Python is not just a programming language. Python's versatility and extensive libraries make it the top choice for data analysis. It's a powerhouse that can transform raw data into actionable insights, helping you make smarter decisions, predict trends, and even innovate with AI. So, welcome to this video, which is going to be your go-to resource if you want to master Python for data analysis. In 2024, data is being more powerful than ever, and Python is the key to unlocking its full potential. So, in this video, we will first introduce you to Essentials, NumPy for numerical computing, Pandas for data manipulation, and Matplotlib and SeaBorn for creating stunning visualizations. We will also introduce you to Scikit-Learn for machine learning basics and SciPy for scientific computing, including installation and the must-know SciPy packages. But that's just the beginning. We will dive into advanced topics like Anomaly and Outlier detection to refine your analytical skills. And to make your learning experience truly practical, we have lined up 3 exciting Python projects for you in this video. Before introducing you to generative AI and the tools that are reshaping the future of data analysis, by now you know this isn't just another tutorial. It's a complete journey into Python for data analysis, packed with actionable insights and real-world applications. So get up and watch this video till the end while we turn you into a data analysis expert with Python.
Now we'll start off with this library called as NumPy, which stands for Numerical Python. And as it is stated over here, it is the core library for numeric and scientific computing. So whatever numeric or scientific calculations you'd have to perform, NumPy should be your go-to language. And this library called as NumPy consists of multi-dimensional array objects and a collection of routines for processing these arrays. So let's go ahead and create our first NumPy array. So you can have a single dimensional NumPy array or a multi-dimensional NumPy array. Now we'd have to start off by importing this library. So to import NumPy, we'll type in import NumPy as NP. So this NP which you see over here is known as the alias. So we are importing the library NumPy with this alias NP. Now this NumPy library has a lot of methods, and one method is called the array method. And with the help of this, we will be able to create the NumPy array. All we have to do is type in np.array, and inside this I am passing in the list of values starting from 10 going on till 40, and I'll store it in this object called as n1. And when I print it out, I get the result 10, 20, 30, 40. Similarly, I go ahead and create a multi-dimensional array. So here we are passing in a list of lists. So here we had a single list. Here we are passing in a list of lists. So as you see, we have a list over here, and inside this we have 2 more lists. The first list comprises of the elements 10, 20, 30 and 40, and the second list comprises of the elements 40, 30, 20 and 10. And when I print it out, this is how I get this multi-dimensional array. The first list is present in the first row and the second list is present in the second row. Now let me go to Jupyter Notebook and implement these two. Let me just add a comment over here. I'll name it as NumPy. Now I'd have to import the NumPy library. So I'll have import NumPy as NP, and let's just wait till this library is loaded. Now that this is loaded, I can go ahead and create the NumPy array. So for this, I'll have to use np.array, and inside this I'll be passing in a list of values. So I'll pass in 10, 20, 30 and 40, and I'm storing it in this object called as n1. Now let me print out n1 over here. And as you guys see, I have successfully created this NumPy array, which over here the values are 10, 20, 30 and 40. And just to be sure, I'll go ahead and check the type of this NumPy array. So I'll have type. Inside this, I'll pass in n1, And as you guys see, we get the result numpy.ndarray. So ndarray stands for n-dimensional array. Now we'll go ahead and create a multi-dimensional array over here. So to create a multi-dimensional array, we'd have to pass in a list of lists inside this np.array method. So I'll have this outer list. Inside this, I will create two lists. So the first list, let's say, comprises of the elements 1, 2, 3 and 4. And the second list comprises of the elements 4, 3, 2 and 1. Now I'll just print out n2 over here. And I have created this multi-dimensional array where all of the elements from the first list are present in the first row and all of the elements from the second list are present in the second row. Now that we have created these NumPy arrays, we'll now see how to create or how to initialize a NumPy array with different ways. So now let's say if I want to initialize a NumPy array with only zeros, then we have a method called as zeros. It's very intuitive, isn't it? So here we are importing the NumPy array, then we are using np.zeros and it takes in two parameters. So these two parameters basically indicate the dimensions of the NumPy array. So if I want to create a 1 cross 2 NumPy array where all of the values are zeros, then I can just go ahead and type in np.zeros and inside this I'll pass in the dimensions, which is 1, 2, and I get a 1 cross 2 NumPy array where the values are only zeros. Similarly, over here, I am creating a 5 cross 5 NumPy array where all of the values are zeros. So I'll just use np.zeros and inside this I'll pass in 5, 5. Now let me go ahead and implement this in Jupyter Notebook. Here I'll add the comment np.zeros. Now I'll go ahead and let me just create this in n1, and inside n1 I'd have to use the np.zeros method, and over here I'd have to pass in the dimensions. So the dimensions would be 1, 2, and let me go ahead and print out n1 over here. So as you guys see, I have successfully created this NumPy array. Now if I want maybe a NumPy array with a different dimension, so the method would be the same. I'll have np.zeros over here, and inside this, let's say I want to create a 3 cross 3 NumPy array which consists of only zeros, and this I'll go ahead and store it in this object called as n2. Now let me print out n2 over here, and we have a 3 cross 3 NumPy array which comprises of only zeros. Now if I want to initialize a NumPy array with the same number, then we can go ahead and use the full method. So here I am using np.full, and this takes in two parameters. The first parameter is the dimension of the NumPy array. The second parameter is the value which we'd want to insert into this NumPy array. So here we are creating a 2 cross 2 NumPy array where the value is filled with 10. So as you guys see, it's a 2 cross 2 NumPy array where we only have 10s. So it's time for np.full. I'll just type in np.full. I'm adding a comment over here. Then let me add np.full, and I'd have to give in two parameters. Let's say I'd want a 4 cross 8 NumPy array, and I'd want the value 5 inside this. Now I'll store this in this object called as n3, and I'll just print out n3 over here. And as you guys see, I have created a 4 cross 8 NumPy array where the value is only 5. Now similarly, if I want to initialize a NumPy array within a particular range, then I can go ahead and use the aRange method. So here, as you guys see, I am using np.aRange, and this again takes in two parameters. The first parameter is the initial value from which the range has to start. So here when I give in 10, as you guys see, the range starts from 10. And when I give in 20, so here again you'd have to remember that 20 is exclusive, or maybe the second parameter is exclusive. And since this is exclusive, we'll only have values starting from 10 and going on till 19. And that is why 20 is not included in this result over here. Now we can go ahead and add another parameter. So here the initial value is 10, the final value is 50, and we have the skip value. So the skip value is 5, which would mean that after 10 we'll have 15. So 15 plus 5 becomes 20, 20 plus 5 becomes 25, and that is how this keeps on proceeding. Now when we reach 45, when you add 5 more to 45, that becomes 50. And since 50 is exclusive over here, that is why we end at 45. But on the other hand, if we had given the final value as 51, then we would also have the element 50 over here. So let's go ahead and implement aRange method over here. np.aRange, and I'll store this in N4. Now I'd have to use np.aRange, and I'll go ahead and give in the initial value as, let's say, 100. Then I'll give the final value as 200, and I'll print out N4 over here. And as you guys see, we have all of the numbers in sequence starting from 100 going on till 199. Now if I actually want the value 200 to be included in this as well, let me make the final value to be 201. And as you guys see, this time the range starts from 100 and also includes 200 over here. And we can also add a skip value. Now let's say if I give the skip value of 10. So here after 100 we have 110, then 120, and this goes on till 200. Now instead of 201, if I keep the final value as 200, we see that this NumPy array ends at 190 because 200 is exclusive. Now we can also go ahead and initialize a NumPy array with random numbers. And to initialize NumPy array with random numbers, we can use random.randint. So here we are invoking np.random.randint, and over here we have three parameters. And over here we have three parameters. The first parameter is basically, and over here we have three parameters. The first two parameters basically indicate the range from which we would want the random numbers. So we would want the random numbers in this range of 1 to 100. And this third parameter would tell the Python interpreter how many random numbers do we need. So in the range of 1 to 100, we would need 5 random numbers. And as you guys see, this is the result which you get over here. So we have 95, 88, 26, 22, and 76, which are 5 random numbers generated between the range of 1 and 100. I'll add this comment random. Now let's go ahead and initialize a NumPy array with some random numbers. So I'll have np.random.randint because I want a random set of integers, and this will take in 3 parameters. Let's say I would need values between 50 and 100, and I would need 10 random values over here. And let me store this in N5. Let me go ahead and print out N5 over here. And as you guys see, I have 10 random values which are generated between the range of 50 and 100. Now, similarly, if I go ahead and run this again, I'll get a different set of values. As you guys see, we have a different set of values again. When I click this, we again have a different set of values. That was all about initializing a NumPy array with different methods. Now you can also go ahead and check the shape of a NumPy array. And to check the shape of a NumPy array, we have the shape method, which again is very intuitive. So here we are creating a NumPy array where we are passing in a list of lists. So in the first list we have 1, 2, and 3. In the second list we have 4, 5, and 6. So obviously we will have a NumPy array where we'll have 2 rows and 3 columns, and this is what the n1.shape gives us. Now if we want to change the shape of this, then we can use the same method. So here what I'm doing is I'm typing in n1.shape, and I'm changing the shape from 2, 3 to 3, 2. That is, instead of having 2 rows and 3 columns, I will have 3 rows and 2 columns. So this same shape method can be used to check the shape of the NumPy array and also reshape the dimensions of the NumPy array. So let me create a NumPy array over here. So we would have to create a multi-dimensional NumPy array. So this will be n6 is equal to, I'll have np.array, and inside this I'll have to create a list of lists. So in the first list I'll have values 10, 20, and 30. And in the second list I'll have values 40, 50, and 60, and I'm storing this in n6. Now once that is done, let me just print out n6 over here. So you guys can see this NumPy array. Now I'll also go ahead and check the shape of it. So I'll have n6.shape, and we get the result that this is a NumPy array where we have 2 rows and 3 columns. Now I can also go ahead and change the shape of this. So I'll have n6.shape, and over here I am changing the shape to be equal to 3, 2. Then I'll go ahead and print out n6. And as you guys see, we have converted this from a 2 x 3 NumPy array to a 3 x 2 NumPy array. So you had 10, 20, 30 in the first row. We've got 10, 20 in the first row here. So similarly, this is how this has been changed. Then we have some stacking methods over here. We have vstack, headstack, and column stack. So let's just start with vstack. So we are creating a NumPy array n1 where we have the values 10, 20, and 30. Then we are creating the NumPy array n2 where we have the values 40, 50, and 60. Now when we use vstack over here, this again takes in 2 parameters where we'll just pass in 2 NumPy arrays inside this. So as you guys see, we are vertically stacking over here. So when I say vertically stacking, I have one NumPy array on top of another NumPy array. So because I'm using n1, n2, n1 comes at the top, n2 comes at the bottom. So this is how vertical stacking works. Then we can also go ahead and horizontally stack 2 NumPy arrays. So n1 and n2, we've got the same NumPy arrays over here. And instead of using vstack, I'm using the headstack method. I'm passing in n1 and n2. And as you guys see, 40, 50, and 60. So n2 has been stacked horizontally to n1. Then we have the column stack. So if we want to stack these NumPy arrays into separate columns, so we have n1 and n2, and when I'm using column stack over here, as you guys see, n1 goes into the first column, n2 goes into the second column. And this is how we can work with these stacking methods. So I'll have to create these 2 NumPy arrays over here. I'll have n1, which will be np.array, and inside this I'll have 1, 2, and 3. Then I'll also go ahead and create n2. So this will be np.array, and inside this I'll have 4, 5, and 6. So I have my n1 and n2 ready. Now I'll start off with vertical stacking. So I'll use np.vstack, and inside this I'm passing in n1 and n2, and let's see what would be the result. So we have vertically stacked n1 with n2. n1 is at the top, n2 is at the bottom. You can also change how these are stacked. So instead of giving n1, n2, let's say if I give in n2 and n1, you guys would see that n2 is at the top and n1 is at the bottom. Now we can similarly work with the headstack method. So here I'll type in np.hstack, and inside this again I'll pass in n1, n2. And as you guys see, I have stacked n2 at the back end of n1. Now, if I want n2 first and n1 second, I just have to change the sequence. So inside np.headstack, I'll give in n2, n1. And I have 4, 5, 6 first, and n1 is attached at the back end of n2. Then we have column stack. So I'll just have np.column stack over here, and inside this I'll pass in n1, n2. And as you guys see, I have n1 in the first column, n2 in the second column. Similarly, if I give in n2, n1, you will see that I have n2 in the first column and n1 in the second column. So this is all about stacking the NumPy arrays. Now we'll also work with intersection and difference methods. So here again we have 2 NumPy arrays. So in the first NumPy array we have the values from 10 to 60, and in the second NumPy array we have the values from 50 to 90. And if I want the common elements between these 2 NumPy arrays, then I can use the intersect 1D method. So here in the intersect 1D method, I would just have to pass in these 2 NumPy arrays. And as you see in the result, we get a new NumPy array comprising of the common elements in these 2 NumPy arrays. Then over here I have n1 and n2. If I want to find out all the elements which are unique to n1, then I can use the setDiff1d method. So here in n1 we have the elements starting from 10 going on till 60. In n2 we have elements starting from 50 going on till 90. So here, as you guys see, 50 and 60 are common in n1 and n2. And if I want the elements which are unique to only n1, then I would have to use setDiff1d and I'll pass in n1 and 2. As you guys see, I get only 10, 20, 30 and 40 because 50 and 60 are present in both the NumPy arrays. I can also change the sequence over here. So instead of passing in n1, n2, when I pass in n2, n1, then this will give me all of the unique elements which are present in n2. And since 50 and 60 are common in both the NumPy arrays, the resultant will be 70, 80 and 90 because these are the only unique elements in n2. So let's go ahead and work with intersect1d and setDiff1d. I'll just add a comment over here, intersect1d, and I would have to create two new NumPy arrays. I'll have n1 over here. So I'll have np.array and inside this I'll pass in 1, 2, 3, 4, 5, 6 and I'll have n2 and inside this I'll go ahead and create a list of elements where the elements start from 5, 6, 7, 8 and 9. So I have these two set over here. Now that my two NumPy arrays are ready, if I want to find out the common elements which are present in these two NumPy arrays, I'd have to use intersect1d. So I'll have np.intersect1d and inside this I'm passing in n1, n2 and when I hit on run, we see that the common elements between n1 and n2 are 5 and 6. Now, if I want only the elements which are common to n1, then I can use the setDiff1d method. So here I'll have np.setDiff1d and inside this again I'll be passing in n1, n2 and as you guys see I have 1, 2, 3 and 4 which are common to only n1. Now similarly, if I want all of the elements which are only common to n2, then I can have np.setDiff1d and I'll just change the sequence over here. Instead of passing n1, n2, I'll have n2, n1 and the only unique elements which are there in n2 are 7, 8 and 9. Now we'll go ahead and perform some simple NumPy array mathematics. So we'll see how to add two NumPy arrays. So again over here we have two NumPy arrays. In n1 we have 10 and 20, in n2 we have 30 and 40. Now if I want the total sum of all of the elements which are present in both of these two arrays, I can just directly use the sum method. So I'll have np.sum and inside this as a list I'll pass in n1, n2 and you will see that the resultant value would be 100 because 40 plus 30 plus 20 plus 10 is equivalent to 100. Now, if I want to find out the individual sum along the rows and along the columns, then I can use the additional parameter called as axis. So if I want to sum the values along the column, then I'll set the axis to be equal to 0. So when I have the axis value to be equal to 0, as you guys see, I have 30 plus 10 equal to 40 and 40 plus 20 equal to 60. Similarly, if I want to sum these up along the rows, then I'll set the axis value to be equal to 1. And over here I have 10 plus 20 equal to 30 and 30 plus 40 equal to 70. I'll add a new comment over here, addition of NumPy arrays. And let me create new n1 over here. So I'll have np.array and inside this I'll have 10 and 20. Then I'll go ahead and create n2 and inside n2 I'll again have np.array and over here I'll have 30 and 40. I'd have to pass this on as a list of values. So I'll have 30 and 40 inside a list. So I have created n1 and n2. Now it's time to find out the total sum which is present along all of these. So I would have to use np.sum, and inside this I'll just pass in n1 comma n2, and actually I'd have to pass this as a list. So I'll have n1 comma n2 over here, and as you guys see, the resultant comes out to be 100. If I want to add the values along the column, so I'll have np.sum, then I'll have this list over here, I'll have n1 comma n2, then I'll have this new attribute called as axis, and I'll set the axis value to be equal to 0. And I get the resultant 40 and 60, because 30 plus 10 is equal to 40 and 40 plus 20 is equal to 60. Now going ahead, if I want to add the values along the horizontal rows, so here it will be np.sum, and over here I'll have n1 comma n2 again, and this time I'll set the axis value to be equal to 1, and I have 30 and 70, because 20 plus 10 is equal to 30 and 40 plus 30 is equal to 70. Now we'll see how to do some scalar operations on these NumPy arrays. So here we have a NumPy array where we have values 10, 20 and 30, and if I want to add the scalar value 1 to each individual element of the NumPy array, all I have to do is add this value 1 to this NumPy array, and as you guys see, n1 plus 1 becomes 11, 21 and 31. Similarly, if I want to multiply each individual element of a NumPy array with a particular value, so here if I want to multiply it with 2, I'll just write down n1 into 2. So 10 becomes 20, 20 becomes 40 and 30 becomes 60. And if I want to subtract a value, all I have to do is perform n1 minus 1. So 10 becomes 9, 20 becomes 19 and 30 becomes 29. And if I want to divide it, I'll just have n1 divided by 2. So 10 becomes 5, 20 becomes 10 and 30 becomes 15. So this was some basic idea about NumPy. Now let me just see what is there in n1 over here. Let me actually add some more elements inside this. So I'll have n1 is equal to np.array, and inside this I'll have 10, 20, 30 and 40. Let me also print out n1 over here for your reference. So now that we have n1, what I can do is I will just go ahead and add some scalar values to it. And let's say if I want to add 5 more to each individual element of this NumPy array, so I'll just write down n1 plus 5. And as you guys see, 10 becomes 15, 20 becomes 25, 30 becomes 35 and 40 becomes 45. Similarly, if I want to subtract a value, I'll just write down n1 minus 5 over here. And 10 becomes 5, 20 becomes 15, 30 becomes 25 and 40 becomes 35. We can also go ahead and multiply something to this. So I'll have, let's say, n1 into 10. Let me print this out. And as you guys see, we have multiplied these values with 10. Similarly, I can go ahead and divide this with something. So if I have n1 divided by 10, so we see 10, 20, 30, 40 becomes 1, 2, 3 and 4. So this is some basic scalar operation on top of the NumPy arrays. And we can also go ahead and use some mathematical functions. So we have this mean function over here, which would give us the mean value of all of the elements which are present. So the mean value of all of these elements comes out to be 35. Similarly, if we want to find out the median, then all we have to do is use this median method. We have to use np.median, we'll pass in this NumPy, and we see that the median value comes out to be 55.5. And if you want to find out the standard deviation, I'd have to use std, and I'm passing in n1 inside std, and the value becomes 36.59. So we have n1 over here, and if I want to find out the mean value, I'll just have np.mean, and inside this I'll be passing in n1. And as you guys see, the mean or the average value of all of the elements which are present in n1 comes out to be 25. Let me go ahead and create another NumPy over here. So I'll have np.array, and inside this I'll be passing in some random values. So let's say these are all of the values which are present in n2. And if I want to find out the median of all of the values which are present, so I'll just use np.median method, and inside this I'll be passing in n2. And the median of all of these values comes out to be 5. Similarly, if I want to find out the standard deviation, so here I'll have np.std, and if I want to find out the standard deviation of this particular NumPy array, so I'll pass in n2, and you would see that the standard deviation of all of the elements of n2 would be 2.397. So till now we've worked with some basic NumPy arrays. Now let's go ahead and work with a NumPy matrix. So here we are creating a 3x3 NumPy matrix, and to do that you'll again need a list of lists. So over here we'll have 1, 2, 3, 4, 5, 6 and 7, 8, 9. So this first list goes into the first row, second list goes into the second row, and third list goes into the third row. Now that we have created this NumPy matrix, let's see how can we access individual rows and columns from this entire NumPy matrix. So here, let's say if we want to access the first row, again you'd have to remember that the indexing in Python starts from 0. If we want to extract the entire first row, we'll just have n1 and inside parenthesis we'll pass in 0. And as you guys see over here, I have successfully extracted the entire first row. Similarly, if I want to extract the entire second row, then the index value for second row will be 1, and I have extracted the second row. And if I want to extract a column, then I'd have to do something like this. So in a column, I would want all of the rows. So here from this NumPy matrix, I would want the second column and all of the rows from the second column. So here, since I would want all of the rows, I'll just put in a colon over here, and since I want the second column, I'll give in the index value as 1. And as you guys see, I have extracted the entire second column over here. Similarly, if I want to extract the entire third column, the index value will be 2, and I have extracted the entire third column. Let's perform this in Jupyter Notebook. So I'll just write in NumPy matrix over here. Now that this is set, I'll have np.array, and over here I'll have a list of lists. So in the first list I will have 10, 20 and 30. In the second list I will have 40, 50 and 60. In the third list I will have 70, 80 and 90. And I will go ahead and store this in n1 again. Now I'll go ahead and print out n1, and let's see what would be the result. So this is our NumPy array which we have just created. Now if I want to access individual rows from this, I'll have to give in n1, and inside parenthesis, let's say if I want to extract the third row, then the index for the third row will be 2. I'll just have 2 over here. And as you guys see, I have successfully extracted the entire third row. Now similarly, if I want to extract the entire third column, then this time I would have to write n1, and over here, since I would want all of the records from the third column, so I'll just have a colon over here, then over here. So here you'd have to understand whatever is given on the left side of the symbol would indicate rows, and whatever is given on the right side of this comma would indicate all of the columns. So I'd want all of the rows, and all of these rows need to be from the third column, and the index for the third column is 2. And I have successfully extracted all of the elements which are present in the third column. Now we'll see how to transpose a matrix. So what is transposing? Transposing basically means when you're interchanging the rows and columns. So here, as you guys see, we have 1, 2, 3, 4, 5, 6 and 7, 8, 9. Now the rows would be interchanged with the columns. So here 1, 2, 3 which is present in the first row comes into the first column. 4, 5, 6 which is present in the second row comes into the second column. 7, 8, 9 which is present in the third row comes into the third column. Let's go ahead and perform transpose as well. So all I have to do is use np.transpose, and inside this I'll just pass in n1 over here. So as you guys see, initially I had 10, 20, 30 which was in row. This became in column. 40, 50, 60 was in second row, became the second column. 70, 80, 90 was the third row, which became the third column over here. Now we'll see how to perform two matrices. So over here we have n1 where we have the elements starting from 1 going on till 9. Then we have n2 where we have elements starting from 9 going on till 1. Now if we perform the dot operator on this, which is basically matrix multiplication, this is how the multiplication happens. So the multiplication is row by column, which would basically mean, so here we have 1, 2, 3, here we have 9, 6, 3. So it will be 1 into 9 plus 2 into 6 plus 3 into 3, which will give you a result of 30. Then again we'll have row by column. So here it will be 1 into 8 plus 2 into 5 plus 3 into 2, which will give you a result of 24. Then it will be 1 into 7 plus 2 into 4 plus 3 into 1, which will give you a result of 18. And this is how this progresses, and finally we'll get this result over here. And the dot product of n1 into n2 and n2 into n1 will be different. So as you guys see, this is the dot product of n1, n2, and this is the dot product of n2, n1. Both of these will be different. So I already have n1 over here. Let me go ahead and also create n2. So here I'll write n2 is equal to np.array, and over here I'll have the elements in reverse order. So I'll have 90, 80, and then I'll have 70. Going ahead, I'll have 60, 50, and 40. After this, I'll have 30, 20, and 10, and I am storing this in this object called as n2. Let me also go ahead and print out n2 for you guys over here. So this is what we have. Now if I want to perform the dot product, so I'll have n1. I'll actually have, if I want to perform the dot product here, I'll have n1 dot dot. Inside this, I'll pass in n2. And as you guys see, this is the dot product of n1 cross n2. But we know that n1 cross n2 and n2 cross n1 is different. So when I perform n2 dot n1, the result will be different from n1 dot n2. So this was about matrix multiplication. Now we'll go ahead and see how can we actually save a NumPy array and then load it from somewhere else. So here we are creating this NumPy array where we have elements from 10 to 60. Then to save this NumPy array, we just have to use the save method. And over here we are saving this NumPy array with this name called as my_NumPy. So this takes in two parameters. First parameter is the name by which we'd want to save this NumPy array. Second is the array which we'd want to save. Now once that we save this, to load this NumPy array, we will have to use np.load, and over here we'd have to give in the name by which we save this NumPy array. So we save this NumPy array as my_NumPy, and we'd have to give the extension which is .npy, which basically stands for NumPy, and we go ahead and store this in n2 and we print out n2. We see that we have successfully loaded this NumPy array over here. Now I'll go ahead and save this. So I'll have np.save, and this, as we have seen, takes in two parameters. The first parameter is by which I save this. So I'll have save n1, and I would want to store n1. So I have saved this. Now if I want to load this, I would have to use np.load, and over here I'd have to give the name of the NumPy array. So it will be save_n1.npy. Let me actually remove this over here, and I will store this in, let's say, n9. Let me click on run over here. So we have an error over here. We have this error because I'd have to give this inside single quotes. Now if I click on run, we'll get the result. Now if I print in n9 over here, we finally get the result. So Pandas stands for panel data and is the core library for data manipulation and data analysis. So if you want to perform any sort of data analytical task, Pandas should be your go-to library. And Pandas provides single and multi-dimensional data structures for the purpose of data manipulation. So the single dimensional data structure is known as the series object, and the multi-dimensional data structure is known as the data frame. We'll start off by understanding about the series object. So series object is a one-dimensional labeled array. So we have already worked with the NumPy array. So in NumPy array, we had no labels along with it. It was just a simple blank array where we had stored some values. But over here in a series object, as you guys see, we have labels, or you can consider them to be indexed with labels over here for these. So first we'd have to start off by importing pandas, which is the library, and we are giving this alias as PD. So import pandas as PD. Then if we want to create a series object, will have pd.series, and inside this I am passing in the values 1, 2, 3, 4 and 5. And when I print it out, I get this series object. So when I check the type of this, type of S1, this gives me pandas.core.series.series. Now over here, you'd have to keep in mind that S is capital over here. So if you're given a small s, you will get an error. So let's go ahead and create our first series object. So I'll just add the comment pandas. Now our first task would be to import the pandas library. So I'll go ahead and type in import pandas as pd. Let's just wait for this to be loaded properly. Now that we have loaded the library, I can go ahead and create the series object. So I'll type in pd.series where s is capital. Inside this, I'll pass in the list of values. So let's say I'll just have 10, 20, 30, 40 and 50, and I'll go ahead and store it in this object called as S1. Let me print out S1 over here, and as you guys see, I have created this series object. Let me also check the type of this. So inside the type method, when I pass in S1, you guys would see that this is a series object. And over here, we have the labels. So the labels are 0 to 4. So by default, the label or the index starts with 0 over here. So 10 is present at label or index 0, 20 is present at index 1, 30 is present at index 2, and that is how it proceeds further. Now, since we have labels in a series object, we can change how the label of the index looks like. So over here, we just had numbers starting from 0, but instead of numbers, let's say if I wanted alphabets over here, then I can add a new attribute called as index. So over here with this index attribute, I am setting the values to be equal to A, B, C, D, E. So here initially we had index 0, 0 has been changed to A. Then we had 1, 1 has been changed to B. We have 2, 2 has been changed to C, and that is how it proceeds. So now over here, let me go ahead and change these index values. So it is the same command over here. And with this same command, all I'm doing is adding a new attribute called as index. And I'll pass in a list of values for the indices. So I'll have A, B, C, D. Let me have D over here, and I'll have E. Now, when I click on run and I print out S1 over here, you guys would see that I have changed the indices from 0 to 4 to A to E. Now we can go ahead and see how to create a series object from a dictionary. So we have already worked with dictionaries. We know that the dictionary is a key value pair. So here we'll just give in pd.series, and over here we have 3 key value pairs. A10, B20, C30. So here automatically the keys are taken as the labels, and these values are taken as the series values over here. Let me create a new dictionary. So I'll have D1, and inside D1, let me have 4 key value pairs. Maybe I'll have A and 10. Then I'll have B and 20. After that, I'll have C and 30. Going ahead, I'll have D and 40. Now I'll just go ahead and print this out. As you guys see, I have successfully created this dictionary. Now I would have to create a series object out of this. So I'll just have pd.series, and inside this I'll pass in D1, and let's see what would be the result. So these 4 keys which were present became the labels, and these values over here in the dictionary became the series values as well. Now we can also go ahead and change the index position. So similarly, as we had actually changed the index values from numerical to alphabetical. So when I given the index values as B, C, D, A, this sequence is maintained. So I have B and C first. So for B, I have the value 20, C, I have the value 30. And D, we had not created any key with this particular index. So that is why we have NaN over here. And then we have A, for which we have the value 10. So this is how we can maybe add a new index position or change the existing index positions. So this is what we had over here. This was our series object. And now what I'd want to do is So instead of A, B, C, D, I would want, let's say, C, B, A, and D. And if I click on run, you guys see that the sequence has changed over here. Now we'll also see how to extract individual elements from the series object. So here we have all of these elements starting from 1 going on till 9. And again, you'd have to keep in mind that the indexing starts from 0. So if I want to extract this particular element over here, so the index value for this would be 3. So 0, 1, 2 and 3. And when I given the index value as 3, I am able to extract this particular element. And if I want to extract a sequence of elements over here, so if I want the first 4 elements, then I'll have S1 colon 4. This would mean that I am extracting all of the elements starting from index number 0 going on till index number 4. And since 4 is exclusive, so that is why we will only have till index number 3. So we'll have index number 1 going on till index number 3. And if you want to extract elements from the back side, here we'll have S1 and we'll type in -3 over here. So -3 basically means third element from the end. Third element from the end, when I give in colon, this would mean third element from the end going on till the end. So this is the third element from the end over here. So that is why I'll have 7, 8 and 9. And this is how I'll be able to extract a single element, a sequence of elements from the beginning and a sequence of elements from the back. And let me just create a new series object over here. So I'll have S1 is equal to pd.series, and inside this I'll pass in a list of elements. I'll have 10, 20, 30, 40, 50, 60 and 70. Now that I have this, let me extract this element which is present at index number 3. So I'll have S1, I'll have parenthesis, then I'll just go ahead and give in the index value. So index value will be 3. And as you guys see, I have successfully extracted this particular element. Now if I want to extract the first 4 elements, then I'll just give in the colon over here and I'll have 4. And as you guys see, I have extracted the first 4 elements. Now if I want the last 3 elements over here, then I'll have S1. Then I'll have colon and I'll type in -3, which would mean the third element from the last going on till the last element over here. And I have 50, 60 and 70, which are the last 3 elements. Now we can also go ahead and perform some simple operations on top of the series object. So if I want to add a scalar value, so initially we had this series object where the number started from 1, went on till 9. And if I just wanted to add the scalar value phi to all of the individual elements which are present in the series object, all I have to do is use plus phi. And as you guys see, 1 becomes 5, 2 becomes 7, 3 becomes 8 and so on. And we can also go ahead and add 2 series objects. Over here I have S1 where the elements are from 1 to 9 and S2 where the elements are from 10 to 90. And when I perform S1 plus S2, this would add the elements which are present at the same index position. So here we'll have 10 plus 1, 11, 20 plus 2, 22, 30 plus 3, 33, and this goes on till the last index position over here. So let's go ahead and perform some basic operations on top of the series object. So I already have S1 over here. And these are the original values which are present in S1. Now I'd want to add 10 more to these existing values. So I'll just type in S1 plus 10. And as you guys see, the values, all of the values which are present in the series object have been incremented by 10. Now also I can add 2 series objects together. So in the series object, I have 7 elements. I'll go ahead and create S2. Where I'll have 7 more elements over here. So I would have to type pd.series and inside this, let me just have 7, 6, 5, 4, 3, 2 and 1. Let me print out S2 for your sake over here. So we have S1 and S2, and when I perform S1 plus S2, this is the result which we get. So 10 plus 7 becomes 17, 20 plus 6 becomes 26, 30 plus 5 becomes 35, and this proceeds to the last index value. So that was all about the series object, which was a single dimensional labeled array. Now we'll work with a data frame, which forms the major part of all of the machine learning data science projects. So what exactly is a data frame? It is a two-dimensional label data structure. And if you'd have worked with SQL or maybe Excel, you would have dealt with tabular data. And a data frame helps you to deal with tabular data in Python seamlessly. So a data frame, because this is a tabular data, consists of rows and columns. Now, let's see how can we go ahead and create a data frame from a dictionary. So to create a data frame, we'd have to use this particular method over here. We'd have to type in pd.dataframe, where D is capital and F is also capital. So by any chance, if you give maybe D as small or F as small, you'll get an error. So both of them have to be in capital case. And over here, I have two key value pairs. So the first key is name, and then we have a list of values which are Bob, Sam, and Annie. Then we have the next key, which is marks. Then we have the list of values for marks, which are 76, 25, and 92. So here, as you see, the keys become the column names and the values become the records over here. So name and marks become the column names, and these values over here, the list of values Bob, Sam, and Annie, which are the values for this key, become the records of this particular column. Similarly, these values are there for this particular key, and these become the records for this particular column. So let me go ahead and create a first data frame over here. So I'll just go ahead and type in data frame. Now to create a data frame, I'd have to type pd.dataframe, and D and F both have to be capital. And inside this, I'll create a dictionary. So to create a dictionary, I would need curly braces. So the first key would be name, and I'll go ahead and give in a list of names over here. Let's say the first name is Sam. Then we have Annie. Going ahead, we have Jennifer. Now, once we have the first key value pair, I'll go ahead and also add their marks over here. So the second key would be marks, and I'll have a list of values over here. Let's say Sam has got 50 marks, Annie has got 60 marks, and Jennifer has got 70 marks. And I'll go ahead and store this in df. Let me print out df over here. And we have created our first data frame, where the column names are name and marks, and the values are these over here. And let me go ahead and also show you guys the type of this object which I've just created. So inside this type method, I'll be passing in df. And as you guys see, this is pandas.core.frame.dataframe, which basically means this is a data frame object. Now that we have created our first data frame, we'll perform some basic functions on top of a data frame. We've got head, tail, shape, and describe. So we'll just implement all of these. Now to implement this, we will be performing them on a dataset called as the iris dataset. Now to read any CSV file, we have a method called as pd.read_CSV. So here I'll have pd.read_CSV, and inside this I'll give in single quotes and given the name of the file. So the name of the file will be iris.csv, and I'll go ahead and store this in a new object called as iris. Now let me hit on run. Let me check the first 5 records which are present in this iris data frame. So if I want to check the first 5 records which are present in this iris data frame, I need to use the head method. So iris.head, as you guys see, I have the first 5 records. So this iris data frame comprises of 5 columns, which are sepal length, sepal width, petal width, and species. And we'll have 3 different species, which would be Setosa, versicolor, and virginica. So this is how we can work with the head method. Now, similar to the head method, we would also have the tail method, which would give us the last 5 rows which are present in a data frame. So here I'll type iris.tail, and when I click on run, you guys would see the index value over here. The index value starts from 145 and goes on till 149, because there are 150 records in this iris data frame. So we have extracted the last 5 records and we have printed it onto the console. Then if you want to check the number of rows and number of columns which are present in this iris data frame, we can just use the shape method. So here I'll have iris.shape, and as you guys see, this gives us a dimension value of 150, 5, which means there are 150 records and 5 columns. Then we'll have the describe method. So here I'll have iris.describe. And now when I click on run, we have all of these numerical quantities over here. So let's say if I want to find out what is the minimum value which is present in the sepal length column. The minimum value present in this sepal length column will be 4.3. Similarly, what is the maximum value in sepal length column? It will be 7.9. What is the mean value? It will be 5.84. So these are some interesting metrics which we can find out with the describe method. So now that we know this, let's actually see how can we extract individual records or individual columns from a data frame. So for that purpose, we can use the .iloc and loc methods. So let's start off with the .iloc method. So .iloc method, with the help of it, we can extract rows and columns on the basis of index. So here iloc basically stands for index location. And over here, as you see, I have a comma, and on the left side of the comma, that would indicate all of the rows, and the right side of the comma, that would indicate all of the columns. So from this entire iris data frame, I am extracting the first three records. So here, the rows would be 0 to 3, and 3 is exclusive over here. That is why I'll have the records where the index values are 0, 1, and 2. And similarly, the columns would be 0 to 2, which would mean the column which is present at index 0, which will be sepal length, and the column which is present at index 1, which is sepal width. 2 again over here is exclusive. So let me go ahead and extract some rows and columns with this iloc method. So we already have this iris data frame with us. Let me again print out the head for you guys so that will be easier for you to have a glance at this. Now let's say from this entire data frame, I would want the records from index number 30 going on till index number 40, and I would want the columns which are present at maybe index number 3 and index number 4. So index number 3 will be 0, 1, 2 and 3. This is index number 3, this is index number 4. So here I'll have index number 3 going on till the end because this is the last column. Let me print this out and show you guys the result. As you guys see, I have extracted all of the records starting from index number 30 going on till index number 39, and the columns which you see starts from index number 3, which is this particular columns index, and goes on till the end over here. So this is how we can extract individual rows and columns with the .iloc method. Now we have the .loc method. So instead of giving the column index, if I want to extract columns on the basis of their names, then I can go ahead and use the .loc method. And over here, when it comes to rows, you see that I've given 0 to 3. Here, when it comes to .loc, you'd have to keep in mind that 3 is inclusive. This is the only case where maybe you will find that the final value over here is inclusive. So when I given 0 to 3, you will get all of the records starting from index number 0 going on till index number 3, which is also inclusive. And over here I'm giving in the column names which are sepal length and petal length, and that is what I'm extracting over here. So I have this iris data frame, then I'll just go ahead and use this .loc method. Now from all of these records, let's say I'd want all the records starting from index number 10 going on till index number 20, and the columns which I'd want to extract are sepal length and petal length. I'll just have sepal.length over here, and the next column which I want would be petal.length. Let me hit on run, and as you guys see, I have all the records starting from row number 10 going on till row number 20, and 20 is also inclusive over here. And the columns which I've extracted are sepal length and petal length. Now we'll see how to drop a particular column. So many a times it would happen that not all columns which are present in a data frame are important. So from this entire data frame, if we want to drop a particular column, then we can just go ahead and use the drop method. So here I'll have iris.drop, and I am dropping or removing the sepal length column from this entire data frame. So here, when I set the axis value to be equal to 1, this would basically mean that I am dropping a column. So if you want to drop a row, then you'd set the axis value to be equal to 0. And if you want to drop a column, then you'd set the axis value to be equal to 1. So if from this entire iris data set, again I'll show you guys the head of this so that you guys can have a glance at all of the columns which are present over here. So from all of the columns, if I want to drop the species column, all I have to do is type in iris.drop, and inside this I'd have to give in the name of the column, which would be species, and I'd have to set the axis, which will be equal to 1 because I'm dropping a column. And as you guys see, I have successfully dropped the species column from this entire data frame. Now similarly, if I want to drop some particular rows which are present in this data frame. So here, as you guys see, the index value, it starts from 0, goes on till 4 over here. But if I want to drop the row indexes of 1, 2 and 3. Here, as you guys see, I have two parameters. First parameter, I'll give in a list of all of the indices that I'd want to drop. So I'd want to drop the index value 1, index value 2 and index value 3, and the resultant which you see over here, after 0 we directly jump on to the index number 4. So now from this entire data frame, this what you see over here, I'll just use iris.drop, and I would want to drop the index values of 1, 2 and 3, and I'll set the axis to be equal to 0. And when I hit run, you would see that after 0, we are directly jumping onto index number 4. So this is a very simple example of how to drop some records and how to drop some columns from your data frame. Now we'll go ahead and work with some simple pandas functions. So from the iris data frame, if I want to find out the mean values of all of the columns, I can just go ahead and use the mean method. Similarly, if I wanted the median values of the records of all of the columns, then I'll just go ahead and use the median method. Similarly, if I wanted to find out the minimum value, I'll use the min method. And if I wanted to find out the maximum value, I will use the max method over here. So very basic operations. So when I use iris.mean, this would give me the average values of all of the columns. So average sepal length of the entire data frame is 5.8. Average sepal width is 3.05. Average petal length is 3.75 and average petal width is 1.19. Similarly, if I want to find out the minimum value of all of the columns, so I'll have iris.mean, and this will give me all of the minimum values. And if I want to find out the maximum values, I'll just go ahead and type iris.max, and this would give me the maximum value of all of the columns over here. So I've got the mean value, the minimum value, the maximum value, and I can also find out the median value. So I'll just type in iris.median, and when I click on run over here, this would give me the median values with respect to all of the columns which are present. Now we will get on with this library called as Matplotlib, which is mostly used for data visualization. And with the help of this library, we can create stunning plots such as bar plots, scatter plots, histograms, and a lot more. So we'll start off by creating our first plot, which will be a line plot. So we would require two libraries over here. The first library would be NumPy, because we would want to create our data with this NumPy library. Then we would import this PyPlot submodule from this Matplotlib library. So we'd have to type in from Matplotlib import PyPlot as PLT, and the alias which I'm giving for PyPlot is PLT. Then I'll create two NumPy arrays over here. The first NumPy array will be X, and I'm creating this NumPy array with the help of this np.aRange method, and the range will be from 1 to 10. And then I'll create the next NumPy array, which is basically 2 times of X. So all I have to do is multiply X with 2, and then I'll get Y. So here we have 1, we have 2. 2 becomes 4, 3 becomes 6, and this is how it proceeds. Now once we create the data, all we have to do to create a line plot is use this plt.plot. So we'll have the plot method in this PyPlot module. So this takes in two parameters, which are X and Y. So we have already created our data X and Y. So X will be plotted on the X axis, Y will be plotted on the Y axis. And as you guys see over here, X goes from 0 to 10 and Y goes from 1 to 20 over here. And we see that there is a linear relationship between x and y, or in other words, as the value of x increases, the value of y also correspondingly increases. So let's go to Jupyter Notebook and create our first line plot using Matplotlib. So I'd have to start off by importing the required libraries. So I would need NumPy. Here I'll type import NumPy as np. And after this, I would also require Matplotlib. So I'll type from Matplotlib import pyplot as plt. Let me write the spelling properly over here. And once I've imported these two libraries, I'd have to create the data. So first I'll have x, and this I'll be creating with np.aRange, and the range will be from 1 to 10. Since I want the numbers from 1 to 10, I'd have to give the value 11 because 11 will be exclusive over here. Then let me just go ahead and print out x for you folks over here. As you see, we have the numbers starting from 1 going on till 10. Now, if I have to create y will just be 2 times of x. So here I'll have 2 into x, and then let me print out y for you folks over here. And as you guys see, this is all of the elements are just 2 times of the elements which are present in x. Now, since I have to create a simple line plot, I would have to use plt.plot, and this would take in 2 parameters which are x and y. So this data would be plotted onto the x-axis, this data would be plotted onto the y-axis, and I'll just show this as a result. So as you guys see, we have this object x mapped on the x-axis, this object y mapped on the y-axis, and this is the corresponding line plot. Now that we have created this, we can also add the title x label and y label. So we'd have to use this title method. So we'll have plt.title, and inside this we'll give the title as line plot. Similarly, we can also add x label and y label by using these two methods, and as you guys see, we have added these two labels over here. So let me add the title x label and y label plt. So I'll copy this entire code over here and then I'll paste it over here. Now after this, I'd have to add the title. So for that, I'll use plt.title, and I'll just give the title as first line plot. Then I'll have x label. So here I'll have plt.x label, and here I'll give the x label as x-axis. Then I would have the y label. So plt.y label, and inside this I'll give the y label as y-axis. Let's run this and wait for the results. So as you guys see, initially this was just a bland plot without the title and the x and y-axis labels. Now with the help of these 3 methods, we have added the title, the x-axis label, and the y-axis label. Now we can also go ahead and change some more attributes with respect to this line plots. So we have color, line style, and line width. So initially, as you see over here, the color of this line by default is blue. But if I don't want the blue color and if I want some other color, then I can just use this color attribute and assign it a new color. Since I'm giving it a value of G, which basically means green color, and as you guys see, this is a green color. Similarly, we have this next attribute called as line style. So initially we have a solid line, but instead of a solid line, if I want a dotted line, then I can go ahead and use a colon over here. And as you guys see, we have a dotted line right now. And by default also the line width is 1. So we can go ahead and increase or decrease the line width. So here we are setting the line width to be equal to 2. And this is the final result which we get. So let's go ahead and add some color, line plot, and line width. I have the same code over here. Now what I'd have to do is add in some color. So I'll have this attribute called as color, and I'm setting, let's say I'll give it orange color to this. Now I would have to change the line style. So I would want a dotted line instead of this solid line. So I'll give in a colon over here, and I'll also change the line width. So I'll give the line width as 3. So as you guys see, initially this was the line which we had, but now I have changed it to this. So from blue, we have converted it to orange. From a solid line, we have converted it to a dotted line. And also you see that this is a thin line and we have increased the width of this line by 2 points. Now we have only created one line in one plot, but we can also have two lines in the same plot. So for this purpose, I'll have two y variables. So x variable will be the same, which will be the numbers starting from 1 going on till 10. But I'll have two y variables, y1 and y2. y1 is 2 times of x, y2 is 3 times of x. So now that we have y1 and y2 ready, I'll have to make two plots because I want two line plots in the same graph. So first I'll have plt.plot, and this line will be between x and y1. So this first line which you are making, it will be between x and y1. And for this particular line, I'm setting the color to be equal to green, the line style to be equal to, so this will be a dotted line. Then we'll set the line width to be equal to 2. Then we'll have our next line, which will be between x and y2, and the color of this line will be red, and this will be a dashed line, and we are setting the line width to be equal to 3. Then again we have the title, x label and y label, and we also have this new method called as grid. So in the earlier plot, as you guys see, we don't have any grid over here, but when we set plt.grid to be equal to true, we'll have a grid as well. And this is the resultant line which we get. So here we have the green line over here, which is this dash line. Then we also have this next line over here, which is between x and y2, and this is the line. And since I've also set the grid to be equal to true, we also have a grid over here in this particular graph. So I'll go back. We already have x. Now let me just print out x for you guys over here. These are all of the numbers which are present in x. Now y1, I'll set it as 2 times of x, and then I'll have y2, which will be equal to 3 times of x. So I have y1 and y2 ready. Now after this, I would have to make a plot between x and y1. So I'll have plt.plot, and onto the x-axis I'll obviously have x, then onto the y-axis I'll have y1, and the color for the first line I'll have green, and let's say the line width, I'll set this to be equal to 2. Then I'll have the next line which will be between x and y2. So here I'll just write down x comma y2, and for this line I'll set the color to be equal to red, and I'll change the line width over here again. So I'll set the line width to be equal to 5, and I would just have to print it out. So it will be plt.show, and I would also want a grid over here. So before this I'll set plt.grid, and I will set this to be equal to true. Let's hit run, and as you guys see, I have two lines in the same plot. Now in the earlier example, we had two lines in the same plot, but if we actually want two subplots itself, that is, as you guys see over here, this is one subplot, this is one subplot, and this line is present in the first subplot, this line is present in the second subplot. So this is also something which we can create. So first we have x, y1 and y2. So these would be the same variables. Once we have our variables ready, we would have to use the subplot method. So we'll have plt.subplot, and inside this I am passing in 1, 2, 1. So here 1, 2 basically means that I would have two plots over here, and those two plots would be present in this way. So I'll have one row, two columns. As you guys see, I have one row and two columns. So this is column number 1, column number 2, which are present in the same row. Then I will give in the index of this subplot. So this is index number 1. And for this first index, this will be the plot which we'll be creating. So for the first index, the plot will be between X and Y1, color will be green, line style will be dotted, and line width will be 2. And as you guys see, at index number 1, we have this green colored line between X and Y1. Then we'll have plt.subplot, which is our next subplot, and the first two parameters will be the same. The third parameter here will set the index value, which is 2. So this is what we'll be getting over here. And the second index will have the line plot between X and Y2, and the color, as you see, is red, line style is dotted, and line width is equal to 2. Then we'll just go ahead and print it out. So we already have X, Y1 and Y2 ready with us. Now after this, we would have to start off by creating a subplot. So here I'll have plt.subplot, and I'd have to give in the dimensions over here. So I'll have 1, 2, 1. So I'm creating my first subplot over here, plt.plot, and this plot will be between X and Y1, and I'll set the color to be equal to yellow. Then after this, I'll go ahead and create the second subplot, and the first two parameters will be 1 and 2 because I'd want these two plots along the columns, and I'll set the index to be equal to 2. Then I'll have plt.plot, and the next plot will be between X and Y2, and over here I am setting the color to be equal to orange. Then I can just go ahead and show you guys the result. So as you see, I have two subplots over here. The first subplot is between X and Y1, and the color of this line is yellow. The next subplot is between X and Y2, and the color of this line is orange. Now, if I want the subplots along the row and not along the column, that is also I can set. So all I have to do is make this change over here. I'll set this to be equal to 2, 1. And similarly over here, I'll make this to be 2, 1, which means that I will have the plots along the rows. I'll have 2 rows and only 1 column. When I hit run, as you guys see, I have 2 rows and only 1 column. This is the first subplot. This is the second subplot. So that was a line plot which helped us to understand the relationship between two numerical entities. So whatever we mapped onto the x-axis was a numerical entity, and whatever we mapped onto the y-axis was also a numerical entity. Now we'll go ahead and work with something known as a bar plot, which would help us to understand the distribution of a categorical column. So for this, we are creating a dictionary called as student, and it comprises of 3 key value pairs. We have Bob 87, Matt 56, and Sam 27. Now we'll go ahead and extract the names and values individually. So the names of these students are basically the keys. So I'll have student.keys, which will give me all of these keys, and I'll go ahead and convert these keys into a list. So I'll pass this into this list method, and I'll store the result in this names object. Similarly, I'll extract all of the values, I'll convert all of the values into a list, or I'll store all of the values into a list, and I'll store that list in this object called as values. So I've got names, I've got values, and to create a bar plot, all I have to do is use plt.bar, and this takes in 2 parameters. The first parameter will have the categorical values, the second parameter will have the numerical values. Since the first parameter comprises of the categorical values, I'll pass in names over here, and the second parameter will be the values. And as you guys see over here on the x-axis, I have the names, which are Bob, Matt, and Sam, and on the y-axis, I have the corresponding values. So we see that Bob has scored the highest marks, followed by Matt, followed by Sam. Now, since we are creating a bar plot, I'll just add this comment bar plot over here, and I'd have to create a dictionary so that we get the data for this bar plot. So I'll name this dictionary as student, and we can create a dictionary with these curly braces over here. So I'll have the first student, who is Bob. Let's say Bob has scored 45 marks. Then we'll have the second student, Sam, and Sam has scored, let's say, 97 marks. Then we'll have Matt, and let's say Matt has scored only 23 marks. So we've got 3 key value pairs. Now that this is done, I'd have to extract the keys. So I'll type in student.keys and I will convert this into a list. So I'll cut this, I'll put this inside the list, and I will store this in a new object called as names. Now that I have names of all of the students, I'll go ahead and also extract marks of all of the students. So I'll store that in this object called as values. I'll have to convert the result into a list, and inside this I would basically have to extract all of the values. So it'll be student.values. I have names and values ready, and to create the bar plot I would just have to use plt.bar. The first parameter will be names and the second parameter will be values. Then I can just go ahead and show out the result. So we have Bob, Sam and Matt mapped on the x-axis and their corresponding values, and we see that Sam has the highest marks and Matt has the lowest marks. And now the plot which we had created earlier was very bland, and we can go ahead and add the title, x label and y label to it, and also assign a grid. So we'll be using the same methods. To add the title, we'll have plt.title, and to add the x label and the y label, we'll be using plt.xlabel and plt.ylabel, and we'll also set the grid to be equal to true. I'll copy these two set of commands over here, and I would have to set the title. So here I'll have plt.title and I'll set the title to be equal to marks of students. Then I'll have something on the x-axis, plt.xlabel, and I'll just have names and the x-axis. Then I'll have something on the y-axis. Here I'll just write down plt.ylabel, and on the y-axis I'll just write down marks, and I would also have to set the grid to be equal to true. So it'll be plt.grid, and here I'll set the value to be equal to true. And as you guys see, I have names on the x-axis, marks on the y-axis, and I've also set the grid to be true. Now after this, we can also create a horizontal plot. So the plot which we had created earlier was a vertical plot. So here we are basically doing two things. So if we have to create a bar plot, we have to use bar h instead of using just bar, and we are adding a color as well. So by default we had the blue color, and if I want to change the color from blue to green, I'll use this color attribute and I'll map the green color to this. Rest everything will be the same. Let me add a new comment over here, which will be horizontal bar plot. Now that I have added this comment, let me go ahead and copy everything. I'll paste it over here, and instead of just having bar, I'll have bar h, and I'll set the color to be red, and we have this bar plot over here. So it's just that we have to interchange the labels. So on the x-axis now we have the marks, so let me keep this as marks, and on the y-axis we'll have names. Let me change this to names, and as you guys see, we have successfully created this horizontal bar plot. Now that we are done with the bar plot, we will head on to the next geometry, which will be a scatter plot. A scatter plot again is used to understand the distribution between two numerical entities, and these entities are represented in the form of data points. So we'll be creating two lists over here. The first list will be storing in X, which basically comprises of the elements starting from 10 going on till 90. Then we'll have the next list A, which comprises of some random elements. And here you'd have to keep in mind that both of the lists have same number of elements, else there'll be an error. And to create a scatter plot, we'll just use plt.scatter. We'll pass this over here, we'll pass this over here as a second parameter, and then we'll just show out the result. Let me go ahead and add a comment over here. So this will be a scatter plot. Now to create this scatter plot, I'd have to create the data. So I'd have to store something onto the x-axis. So in x, I'll just have 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then I'll have y, and in y, I'll just have 9 random numbers over here. So let me just store some 9 random numbers, which is done. Now to create this scatter plot, I'll have plt.scatter and I'll just pass in x comma y, and I would have to show out the result, plt.show. And as you guys see, I have created this scatter plot. Let's start off with this particular point over here. This particular point indicates these two. So I have x, y, which is basically 1 and 5. So this intersection between 1 and 5 is where we'll be getting this point. So I have x, I have y, and this is the point I have. Then I have 2, 2. So the intersection of 2, 2, I'll get this particular point. Then we have this point over here, which is the intersection between 9 and 7. So as you guys see, I have 9 and 7 over here. Now we can also go ahead and add some aesthetics or change the aesthetics of the existing points. So we had same x and a. These are the same list which we have. It's just that we are adding new attributes over here. The first attribute is marker. Initially, we just had solid circles. So instead of having solid circles, if I wanted a star, then with the help of this marker attribute, I'll add star over here. Similarly, to change the color, I'll just have C and I'll assign green to this attribute C. And also I can change the size of this, and to change the size of this, I'll be using S. Let me copy this entire thing. I'll be pasting it over here. So these two will be the same. I'll add this new attribute called as marker, and I'll set the marker to be equal to star, and I'll change the color. Color will be, let's say, I'll have orange again, and I'll have size to be equal to 200. Let me print it out. And as you guys see, this is the result. Just to show you guys what happens if we increase the size. Instead of 200, if I keep it to be 500, you guys see that the size has increased again. Now instead of 500, what happens if I keep it to be 50? You would see that the size of the stars has decreased. Now, as we did with the line plot, where we had two lines in the same graph, we can perform a similar sort of thing over here, where we'll have two different sets of points in the same plot. So for this, we would need a new list. We already have x and a. Then we'll create a new list called as B. Again, we'd have to keep in mind that the elements which are present in this list, or the number of elements which are present in this list, should be equal to the number of elements which are present in A as well as X. Then we'll go ahead and create our first scatter plot by using plt.scatter, and the first scatter plot will be between X and A. And the first scatter plot here, these dots will be represented with stars. Then we'll go ahead and create the second scatter plot, which will be between X and B, and these will be represented with circles. And also we have different colors for both of these scatter plots, and also the size of the different data points will be different. I'll copy this entire thing over here and I'll paste it down. I'll change this to be equal to y1. Then I'll have a y2 as well, and then y2 I would need some bunch of elements over here, random 9 elements. So let me just have some random 9 elements. Let me just check how many elements do we have. So I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these 3 lists are ready. After this, I'd have to go ahead and create the first scatter plot, which will be between X and Y1. Then I'll go ahead and create the second scatter plot, which will be between X and Y2. and I'm not adding the marker because we have already added the marker for the first one. I'll just change the color for this. So the color for second one, let's just keep it to be blue, so I don't have to add the color as well. And I'll change the size of this. So for this, I'll set the size to be equal to 500. So as you guys see, I have two sets of points over here. The first set of point is being denoted by the small stars. The second set of points is being determined by these solid circles. Now, instead of having those set of points on a same plot, we can go ahead and create two subplots as well. So we'll be using the subplot method as we had used during the case of line plots. So here we have these three lists, then I'll have plt.subplot, then we'll have the same three parameters, and since I want these plots to be present column wise and not row wise, I'll have 1, 2, which means that I'll have one row, 2 columns, and then I'll give the index. So at index number 1, we'll have this scatter plot, which will be between X and A. So this is the scatter plot between X and A. Then I'll go ahead and create the next subplot, and the next subplot will be between X and B. I'll copy this entire thing. I'll paste it over here. It's just that I'd have to create a subplot now. So I'll have plt.subplot, and I want these plots column wise. So I'll have 1, 2, 1, and the first subplot will be this. Then I'll go ahead and create the second subplot. So I'll have plt.subplot, and here I'll be writing 1, 2, 2. And this is our first subplot, and this is our second subplot. So that was all about the scatter plot. A categorical column, but when it comes to histogram, we'll be using that to understand the distribution of a continuous numerical column. And we'll be creating this continuous numerical column or continuous numerical data with just a list over here. So this is a very basic example. I'm just creating a random list which comprises of all of these numbers, and I'm storing it in this object called as data. And to create a histogram, all I have to do is use this hist method. So inside plt.hist, I'll pass in this list, and when I show out, this is the result which I get. So here, let's actually have a look at this particular bin. So in a histogram, these are known as bins. So here, for this bin, for the value 3, we have this value 4, or for the value 3 on the x-axis, we have this value 4 on the y-axis, which would mean that this number 3 is occurring 4 times. Similarly, if I look at this 1 over here, so for this 1 on the x-axis, we also have the value 1 on y, which would mean that 1 is occurring only once. Similarly, we have 4. So this number 4 is occurring 2 times. Then we have 8, which is occurring 3 times. So let's go ahead and create a histogram in Jupyter Notebook. I'll just add a comment over here. Histogram. And let me go ahead and create a list. So I'll store this list in L1, and I'll have some random numbers over here. So I have created my list. Now that this is ready, I can just go ahead and build out the histogram by using this method called as plt.hist, and inside this I'll be passing in L1. Then since I just have to show this out, I'll just have plt.show, and this is the result. So as you guys see, this number 3 is occurring 4 times. Then we have this number 6, which is occurring 3 times. And the rest of the numbers are occurring only once. Now we can also go ahead and change the number of bins which are present or the color of the histogram as well. So to change the color, we'll just use this over here. So for the color attribute, we are mapping in G, which will give us this green color. And initially we had 1, 2, 3, 4, 5, 6, 7 bins over here. But instead of 7 bins, let's say if I want to reduce the number of bins, I'll just use this attribute and set the number of bins to be equal to 4, and this is the result which I get. I'll copy this entire thing, I'll paste it over here, Now that I have created this histogram, I would want to change the color of this. So I'll set the color to be equal to green. And instead of, so how many bars do I have? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So instead of having 9 bars, let's say I would want only 3 bars over here or 3 bins over here. I'll set the bins value to be equal to 3. And as you guys see, I have only 3 bins. Now let me set it to be 5, and I have 1, 2, 3, 4, and 5 bins. This was all about histogram. Now the earlier histogram which we had created was with respect to a single list. But if you want to create a histogram on top of a data frame, then let's see how can we do it. So here we'll be building this histogram on top of the iris dataset. So if you have to load any data frame, we'll have to use read_csv since this is a CSV file. So inside read_csv, I am passing in the name of the file and I'll store it in this object called as iris. And when I use iris.head, this will give me the first 5 rows which are present in this data frame. Now after that, to create the histogram, we'll just use plt.hist, and inside this, so here we were passing in the list of numbers, but here instead of passing in the list of numbers, I'll pass in the column. So we have this sepal length column which is present in the iris data frame. So I'll just pass in the sepal length column and I'll set the number of bins, and I'll also set the color to be equal to something. And when I show it out, this will be the result which I'll be getting. So here I'd have to load the iris data frame first. So in the iris object, I'll just have pd.read_csv, and inside this, I'll give in the name of the file which will be equal to iris.csv. I'll click on run. So I'd have to import the pandas data frame as well to use read_csv methods. So I'll have import pandas as pd. And we have, let's just wait till this is loaded, both the library and also the data frame. Now in the while it is loaded, I'll go ahead and write in the head method as well. Now if I click on run, we'll have a glance at the first 5 records which are present in this data frame. And as we see, we have sepal length, sepal width, petal width, and the species column. And now I'd want to create a histogram for, let's see, this petal length column over here. Then I'll just have to type in plt.hist, and inside this I'd have to pass in this petal length column. So here, so I'd given the name of the data frame first, and using this parenthesis, I'll give in the name of the column. So the name of the column, let me keep this to be small, it'll be petal length. And I'll set the number of bins to be equal to, let's say 50. And after that, I'll set the color of the bins to be equal to green again. And we can just go ahead and show out the result. So this should be color and not C. I'll keep it as COLOR. Alright, so as you see, we have successfully created this histogram for this petal length column. Now we'll head on to the next geometry, which is a box plot. So this box plot basically gives us a 5 number summary. So here in this result, what you see, this is the minimum value, this is the 25% value, this is the 50% value, this is the 75% value, and this is the maximum value. So we'll be understanding more about this as we progress through the session. So first, what we'll do is we'll just go ahead and create 3 lists. In the first list, we just have numbers from 1 to 9. In the second and the third list, we have randomly given some numbers over here. And then we'll create a list out of all of these 3 lists. So inside this list method, I am passing in 1, 2, and 3 as a list, and I'll store the resultant list in this object called as data. Then if I have to create a box plot, I'll just use plt.boxplot, and inside this I'm passing in this data object which I just created, and when I show it out, this is the result which I get. Now when I compare these 3 boxes, let's actually understand the inferences over here. So for this plot or this plot, this box basically refers to this particular list. This box tells us that the median value of the numbers which are present in this list is 5. The maximum value is 9. The minimum value is 1. Similarly, if we look at this particular box, so this box refers to this particular list. And this box tells us that the median value will be 3, the maximum value will be 5, and the minimum value will be 1. Then if we have a look at this particular box, this would tell us that the median value will be 7 for this list, the minimum value will be 4, the maximum value will be 9. So it's time to create a box plot. I'll add this comment over here, box plot. And after this, I'd have to create 3 lists. So I'll have L1, and inside L1, I'll just have all the numbers starting from 1 going on till 9. Then I'll have L2. Inside L2, I'll just randomly give in 9 numbers. And again, I'll have L3, and also in L3, I'll just randomly give in some numbers over here. Now, once we have L1, L2, and L3, I'd have to create a list of lists. So inside this, I'll just be passing in L1, L2, and L3, and I will store this in a new object called as data. So now that we have created data, I can just go ahead and build out the box plot. So I'll have plt.boxplot, and inside this, I'll just pass in data. Then I can just show it out to you guys. So we have these 3 box plots over here. So the first box plot represents this particular list. We see that the median value is 5, minimum value is 1, and the maximum value is 9. Then we have this second list over here. So for this, the median value is 5, the minimum value is also 1, and the maximum value is 8. So, and for this particular list, it seems that the median value and the 75% value is same. So for this, the median value is 8, the minimum value is 5, and the maximum value is 9. So one another geometry which is analogous to the box plot is the Violin Plot. So the only difference is to create a Violin Plot, we'll be using Violin Plot method instead of box plot method. And this is the difference between how these boxes and violins look. And we can, so normally if we don't set the show medians to be equal to true, we'll not have these lines or these indicators over here. So we'd also have to set this to be equal to true. So now here, I'll just copy this entire thing. I'll paste it over here. And instead of having plt.boxplot, I'll just have plt.violinplot, and I'm printing out the same data. And as you guys see, I have created this violin plot. And now if I want the median, so I'll have show medians, and I'll set this show medians to be equal to true. And as you guys see, I have added the medians as well. And after the violin plot, we'll have the pie chart. And pie chart again helps us to understand the frequency or percentage of different categorical values. So here we have 2 lists. The first list comprises of all of the names of different fruits. So we've got apple, orange, mango, and guava. Then in the second list, we've got the quantity of these fruits. So we've got 67 apples, 34 oranges, 100 mangoes, and 29 guavas. And if I want to represent this relationship of the quantity of these fruits in a pie chart, this is how I can do it. So I'll be using plt.pie. And here first I'll be passing in the numerical entity. So the numerical entity is this quantity, and I'll be passing that over here. Then I'll have the categorical entity over here, which is fruit. So I'm assigning fruit to labels. Then I can just go ahead and show the results. And as we see in the result, we see that the maximum percentage is of mango and the minimum percentage is of guava. So I'll have to create 2 lists over here. I'll create the first list. I'll have fruit, and the first fruit will be apple. The second fruit will be mango. the third fruit will be orange, and the fourth fruit will be lychee. Now that we have created all of these fruits, I'll also assign the quantity. So let's say I have 53 apples, I've got 43 mangoes, I've got only 12 oranges, and I've got 97 lychees. So I've got these two ready. Now after this, I'd have to create the pie chart. So I'll have plt.pie. First, I'd have to give in the numerical object, which will be quantity. Then I'd have to give in the categorical object. So I'm mapping fruit onto the labels. Then I would just have to show out this pie chart. So plt.show. As you guys see, this is the resultant pie chart. So the maximum portion belongs to lychee and the minimum portion belongs to orange, because we have 97 lychees and we have only 12 oranges. Now we can also go ahead and change the colors of these different sectors and also add the actual percentage in these different sectors. To add the percentage, we'll be using auto PCT. So here, for this auto PCT attribute, I am using 0.1f. Now, what this basically means is the 0.1 basically means that I'll have the decimal values to one place. So if I have 0.1, this will mean I have decimal values to one place. If I'll keep it as 0.2, then I'll have decimal values to two places. And after this, I'm just adding this new attribute called as colors. And the coloring, it starts from the first label, which is apple over here. Orange, then I've got blue, which is for mango. Then I've got black, which is for guava. I'll copy this entire thing over here. I'll paste it over here. Now, to add the percentage, I'll be using auto PCT. And here I'll have to use %0.1f. Let me add %. And after this, I'll also have to set the color over here. So the colors, I'd have to give in a list of colors. So let's say for apple, I'd want to give in green. Then for mango, I'd want to give in yellow. Then for orange, I'd obviously want orange. And for lychee, I'd want pink. Now when I hit on run, let's see what would be the result. Let me change this to colors instead of color. So as you guys see, I have the percentage over here because I had used auto PCT attribute, and it seems that we have, out of all of the fruits, 47.3 of them are lychees, and this is the color indicated. Similarly, out of all of the fruits, only 5.9% of them are oranges. So we have created the pie chart. Then something which is very similar to pie chart is the donut chart. And to create this donut chart, we'll be using two pie charts over here. So the data is same. We have fruit and quantity. It's just that first we'll go ahead and create our first pie chart, which comprises of quantity and labels. And I am adding a new attribute inside this, which is the radius. So I am setting the radius of this to be equal to 2. Then I'll go ahead and create another pie chart. Here inside this, I'll just pass in. So first we'd have to pass in numerical entity. So I'll just have a list which comprises of only one element or one value, which is 1. And this entire value or this entire list comprises of only one color, which is white. And I'll set the radius to be exactly half of the original pie. So I'm setting the radius to be equal to 1. And as you guys see, this is the outer pie chart. This is the inner pie chart. So the outer pie chart has a radius of 2. The inner pie chart has a radius of 1. And since I've given a color of white, this is what I have over here. So you can give in any random number over here. That doesn't really matter. So you can give 1, 10, 5. It is all the same. It's just that keep the color as W, because since a donut, it just basically looks like a donut, we'll have to give in the white color. I'll copy this entire thing. I'll paste it over here. I'll set the radius for this to be equal to, let's say, 4. Then I'll have a new pie chart over here. I'll just give in a random value. Let's say I'll give in 5 over here. And after this, I'd have to set in a color. And since there is only one value, I'll just give in white color over here. And after this, the only thing which I have to set is radius, and I'll set the radius for this to be equal to 2. Let's hit on run. And this is the donut chart which we get. So as you guys see, the radius for the outer pie chart is 4, the radius for the inner pie chart is 2. Let me reduce this. Let me keep this to be 2 actually, and let me keep this as 1. And this is the resultant donut chart. So SeaBorn is another visualization library which is built on top of Matplotlib. So if you want to work with SeaBorn, then we'd have to import Matplotlib as well. So to import SeaBorn, we'd have to type in import SeaBorn as SNS. And since this is built on top of Matplotlib, we'd also have to import Matplotlib. So we'll have from Matplotlib import PyPlot as PLT. And inside SeaBorn, we have this method called as load dataset, and we have some built-in datasets inside the SeaBorn library. And one such built-in dataset is the fMRI dataset. And I'm storing this in this new object called as fMRI. And then I'll have a glance at this first 5 columns of this dataset. So we have these columns. We've got subject, time point, event, region, and signal. Now, out of all of these columns, I'd want to make a line plot between the time point column and the signal column. So to make a line plot with the help of this SeaBorn library, since I've given the alias for this SeaBorn library as SNS, I'll type in SNS.lineplot, and onto the x-axis I am mapping the time point column, and onto the y-axis I am mapping the signal column. And then I'll have a new attribute called as data. So basically I am building this line plot on top of this fMRI dataset, that I just go ahead and show out this line plot. So let's understand this properly. So if you look at this line plot closely, you would see that till the time point of 5 seconds. So let's say if this time point is in seconds, so till the time point of 5 seconds, the signal value is increasing. But from time point of 5 seconds to 10 seconds, you have the signal value to be increasing. And after 10 seconds, this sort of stabilizes and only increases to, so here if the value is minus 0.05, so from minus 0.05, it goes up to close to 0. So now that we are done with Matplotlib, let me go ahead and create a new notebook over here. And I'll name this new notebook to be equal to SeaBorn. Let me rename it. I'll delete this. I'll name this as SeaBorn Demo. And we'd have to load the required libraries. The first library is obviously SeaBorn. So I'll have import SeaBorn as SNS. Then I'd also need PyPlot. So I'll have from Matplotlib import PyPlot as PLT. Let's just wait for these two libraries to load. And once we have SeaBorn with us, we'll be working with the fMRI dataset. So to load the fMRI dataset, we have the load dataset method, which is part of the SNS library. So I'll have SNS.load dataset, and inside this, I'll be passing in the name of the dataset, which is fMRI. And I will store it in this object called as fMRI, and let me have a glance at the first 5 records of it. So I'll just type in fMRI.head, and these are the different columns which are present, and I'd want to make a line plot between the time point column and the signal column. And for this purpose, I'd have to map the time point column onto the x-axis and the signal column onto the y-axis. SNS.line plot, and onto the x-axis I am mapping time point, and onto the y-axis I am mapping signal, and the data is obviously fMRI. Then I would just have to show out the result. So I'll have SNS. I'll actually have to give in plt.show over here. Let's hit run. So we have successfully created this line plot, and as we had already seen, so till 5 seconds there's an increase in the signal value, from 5 to 10 seconds there's a drop, and then it sort of stabilizes. Now we can also add a new attribute or new aesthetic called as hue. So here we had only one line, and this one line, arbitrarily the color of this was blue. But if I want the color of the lines to be actually determined by a column, what I can do is I can map a column onto the hue aesthetic. So we have the event column and we are mapping the event column onto the hue aesthetic. So now the color of the lines would be dependent on this event column. And since we have two events over here, we have the stem event and we have the queue event. This blue color line represents the stem event and this orange color line represents the queue event. And if we look at this blue color line over here, you would see that till time point of 5 seconds, the signal value, it goes up till maybe 20 and then it drops down to a minus 0.1. And similarly, if we look at this queue event, you see that the peak is not so high. So for the stem event, it was almost 0.2, and when it came to queue, it is only 0.05. But you'd also notice that the drop is not so steep. So for the drop of the stem event, it came from 0.2 and it will drop down to minus 0.10. But for this particular signal queue, the drop is very small. It dropped from 0.05 to only minus 0.05. And also if you see the increase of it, so once it dropped, the increase of queue event is much higher when compared to the increase of this stem event. So this is the same set of commands. It's just that I am adding a new attribute called as hue and I'm determining the color of the lines on the basis of this attribute, and I'll be mapping the event column on top of this. So as you guys see, I have this event column and this is the same column which I'm mapping onto this hue aesthetic. Event, we see that we don't have the event column. So what I'll do over here is I will cut this out. I'll paste it over here. I'll put in a comma, and since this is a column, I'd have to put this in double quotes. Now when I hit run, so seems like we have an error again over here. I have two commas. Let me go ahead and delete this comma. And we have successfully produced these two line plots over here. Now we can also go ahead and change the style of how these lines look. So now if I want these lines again, or the style of these lines again, to be dependent on a column, I can just go ahead and add a column onto the style aesthetic. So the color is also being determined by the event column, and also the style is being determined by the event column. So it will be the same command, and I'll be adding a new attribute to this. I'll have style, and to this I am mapping the event column, and you see that the queue event is being represented with this dotted line and the stem event is being represented with this solid line. So now that we have created that, we can also add markers on top of it. So all we have to do is set the markers to be equal to true. Here in this command, I'll have this new attribute called as markers, and when I set this to be equal to true, you will see that, so I have markers now. When it comes to the stem event, the markers are solid circles, and when it comes to the queue event, the markers are crosses. So that was all about line plot with the help of the SeaBorn library. Now we'll go ahead and create a bar plot with the SeaBorn library. So to create this bar plot, we'll be actually needing the Pokemon dataset. So we'd have to start off by loading the Pokemon dataset. So we'll have pd.read_csv, and we'll store this Pokemon.csv file in this Pokemon object. And once we store it in this object, we can go ahead and create a bar plot for this isLegendary column. So this isLegendary column is a categorical column, and that is why we are creating a bar plot. And in this is legendary column, we have two categories, 0 and 1. So 0 indicates that the Pokemon is not legendary and 1 indicates that the Pokemon is legendary. And onto the y-axis, I am mapping the speed column. And from this bar plot, it is very evident that legendary Pokemons, or the speed of the legendary Pokemons, is higher when compared to the speed of non-legendary Pokemons. So now I'll have to go ahead and load up the required data set. So to load the data set, I would need pandas. So I'll just type in import pandas as PD. Now once I have this, I need to load the CSV file. So I'll type in pd.read_csv, and inside this I'll give in the name of the CSV file, which will be pokemon.csv, and I will store it in this new object called as Pokemon. And once I've stored this, let me have a glance at this. So I'll just type in Pokemon.head and I'll show you all of these columns. So these are the different columns which are present over here. So against bug, against dark, against dragon, all of these columns basically tell us how does a Pokemon perform against these types of Pokemons. Then let me scroll it to the last. So here we have this is legendary column, which would tell us if the Pokemon is legendary or not. Then we have this generation column, which would tell us to which generation does this Pokemon actually belong to. Then this column tells us what is the weight of this Pokemon in kg. Then this type 1 tells us what is the primary type of the Pokemon. Type 2 tells us what is the secondary type of the Pokemon. And then we've got other columns as well. So now for this bar plot, we'll be only working with this is legendary column and then the speed column. So I'll be using sns.bar plot, and onto the x-axis, I would have to map is legendary, and then onto the y-axis, I'll be mapping the speed column. And the data onto which I'd want to build this bar plot is the Pokemon dataset. Then I can just go ahead and show this out. And when I hit on run, you would see that I have successfully created this bar plot. And again, it is very evident that the legendary Pokemons, the speed of the legendary Pokemons is higher when compared to the speed of non-legendary Pokemons. So now we'll create a bar plot between is legendary column and weight in kg column. So is legendary column is again mapped onto the x-axis. It's just that here for the y-axis we are mapping weight kg column. And this time it is very obvious that legendary Pokemons, their weight is much higher when compared to non-legendary Pokemons. I'll cut this out, I'll paste it over here. And instead of mapping speed, I have the weight kg column. And when I hit on run, you would see that the weight in kg of a legendary Pokemon is much higher when compared to the weight in kg of a non-legendary Pokemon. Now, we can also go ahead and determine the color of these bars on the basis of a column. And we already know to do that, we'll be using the hue aesthetic or the hue attribute. And I want the color to be determined by the generation column. So this time I'll be mapping the generation column onto the hue aesthetic. And as you guys see, we have 7 generations over here, starting from generation 1 going on till generation 1. And since we have 2 different legendary status, so 0 indicates that the Pokemon is not legendary, 1 indicates that the Pokemon is legendary. For these 2 categories, I'll have 7 bars each. So for those Pokemons which are not legendary, I'll have these bars, these 7 bars indicating to which generation does the Pokemon belong to. Similarly, for all of the Pokemons which are legendary, I'll have these bars indicating to which generation does the Pokemon again belong to. And again on the y-axis, since we have mapped speed, we have the speed values corresponding to whether the Pokemon is legendary or not legendary. So the same set of command, I would have to use the hue aesthetic, and onto this I'll be mapping the generation column. And as you guys see, so this denotes all of those Pokemons which are not legendary, this denotes all of those Pokemons which are legendary, And it is very clear that legendary Pokemons, they have much higher weight when compared to non-legendary Pokemons. And we have the distribution of Pokemons which belong to the different generations with respect to both legendary Pokemons and non-legendary Pokemons. Now going ahead, we can also change how the different palettes look for these bars. So we will use the palette attribute. So we've got these three different palettes over here. So again, the bar plot is between is legendary column and weight column. And it's just that instead of using a column to map it onto the hue aesthetic, we are using a new aesthetic called as palette. And we can directly use different predefined palettes. So first we have the blues D palette with a capital B. This is how it looks like. Then we have the rocket palette, and this is the resultant. And then we have the VLAG palette. Let me delete this hue attribute over here. And instead of that, I'll have palette attribute. And the first palette which I'll be using is blues D. And as you guys see, this is the blues D palette. Similarly, if I want maybe a more of red color, then I'll be using the rocket palette. Then if I want maybe a light shade of bluish gray, I'll be using VLAG, and this is what I'll be getting. Now, instead of maybe using a palette or maybe mapping a color onto the hue aesthetic, I can just go ahead and use the color attribute and assign one single color for all of the bars which are present. So I'm using the color attribute and I'm mapping the orange color to both these bars. I'll remove palette, and instead of palette, I'll have the color attribute, and I will set the color of these two bars to be equal to orange, and this is the result. So we are done with bar plot as well. Now we'll go ahead with the next type of plot, which is scatterplot. And we have already learned that a scatterplot is used to understand the relationship between two numerical entities. And over here, we are building the scatterplot on top of the iris dataset. So we'll load this dataset up. Then we'll be using sns.scatterplot, and onto the x-axis I am mapping the sepal length column, and onto the y-axis I am mapping the petal length column, and the data onto which I'm building this scatterplot is the iris dataset. And again, it's very clear that as the sepal length of the iris flower increases, the petal length of the iris flower also increases linearly. So here I'd have to load up the iris dataset first. So I'll have pd.read_csv. I'll give in the name of the file, which will be iris.csv. Now that I have loaded this, let me show you guys the first 5 rows of all of the columns, and this is the resultant. And to create the scatterplot, all I have to do is use plt.scatterplot, and since I want the scatterplot between sepal length and petal length, and I want sepal length to be onto the x-axis, so to x I'll be using sepal.length, and on the y-axis I would need petal length. So let me give in the name of the column over here, which will be petal length, and the data which I'm using is obviously iris. Then I can go ahead and show out the result. So let me just keep it as scatter over here. And again, this has to be equal to small d and not capital D. Let me hit on run over here, and this is the resultant value. Now, as you see over here, we can go ahead and add in color and also change the style of this. So initially we just had a simple plot between sepal length and petal length, but now I want these dots to be determined, or the color of these dots to be determined by the species column. So that is why I am mapping the species column onto the hue aesthetic. And after that, similarly, I am mapping the species column onto the style aesthetic as well. So here, as you see, we've got 3 different colors: blue, orange, and green. The blue color is being determined with the Setosa species. Then we've got this orange color, which is for the versicolor species. Then we've got this green color, which is for the Virginica species. Similarly, we've got 3 different styles over here. For Setosa, we have solid circles, for versicolor, we have crosses, and for Virginica, we have solid squares. The same command which I've copied, I've pasted it over here. I'll add two more attributes. The first attribute will be hue, and onto hue, I'll be mapping the species column. Similarly, onto style as well, I'll be mapping species column, and when I hit on run, so I'll have it as hues. Now when I hit on run, seems like we have an error over here. Let me check it properly. And this over here has to be just hue. Now when I hit on run, this is the resultant scatter plot which I get. And now let's say instead of having the colors to be determined by a categorical column, if I actually want the color to be determined by a numerical column, I can also do that. So here, since petal length is mapped on the y-axis and I want the color to be with respect to the petal length, I'll go ahead and map the petal length onto the hue aesthetic. And as you guys see over here, as the value of petal length is increasing, the intensity of these points is also increasing. So here on this lower left side over here, we have all of this very light shaded circles, and at the top right you have this high intensity or high intensely colored circles over here. I'll copy this, I'll paste it over here. Now I'll want the hue or the color to be actually determined by petal length itself. Let me keep the L to be capital, and when I hit on run, you would see that as the petal length value increases, the intensity of the color also increases. Let me just go ahead and also add the style over here. So this time the style will be determined by the species column, and you would see that we have three different styles. For Setosa, this is Setosa, you have solid circles. For versicolor, you have crosses, and for Virginica, you have solid squares. So this was about a scatter plot. Now we'll go ahead and make a histogram or a distribution plot. So a distribution plot, you can consider this to be a combination of a frequency curve and a histogram. And we've already worked with histogram when it came to Matplotlib. We know that a histogram is used to understand the distribution of a continuous numerical value. So for this, we'll be using the diamonds data frame. So we'll load up this diamonds data frame, we'll store it in this diamonds object, and then we'll have a glance at it. After that, to create this distribution plot, we'll use Distplot, and inside this, if I want to understand the distribution of the price column, I'll just pass it over here. So I'll have diamonds of price, and as you guys see, this would show us the distribution plot. And as I've told you, the distribution plot is a combination of a histogram and the frequency curve over here. I'll just add this comment and I'll add distribution plot. Now over here, to create this distribution plot, I would need to load up the diamonds data set. So I'll have pd.read_csv, and inside this I'll be passing in the diamonds.csv file, and I will store it in this new object called as diamond. Now that I've loaded this data set, let me have a glance at the first 5 records of this. So diamond.head, and these are the different columns which are present. So I've got caret, which obviously tells us about the caret of the diamond. Then we've got the cut type of the diamond, we've got color, clarity, depth, table, price. So this is price of the diamond in US dollars. So the price would mostly range from around $300 to around $18,000. Then we've got X, Y, and Z. X over here denotes the length of the diamond in millimeters. Y denotes the width of the diamond in millimeters, and Z denotes the depth of the diamond in millimeters. So once this is clear, I'd have to make a distribution plot, and since distribution plot is used for continuous numerical values, I'd want to make a distribution plot for this particular column. So I'll have sns.distplot, And inside this, I'll be passing in diamond. I'll have square braces over here. Inside this, I'd have to pass in the column, which is price. And I would just show this out. I'll have plt.show. And you would see that I have created this distribution plot over here. Now, in the distribution plot, let's say if I want only the frequency curve without the histogram, that also can be done. It's just that in the same command, I would have to set hist to be equal to false. And when I set hist to be equal to false, I'll only get the frequency curve. I'll copy it, I'll paste it over here, and I'll add a new attribute called as hist, and I'll set this to be equal to false. And when that is done, you would see the difference. So this was a distribution plot which had both histogram and the frequency curve. Now this is a distribution plot which comprises of only the frequency curve. Now similarly, we can go ahead and add a new color to this, and to add a new color, we'll just use this color attribute and add this. So this was the distribution plot which we had created, and to this, if I want to add color, I'll use this color attribute. I'll assign it red, and you would see that I have assigned it the red color. Now if I want a distribution plot without the frequency curve, which would mean I'd want only the histogram, then here I will set KDE equal to false. So in the distribution plot, either we can have both the histogram as well as the frequency curve, or we can just have the histogram, or we can just have the frequency curve. To just get the frequency curve, we'll set hist to be false. To just get the histogram, we'll set KDE to be equal to false. And we can also go ahead and vary the number of bins which are present. To vary the number of bins, I'll use this attribute called as bins, and over here I'm setting the number of bins to be equal to 10, and I'm just setting the color to be equal to green. I'll select this over here, I'll paste it, and I'll set KDE to be equal to false. And when I do this, you would see that I have only the histogram without the frequency curve. Now if I want to change the number of bins which are present, so since there are 150 records, I'll have 150 bins, but instead of having all of this, so let's say if I want only 50 odd bins over here, I'll set 50, and as you guys see, I have only 50 bins. Now let's say instead of 50, maybe if I want only 10 bins, so you will see that I have only 10 bins. Now let's say if I want only 5, that also something which can be done. I'll set the value to be equal to 5, and we have only 5 bins over here. And after this, let's say if I want to plot it on a different axis. So till now we've been creating this distribution plot where on the x-axis, or basically this was based on the x-axis, but instead of having it to be based on the x-axis, if I want to map it vertically, then I would just have to set vertical to be equal to true. I'll have the same command over here. And here I'll set vertical to be equal to true. I'll remove this KDE equal to false from this. I'll also remove this particular attribute from this. Now if I hit on run, you would see that I have mapped this distribution plot onto the y-axis. Next we have a new geometry called as a joint plot. So this joint plot is a combination of a scatter plot and a histogram. So as you guys see over here, I have a scatter plot in the center, and I have a histogram at the top side and the right side. And I'll be creating this joint plot on top of this iris data frame. So once I've loaded this iris data frame, I want to create a joint plot between sepal length and petal length. So I just created a scatter plot. So for scatter plot, we are just use scatterplot method. For joint plot, it's just that we have to use this particular method. We are passing in the same columns. Now, when it came to scatterplot, we had only this particular part. But when it comes to joint plot, here what you see for sepal length, you would have the histogram of the sepal length column as well. Similarly, for petal length, you will have the histogram for petal length column as well. So this is an interesting point about JointPlot. We already have loaded the iris data frame. Now I'll have to use sns.jointplot, and onto the x-axis I'll be mapping sepal.length, and onto the y-axis I'll have to map something. So onto the y-axis I'll be mapping petal.length, and that is pretty much it. I'd actually have to give in the data as well. So the data on which I'm making this is the iris data set. Then here I'll have plt.show, and when I hit on run, so seems like we have an error over here. So sepal length, so L has to be capital. Let me make it capital L. And you would see that I have successfully created this joint plot where I have the scatter plot in the center, and I have corresponding histogram for sepal length on the top, corresponding histogram for petal length on the right side. And over here, if I want to change the color, that is also something which can be done, and we've already seen this throughout. So all I have to do is use this color attribute, and I have to give in a color for this. And if I like the olive color, that is what I'll be going ahead and mapping it onto this attribute. I'll add this color attribute, and I'll have olive. And as you guys see, I have mapped the olive color for this joint plot. Now for this, if I want a regression line through the scatter plot and also through the histogram, I'd have to use this new attribute called as kind. And for this new attribute kind, I am assigning this value reg. So as you guys see, I have this regression line which is passing through the sepal length values and the petal length values, and also it is passing through both of these histograms. So here I'll have kind, and I'll have the value reg set for this kind attribute. Let's wait for the result, and you would see that I have added a regression line which goes through the histogram and also goes through the scatter plot. Once I have done this, let's go ahead to the next geometry, which is a box plot. And to create a box plot, we'll just be using this box plot method, and we'll be creating this box plot on top of the churn data frame. So we'd have to load this data frame first. So this data frame tells us about the different features of a telecom company, and on the basis of this features, we'd have to find out if the customer will churn out or will stick to the same company. So here we have the churn column and the tenure column. The churn column I'm mapping onto the x-axis, the tenure column I'm mapping onto the y-axis, and obviously I'm building this box plot on top of the churn data frame. One interesting attribute about a box plot is that box plot can be mostly used to understand how does a categorical value change along with a numerical value. So that is why here we have mapped this categorical column churn onto the x-axis and this numerical column tenure onto the y-axis. And we see that, so this what you see is the median value which we have already seen. So when it comes to people who do not churn out, it seems that those people who do not churn out, their median tenure or their tenure in general is longer than those people who actually churn out. So I would have to load this data frame first. I would have to store it in this churn object. So churn is equal to pd.read_csv, and inside this I'll have churn.csv, and then let me have a glance at the first 5 records of all of the columns, and these are all of the columns. And for all of these columns, I'd have to make a box plot between this tenure column which would go on the y-axis and this churn column which would go on the x-axis. sns.boxplot, and onto the x-axis I'd have to map obviously the tenure column. Onto the y-axis I am mapping the churn column. Then I'd have to use the data which is churn, and I'd have to show it out. So I'll have plt.show, So I've actually made a mistake over here. So tenure will go on to the y-axis and churn will go on to the x-axis. Now, if we get this box plot, and we've already seen the inference, it seems that those people who do not churn out, their tenure seems to be longer than those people who actually churn out. And now this time we'll be creating a box plot between the internet service column and the monthly charges column. So we have the monthly charges column onto the y-axis and the internet service column onto the x-axis. And we've got these three different categories in this internet service column. So the internet service can either be DSL, fiber optic. So this no means that the people don't have or the people haven't subscribed to internet service. And it is very clear that those people whose internet service is fiber optic, they would have the maximum monthly charges. Similarly, those people who do not have internet service, their monthly charges is minimum. So when you compare this box to these two boxes, it is very evident that people who don't have internet service, their monthly charges are very, very low. I'll copy the same command over here, but on the y-axis, I'll have monthly charges, and on the x-axis, I'll have internet service, and this is the resultant box plot which we'll be getting. Now we'll go ahead and make another box plot between the contract column and the tenure column. Tenure column would go onto the y-axis, contract column would go onto the x-axis, and we can have three different types of contracts: month-to-month contract, 1 year contract, and a 2-year contract. And if we look at the tenure of it, so let's actually look at the median values of the tenures. So it seems that if the contract is of month to month, then the median tenure is the lowest. Similarly, if the contract is of 2 years, then the median tenure is the maximum. And we are setting a palette over here. So again, we can have different palettes. So the palette which I'm using is equal to set1. Onto the y-axis, I'll be mapping the tenure column. Onto the x-axis, I'll have the contract column. Let me write in contract column over here. And the data will obviously be the churn data set. And what I'd have to do is I'd have to use a palette, and the palette which I am using is equal to set1. And this is the resultant box plot. Now you see these boundary lines over here. If we want to change the thickness of these boundary lines, we can do that with the help of this line width attribute. So here I am setting the line width to be equal to 3. If you compare this particular box plot with the earlier box plot, it is very clear that the thickness has increased. The same code, I'll actually have tenure and contract over here. Onto the x-axis, I'll be needing contract. And I will use this line width, and I'll set this to be equal to 3. And you would see that the line width has increased substantially. And after this, let's say if I want to change the order of how these boxes are present. So here, initially the boxes were present in the order of month to month, 1 year, 2 year. But instead of this order, let's say if I want 2 year first, followed by month to month, then after that, if I want 1 year, then I can use this attribute called as order, and inside this I'll pass in the list which will comprise of the order in which I would want these boxes to be present. So here I'll remove the line width, and instead of line width, I'll use this attribute called as order, and first I'll have 2 year. After that, I'll have month to month. Then finally, I'll have the last box, which will be 1 year. And you would see that I have changed the sequence. Now, if you want to add colors on the basis of a column, which we've been doing throughout, that can be done with the help of this hue attribute. And I want the color of all of these boxes to be determined by this payment method column. So here I am mapping this payment method column onto this hue aesthetic. And as you guys see, I have these 4 different payment methods. I have electronic check, mail check, bank transfer, and credit card. So electronic check. So this particular box, or wherever all of these boxes where the color of the box is purple or dark blue, that denotes electronic check. Then we have the box where the color is orange, that would denote mail check. And if the color of the box is green, that would denote bank transfer. And if the color of the box is red, that would denote credit card. So here, I'll add this attribute called as hue. And I want the hue to be determined with the help of this payment method column. And you would see that I have 4 of these over here. So I have 4 boxes with respect to these 3 different categories.
Alright guys, so to come to the first point on the agenda, what is Scikit-Learn? Well, the name seems to be pretty fancy, right? Scikit-Learn. I mean, why is it called Scikit-Learn, or what is it in fact, or how is it associated with Python? I'm sure your head is, you're wondering about a lot of these questions. Let me answer them. First of all, let us understand what it is, right? Scikit-Learn is a library in Python. Now, when I say a library in Python, it basically brings its own set of functions. It brings its own syntax. When I say syntax, it basically brings into its own picture a lot of these helpers, a lot of these things that not only shorten the code but give us immense amount of power and flexibility for a small amount of code, again, to have a large impact, as I previously mentioned, right? Not just Scikit-Learn, Python is known, Python is popular, and I popularly say it in all of my talks and all of my seminars and all of that Python is popular because of the fact that, one, it is written amazingly well. You can write Python beautifully. Syntax is amazing. The second thing that makes Python so great and makes it want everyone around the world to go mad about it is for a fact that it has these libraries which are taking extremely complex tasks and eventually simplifying it to the maximum extent so that you and I can work on it with ease, right? We have an entire community to thank. Of course, the Python community and the Scikit-Learn community, you have to understand, but all of these are like open source. So at the end of the day, for you, it is completely free to use. So if you're wondering about starting machine learning in Python, you really don't have to pay anyone anything to actually maybe buy the tools to use it, because Python is free, Scikit-Learn as a library is free. You have multiple IDEs, integrated development environments, that you can use to work with Python for free. Well, at the end of the day, you really don't have to pay a penny to actually get your hands dirty out there, right? So what is it about Scikit-Learn? Scikit-Learn, is, people usually call it the father of machine learning in Python, as in a library, right? It's a way of explaining and understanding the importance of the library. Scikit-Learn as a library itself is considered to be a core library in Python. Now, when I say a core library, what I basically mean is that it has extreme importance, because without the library Scikit-Learn, it would actually make it very, very difficult for us to manually implement machine learning. Now, what I mean, just keep this in your mind until the end of the course, because when I actually practically show you how simple it is to work with this, then you'll realize saying, okay, so if it weren't for this library, that task would have been absolutely horrendous to do, right? So you're going to be understanding all of that firsthand. And again, as I just told you, right, it's a library that is considered super important, not just for machine learning, but at the end of the day, when you think about Python's library, set of libraries that make Python popular, Scikit-Learn is sitting way high up in that chart. And as you can see, it's also say that it's used alongside other beautiful libraries like NumPy, Pandas, or even Matplotlib. We're going to be using all of those libraries in the demo that I just spoke about. But yes, NumPy stands for numerical Python. Pandas is a beautiful library which will give you more data structures to play with. Matplotlib is a beautiful library that will help you with data visualization. So overall, when you're trying to devise a machine learning solution, you're going to be using all of these in conjunction, right? It's not just you using Scikit-Learn. Scikit-Learn gets the machine learning part of it done. But to convey the machine learning part of it to a generic audience, or to even explain it in a fashion that it would be understandable by a wide audience, is where you would require something like Matplotlib. But to make your own machine learning algorithm understand the data, you have to feed it in a very structured manner. For that, you're going to require Pandas. If you're performing any numerical operations, you're going to require NumPy. So in this one sentence that I just told you about, I basically condensed the entire process of handling a machine learning project, and you'll understand that even though Scikit-Learn is the center of the project, it actually fits in a way bigger picture which is leading to the overall solution, right? That's a really fun part to understand. Now, coming to machine learning is a domain of its own. It's a league of its own. So Scikit-Learn is basically a library. It's like a doorway. It's like a path that almost, I want to say everyone, almost all the learners, take to get towards the domain, right? As you might already understand, right now, wherever in whatever form you're watching this content, there is a bit of machine learning going on in the video player that's maybe using it, or the website that you're watching this on, or whatever it is, right? Right from your phone, your mobile phone, even my watch basically is smart these days. It uses machine learning to continuously analyze and assess what I do so that it can help me better. How fantastic is that, right? Now, if it can help me like that on a personal basis, be it fitness or whatever it is, think about what it can do around the world where we have so much requirement, right? So literally, it has millions of applications and millions of developers who are working day in and day out to make machine learning more accessible to all of you all, first of all. And at the end of the day, it's not just accessibility, it's the way of simplifying a complex domain such as machine learning to make sure you understand it easily, right? Because without Scikit-Learn, again, to reinforce on the same, it would have been very difficult to implement some very simple machine learning solution, because you have to manually just think about the process of machine learning. You're getting your computer to learn a lot of things which it has probably not learned before, it has not seen before, right? Now, you and me, we are cognitive species. We can go about learning really rapidly. When it comes to your computer, when it comes to your laptop, mobile phone, anything digital, in its most fundamental sense, in its most basic sense, the more in depth you dive into your computer, you will understand that you will reach an end point where your machine only understands zeros and ones. Everything in your computer's world is just zeros and ones. Now, you would probably be reinforced for a fact that you might think humans are the most intelligent species out there, and now you probably figure out saying why probably you're faster than your computer or something like that, right? But yes, once it becomes that simple, you have to teach your computer to learn, right? You have to make sure it understands what it is seeing. That process in itself is extremely complex, but thanks to the world of statistics, mathematics, and programming, we have basically dumbed down a very complex process to make sure that, even not just researchers, but even freshers, beginners, students, whoever wants to get into the domain can beautifully work with it. And Scikit-Learn, again, is a very, very big reason for all of this, is definitely in my belief as well. Now, whenever you think about machine learning, whenever you think about using a library such as Scikit-Learn for machine learning, your library must be able to do three things with ease, right? With any machine learning algorithm, you're going to require some sort of representation, you're going to require some sort of evaluation, and you're going to require some sort of optimization. Now, what do I mean by this? Let's take a look at representation for a second. Now, representation basically is talking about the capability of Python, the capability of your working environment to actually you using tools and techniques to make sure that your data is configured in a way wherein your machine learning algorithm can sort of ingest it, can understand it, can work with it, can import it, all of these words that I just said, right? Yes, that is representation. Finding a way to getting your machine learning algorithm to realize that, hey, here's the data, here's how best I can use them. Scikit-Learn works beautifully there. I'm going to show you how. And then talk about evaluation. Evaluation is where, I think is the most human dependent concept, because you will be wondering about a hypothesis you might have in mind. You might think that a solution might work, or you might have a problem statement in mind and a solution. And when you start implementing it and you start making assumptions based on which either your solution will work or not, to support this exact thought in the world of programming, it's you thinking is very different from you writing a program to get your computer to think. Scikit-Learn will help you with respect to evaluation as well. Of course, it will help you with evaluation, because evaluation is the heart of machine learning. After it learns something, you evaluate it to see if it has learned anything or not, right? That's how probably the entire world's education system is. You're probably given a couple of textbooks, a couple of notes or whatever it is, reference material to study. You study all of that. Eventually, you go back to your school, college, university, whatever it is, and you write an examination to showcase that you have learned something. You're proving that you have learned something from your memory, right? You're recalling it. You're showcasing what it is that you have learned. We want our machine learning algorithm to have that capability, and it is very well done. Now, the third thing that the library should help you do is optimization. Now, when I say optimization, think of a situation where you have created a machine learning solution. It is working well maybe to the level of 75% accuracy, right? Now, in the general machine learning world, anything above 80 and all the way to 90-95% is considered to be really, really good accuracy in terms of a machine learning model. Now, it's not just you write a program once, you execute it, the solution is working well, boom, you're done. That never, ever happens in a real world situation. In a real world situation, you'll be the happiest guy when your solution actually starts working towards the goal. But it is also a starting point to make sure you can tune your model to perform better. Think about a very simple example, right? Let's just say you just want to start running. You really like running marathons. You love people whenever they post stories of running like 10 kilometers, 5 kilometers, 15 kilometers and all of that. You want to do it. Day one, you would probably not be able to run 10 kilometers or 15 kilometers at a stretch. Maybe with 6 months of everyday training, you can do it with ease, right? First day, you try it out. Maybe 1 kilometer, you run really well and then you're tired and you're like, there's no way I can run 10 more. But maybe 6 months later, that starting 1 kilometer becomes like the easiest warm up ever. And you can maybe run 20 more at your best performance ever, right? So what happened over those months? You learned, your muscles are trained better, everything in your body is working towards you becoming faster and having more endurance. Similarly here, we find ways to ensure we can train machine learning algorithm not just to solve a problem, but we are continuously changing something in the way it learns to make sure that at the end of the day you have the maximum accuracy possible. So you're tweaking, you're tuning, you're making some changes to get your machine learning algorithm to understand better, and if it understands better, what happens? It gives you a better result that you can take away, right? So it becomes very important in this part of our discussion. Now, coming to the origin of Scikit-Learn, you might have seen machine learning's popularity like rapidly increase all around the world, maybe like in 2012, 2014, right? A couple of years back, less than 10 years back. So it is, whenever again I go to seminars and I address an audience, they always ask me saying, hey, this is a brand new library which beginners might have not heard of. Well, to your surprise, Scikit-Learn is actually over 10 years old. It was basically developed as a summer project, Google Summer of Code project in the year 2007 by this person, a really talented person called David. And originally it was called as Scikit-Learn with a S at the end. And of course, we don't have that S anymore. And what started as a project, a brainstorm of one very talented individual, the project actually went public in the year 2010, after having some sort of research application development. And right since 2010, where are we right now? 21, 22, right? So when you think about it, 10 years back, a library which was made open source, popular, and everyone in the community are not just working to use the library, but there are thousands of developers and millions of intelligent people who are making the library better, as in they're working on the library to make sure you and me can have a more easier way to work with it, right? So Scikit-Learn started out as a research project. It went public. It is open source. It is free. It has millions of collaborators who are working to improve. In fact, there are developers right now as you're watching this course who are working on improving and bringing a better version of Scikit-Learn, right? And all of that is being done for free, mind you. And at the end of the day, Scikit-Learn is used commercially everywhere around the world. So that should really tell you about not just the power of machine learning, but really the brains. And my kudos to all the contributors who have made sure that we have a very good library such as this, right? Now, you might be asking a question saying, wow, this sounds really fancy, but what are some of the things that I should know about when I begin working with Scikit-Learn? Well, I can tell you one important thing. There are definitely certain prerequisites when you have to think about working with Scikit-Learn. And mostly, as I told you at the start of the course itself, it is the dependency with other libraries, because Scikit-Learn fits as a puzzle piece on a very big scale to make sure you get towards a solution. It is not the only puzzle piece, but it is just one among a lot of other things that you're going to require, right? So what are these other things that you're going to require? First of all, we're discussing Python. So you definitely require the understanding of Python syntax. You need to know how Python syntax is written, and you must have the capability to, take something in your head, a thought in your head, and maybe put that down as code. That is going to be a skill that's going to help you a lot in machine learning. Then working with libraries such as NumPy and Pandas and Matplotlib and even SciPy, it stands for Scientific Python. All these libraries that you're seeing on your screen right now, NumPy, SciPy, Pandas, and Matplotlib, they are 90% used used together with Scikit-Learn in all of these solutions. So as and when you're learning Scikit-Learn, if you're brand new to Python, brand new to machine learning, watching this course, I highly suggest you spend some time learning Scikit-Learn, at the same time ensuring that you're up to speed with NumPy, SciPy, all the other libraries which are sometimes direct dependencies, right? Now, in the demo that I'm going to be showing you guys, you will realize that it's not just Scikit-Learn that I'm using. For example, the way we ingest data, the way we bring in data, we primarily require Pandas for that. And once you work with it, maybe at the end of the solution, you want to create beautiful looking charts and graphs to showcase the solution. You're going to require Matplotlib for that. Maybe you want to do some array computations and you want to change some values and make sure your data is fed into your model in the right way. You might require a bit of NumPy as well, right? And if you're performing all these statistical operations, data analysis, you're hunting for a lot of insight in your data, you're going to require SciPy. So all in all, a bit of everything is required. But my goal here is to tell you guys, if you do not know, either of these or any of these at this moment of time for this course, it is completely all right, because I promise you, you can follow to the end of it and you can definitely take away a ton of insights from the course, right? Fantastic. Now that we are done with that section, ladies and gentlemen, now we know what Scikit-Learn is, we know its importance, we know its origins, we know the prerequisites, we know what it does, we know that it is a fantastic library, right? So to get you guys started, here is a section where we can discuss about how you guys can install Scikit-Learn. Now, installing Scikit-Learn is very, very simple, because at the end of the day, you never have a hassle to say, oh, my operating system is not supported, right? It is a very common issue that happens. You guys are Mac OS users. There is always a situation where there is an app which is maybe not built or not ready for Mac. In this case, never. Python is widely available in any operating system that you can think of. And if Python is available, there's a very good chance that the libraries that are associated with Python work in multiple operating systems, right? So regardless of the operating system that you actually use, be it Windows, Linux or Mac OS, I'm sure you guys watching this course are using all three of these, right? So I'll actually help you to install this library in all three of these operating systems. It's really a piece of cake, and we're going to be done with this section, I bet, in the next 5 minutes, right? So firstly, let's just talk about Windows and Linux, because it's very straightforward here. Now, to install a library for Python in Windows or Linux, you have something called as pip. Pip basically stands for, it's a package manager. It stands for pip installs packages, right? So whenever you have to install a package, such as Scikit-Learn, libraries are also called packages. When you have to install it, you basically use the help of another application which is built to install the library of your choice. So it is a standard package manager. It comes built in with almost all the operating systems that we have today. And to actually install the library of Scikit-Learn, you have to run one line of command, pip install Scikit-Learn. As you can probably see here, of course, we have 1 or 2 tabs, which is adding a little bit more of functionality about how it installs. But at the end of the day, if you're on Windows or Linux, all you have to do is open up your command prompt, you open up your terminals, and if you install it via Anaconda or something like that, open up the navigator, open up a command line interface, type in pip install Scikit-Learn, and it works. Now, in Anaconda is basically a distribution that will help you install all of these at ease. It not only installs Python, but it installs all these libraries which we are actually discussing these days. It will install it automatically for you. There again, if you, for some reason, if it is not installed, and if you want to manually install it, all you have to do is open up the prompt, Anaconda prompt, type in another command, conda install Scikit-Learn. So we went from pip install Scikit-Learn all the way to conda install Scikit-Learn, and this works for Windows. I think most of the version of Windows and most of the Linux flavors, Ubuntu, whatever it is that you guys are using, right? So how simple is this? You have to open a terminal, run a command, done, right? 3-4 steps, you good to go. So it's pretty simple installing it on Windows and Linux. And similarly, if you've been waiting for the section where I say, oh, it's a bit difficult to install on Mac, not really. It's actually as straightforward as us installing it on Windows or Linux, because here again, Mac OS provides you with Homebrew, right? Homebrew is beautiful, and Homebrew is not the only way of how you can install Mac OS. You can actually install Anaconda here as well. Anaconda is supported for Mac OS. You can install Anaconda, through which you can run the same conda command that we discussed, and you are good to go. Now, let's just say you want to install it via Homebrew. Installing via Homebrew is very simple. First of all, you're going to have to install Python itself. Brew install Python will get you to get Python set up on your machine. And after Python is installed, again, it's another simple pip command. Pip install Scikit-Learn, and boom. Now you have Python set up. Now you have Scikit-Learn set up, right? So again, just quickly pause in whichever section that you wish. Maybe you're a Windows or a Linux user, pause in those sections. You're a Mac user, pause in this section, get it all set up. And I promise you, it's gonna probably take you 5 maximum of 10 minutes to get everything set up for you guys to start using Scikit-Learn, right? So as you can take a look at it, it's very, very simple and straightforward. But you might be asking a question saying, okay, so now I installed it, what next? What do I get after I finish the installation? What is Scikit-Learn giving me after installation, right? Well, first of all, we have to discuss about how it is used completely in the world of machine learning. And in machine learning, supervised learning algorithms are really, really popular, right? Everywhere around the world, but a majority of the solutions are definitely supervised learning algorithms, which are put into use to get the solution done. Scikit-Learn supports many supervised learning algorithms that are out there, and whenever you have to find a way to train your machine learning algorithm better, or find a way to use a certain set of data to make sure that it runs through the same data multiple times and learns better, it's a technique called as cross-validation. And here as well, it's not just one technique that is given to you. You have multiple methodologies that you can use with respect to cross-validation as well. And not just supervised learning algorithm. I'm sure you read the first point and you're like, okay, where is unsupervised learning? Well, of course, it's the core library for machine learning. So you have to have a lot of unsupervised algorithms, and yes, there's a lot of support for that as well. Now, it's not just that you get the functionality of supervised learning algorithms or unsupervised learning algorithms or anything around that. When you have these algorithms, what do you require to start learning and using them? You're going to require data sets, right? So we actually have multiple data sets that come built in with Scikit-Learn. Think about the Iris data set. Think about the Boston housing data set. All these data sets are, if you're a learner, these are like the pathways that you have to take. And once you've started working with these, right? So whenever a machine learning enthusiast actually comes onto the picture and wants to learn machine learning, I am very, very sure they go through all of these data sets to actually learn the basics of machine learning. And I promise you that you might have heard of it, right? So what Scikit-Learn people have done is they realize that these are the data sets that are being popularly used by people to learn. So they just built it inside Scikit-Learn. So if you have to ever use Boston housing dataset, if you use Iris dataset or anything as such, you can actually do two ways. One, you can manually import it if you have the dataset ready in hand. Many cases you might not have the dataset in hand. That's when you quickly actually run a couple of commands in Python and it automatically imports it because the library already has it for you, right? Fantastic. Look at the last point. It says support for feature extraction like bag of words or more. Now, bag of words and all these concepts are super popular in the domain of natural language processing. It has its own library called NLTK, which is super popular for that. But then again, in collaboration with NLTK, in collaboration with natural language processing, you would see that machine learning has a large role there to play, right? So there again, there are multiple support for features which are dependent not just for that subdomain of natural language processing, but it brings together again another piece of the puzzle, which is you using machine learning to solve it. There again, support is provided, right? So it's, as I just told you, this is probably one of the best slides to tell you that it is an all-in-all solution for machine learning in Python. And this is everything that you get after running two simple commands. Now think about how easy it must be to actually go about using these libraries, right? Now, coming to a section where we can discuss what are some of the algorithms that are supported, by this library Scikit-Learn, right? As I just told you, since it's the core library, it has to support a ton of these supervised and unsupervised learning algorithms, and it does. So whenever you have any supervised learning tasks which uses regression or classification, it can be worked with ease. Now, when I say regression, think about maybe performing predictions in the future. Think about weather prediction. Weather prediction is a beautiful example of regression. Then if you want an example for classification, think about me giving you a couple of fruits and saying, can you keep all the apples to the left side, oranges to the right side, and maybe keep all the bananas somewhere else? Could you not do that? Yes, if you can do that, you teach your machine how to do that, and that's called classification and supervised learning, right? And then comes unsupervised learning. Of course, unsupervised learning is broken down into two types. It's clustering and association. And Scikit-Learn works really good for both of these applications. Now, when you say clustering, you're basically trying to find the common entities. You're trying to find the common characteristics in your data points, group all of these common entities, and eventually try to make assumptions out of it, try to have data-driven decisions out of it, or at the end of the day, use your own clusters to make sure that you are finding maybe better ways of analyzing something, or eventually you are dividing it into clusters to help you further down the line. Either way works really great, right? Clustering is sort of similar to classification, but here the way it works, the way your algorithm itself works is different because it's not supervised, it's unsupervised, right? There's no labels for learning here. And then association. I promise you have used association. Every time you go on to Amazon or any other e-commerce site to actually buy something, let's just say maybe you bought a brand new phone, there's a sale happening, you bought a new phone. As soon as you add the new phone to the cart, have you ever seen that Amazon or any other site, it recommends a lot of other stuff that people have bought. It says, hey, people who have bought the mobile phone also have bought two other things. It's very common. One is a tempered glass, the other one is maybe like a protective case for the phone. We know that majority part of the world, we love putting cases on our phones. In fact, I have a case on my phone right now, putting tempered glasses as well. So Amazon is like sort of telling you, hey, people who have bought that, they've also bought this. So they're making more sales and they're probably making it more convenient for you. You maybe require a tempered glass in a case and they're giving it to you at your fingertips, right? So that is association. It happens in Netflix. Maybe if you watch like 10 continuous crime detective stories, the 11th one Netflix is going to recommend to you is going to be a crime detective story. It's not going to be a comedy TV show they'll recommend to you, right? Because they know what it is that you want to learn or what it is that your tastes are and eventually cater to that. And all of that is happening by making use of machine learning, right? So guys, in terms of support for algorithms, there's amazing support for algorithms. If you want to quickly take a look at the supervised learning algorithms that are supported, of course, there's more algorithms that are supported, but as you can see, you have naive bias, you have decision trees, you have KNNs, K nearest neighbors, support vector machines, random forest algorithm, RFA as it's called, or SVM as support vector machines are called. These are like the really popular algorithms. And one side of your thought may be saying, hey, these are like 5 algorithms. How are they solving the entire world's problems? But you'll be surprised to understand how powerful they can get if you provide good quality and quantity of data to perform analysis, right? And in this particular demo, actually, we are going to be taking a look at a KNN implementation. We're going to be understanding how easy it is, how fun it is to work with KNN algorithm. And I'm going to be showing using the KNN algorithm as a demo in the practical section that I'm going to be showing, right? It's a really interesting demo. Don't worry, before I get into the practical aspect of the demo, at that section, I'm going to make sure that I'm going to explain to you, theoretically how the algorithm works and give you ample amount of examples so you understand it, and then take you guys to the code to help you understand it in the form of code, right? So supervised learning algorithms are great. What about unsupervised algorithms? Well, of course, think about clustering, think about Gaussian mixture models, neural networks, bi-clustering, density estimation. Now, even if you are slightly older into machine learning, even if you're experienced in machine learning, some of these names might be a surprise to you. And that again is one of the ways of the world, right? As I told you, majority of the machine learning applications out there mostly use supervised learning algorithms. And of course, there are ways in which unsupervised learning, you cannot match unsupervised learning in the way it learns. So of course you need support for it, and you're going to require some really good algorithms to make sure that at the end of the day you can use these to have powerful solutions at the end as well, right? So supervised algorithms, we took a look at it. Unsupervised algorithms, we took a look at it. And with this, I think it's the high time we take a look at the applications of Scikit-Learn. So coming to the next section, applications of Scikit-Learn, one of the most fascinating things about the domain of Scikit-Learn you have to understand is that it's extremely popular. When I say extremely popular, I should have probably put it out in caps, because again, right from Netflix to Amazon to healthcare, everyone around you, there's a very good chance the vegetable vendor around you might be using a bit of machine learning to understand what vegetables sell when and how good they sell in which season. There, I just gave you another solution to a problem statement, right? So You can actually, if you're talking about applications, you have to understand that we'll have to generalize a lot of things in this discussion, because at the end of the day, there is a lot that we can go on to discuss, right? So to actually give you a bit of an idea in terms of applications, look at this. We have everything from product development to neuroimaging. Neuroimaging basically talks about how you can, pick up all these MRI scans and CT scans and all of that, right? Pictures of your brain. And probably if you've ever seen a CT scan or an MRI of your brain, to an untrained eye, you have absolutely no clue what's going on. But to a trained eye, to a doctor, to a neurologist, or even to a very highly trained machine learning algorithm, it can make a ton of sense, which probably me and you cannot, because we are not experts, we're not doctors there, right? And then again, medical modeling, financial risk analytics, price predictions, everywhere. Medical modeling is really, really important, because even in the creation of vaccines, right, understanding how you can fight viruses and bacteria, you can have thousands of scenarios be trained by a machine learning algorithm to say what happens when this drug is maybe provided and is maybe pushed onto that virus, pushed onto that bacteria or whatever, right? So there's a ton of things in medical modeling that are using machine learning actively. Now it might come to a surprise to you that I'm highlighting healthcare so much, but please do understand that healthcare has been one of these domains which is extremely important for the humankind, but at the same time, this is a domain that is willing to go beyond anything to explore the power of machine learning, because there's a million things like DNA sequencing and whatnot that takes a ton of time, a ton of efforts, almost inhuman, and that to your machine learning algorithm will be a piece of cake, because at the end of the day, it can constantly do a task maybe 100 times, million times faster than what we could do, without getting bogged down, without getting bored, without getting tired, right? So that is what gives power to ML as a whole, and that is what it gives the biggest advantage to us as users. And then look at financial risk analytics. Financial risk analytics, I bet that your banks are using this at the moment, right? So how does your bank know the amount of loan that it should give to someone, right? Of course, there are these scores, CIBIL scores and all of that will tell you how good your credit score is and everything. But at the end of the day, it's a certain risk that is associated with a bank giving out a loan, because they only give you a loan if they're sure that you're going to pay it back, right? They don't want to lose money. But sometimes it so happens that there are defaulters, people who could not pay back. So they're going to use all those situations to learn and understand why people default loans, or why people are not able to pay loans. So they use that learning. To understand if they should provide a loan to someone, if they should provide an X amount of loan to someone having a Y amount of salary, right? So it's popularly used, it's being used as we speak right now. And price predictions are absolutely fantastic, be it in the stock market or be it in the vegetable market, because whenever someone tries to predict something that will happen, they're going to require a lot of data from the past and a lot of current data to see, analyze. And prediction is basically you trying to see if any pattern will repeat, you trying to understand if there's any new trends that might be created, or you understanding if there are other outcomes which will affect your current situations, right? Now again, we might see the increase in petrol prices as maybe a spark for the electric vehicle revolution around India, especially right now, right? So maybe one of that is leading to something else, and you want to analyze what is causing what happens if something else happens. All of that is easily possible with the use of Scikit-Learn, with the use of all of these. The applications are endless, right? Again, I have more for you. Think on the lines of weather prediction. Now, this is a very, very fascinating topic wherein you'll be surprised you have machine learning that is so well integrated into your life that you don't know it's there. Open up your mobile phones right now. I'm sure you might have it in your hand anyway. So open it up, be it on whatever phone you have. Say, hey Google, hey Siri, hey Alexa, hey to whichever voice assistant out there, which is first of all working on the basis of machine learning. Open it up and just ask the chatbot about what the weather is like tomorrow. Just say, hey Google, what is the weather like tomorrow morning? It will tell you what the weather is like tomorrow morning, and I am confident that it's going to be very, very, very accurate, right? It's not like it's randomly trying to guess tomorrow's weather. It's not saying, hey, tomorrow it'll rain. No, it's giving you a probability, a percentage. All those are data-driven answers that it is giving you, right? And then another really nice application of Scikit-Learn, which I absolutely am a huge fan of, is in emergency services. Now, think about what causes floods, right? An underwater earthquake in the middle of an ocean is where two tectonic plates move and it brings in a lot of water rapidly inside and it pushes all of that out. So when it pushes a ton of water out, you know what happens, right? After an earthquake, it's usually a flood, and that's the entire process of it basically. But what you should know is that it will only take a couple of seconds or a maximum a couple of minutes for a huge flood or a huge wave. Probably the wave is like 10 stories tall, 10 buildings tall. It'll take a couple of minutes to reach from the center of the ocean all the way to the coast or something like that, right? So in those emergency services, we cannot rely on human speed. Of course, we are great at a lot of things, but when it comes to certain things like this, if you have a computer there, it's great. Machine learning algorithms is constantly analyzing and assessing what the seismic activity is like. As soon as it sees a huge earthquake or anything that is alarming, it will automatically go on to do a lot of tasks it's supposed to do. Maybe it'll start raising some gates to ensure that flood water doesn't come in. It starts sounding alarms everywhere around the coast to make sure that people are moving away to safety and all of that, right? It will automatically do it the second it realizes there is a threat. There is no way that it can be done manually that fast, right? Someone is reading a seismograph, they see that something is wrong, they say, oh, okay, this is wrong, now let me call someone else, and that call goes to like 10 other people before starting the alarms. Every second here is a matter of life and death, and when that happens, machine learning will come to your rescue like a million times faster than a human. Maximum respect to all the emergency services personnel out there, because without them, none of this is possible. But just the fact that you can use machine learning as a helper there to make it even fast, I am a huge fan of that, right? And then think about text classification, audio processing, and all of that. You'll be surprised by the amount of feedback you can get just from the reviews of products. If you go to Amazon or any other place where you've seen a lot of reviews about people talking about a product, the owners can actually sit and analyze it in depth. They can get their machine learning algorithm to figure out the sentiment of your customers. Are they happy with your product? Are they sad about your product? Are they angry about your product? Or are they just neutral? Are they just saying that, it's a boring product, right? You can figure each and everything out, and you don't have to sit and read through a 1 lakh, 2 lakh, couple of million reviews to figure that out. Your machine learning algorithm will do it in a couple of seconds to tell you what is going on. That is the magic of machine learning, right? And then of course, predictive models, as I just told you, be it weather predictions or be it trying to use some sort of regression, trying to analyze, having current data about how that data will forecast something into the future. I don't think not a lot of other domains give you this capability to predict the future, right? Think about cloud computing, think about DevOps, think about all the other beautiful domains that are out there. I rarely find a domain that will give you the capability to predict what happens in the future like how machine learning does, right? That is the magic, that is the essence of machine learning. Well guys, now that we have understood all the applications of Scikit-Learn, I think it's high time we take a look at the advantages and some disadvantages of Scikit-Learn. Now, ladies and gentlemen, as I just told you, right, there are a lot of advantages and there is a small amount of disadvantages which you're supposed to know. So first, let's get away with the advantages, since we are, of course, building a lot of hype in terms of how powerful Scikit-Learn is. The first advantage, in my opinion, is that this library is extremely versatile in helping you solve multiple challenges, problems, not just in the technical domain, not just in the IT world, but be it any other non-technical domain out there. If you're creative and intelligent enough, you will find a way of how machine learning can be used to maybe better an already existing process. Again, I don't see a lot of other domains which are doing that. I don't have anything against the other domains, but this is a fantastic advantage which has to be like a heading when you're discussing advantages, right? And then, as I told you, Scikit-Learn is a library which is backed by an extremely talented community. A lot of talented and hardworking people and open source contributors are making sure that we can work with the library at ease. So it's a huge advantage for us because they put in their own efforts to simplify something really complex for us. And I think that is an advantage because it's these extremely talented and hardworking contributors that is making the library so amazing for us, right? So again, a lot of contribution from their side, and of course a lot of heartfelt thanks from my side and your side definitely to these guys, right? And then now I told you, I've been telling you one thing for a while right now. I'm telling you it can already better an existing process. Like it will fit into machine learning will fit into any domain out there. You must be asking a question when I said anything and all of that, because at the end of the day, you might say, hey, if there's something which is already existing and working and you suddenly bring machine learning, don't you think it becomes extremely difficult to make your machine learning model work with an already set up and beautifully working infrastructure? Well, with respect to Scikit-Learn, it provides a lot of elaborate API documentation to ensure that you get machine learning to talk really quick to your already existing solution out there, right? So it is not like I have a product, I want to throw that product out and start from the scratch because I cannot use ML with it. There are cases where that might happen, but at the end of the day, in the majority of the cases, you have to understand that many already existing platforms can integrate machine learning into it with ease due to the availability, due to the possibility of these API documentations that are available and made available to us by this beautiful community there, right? So, of course, I had to stop myself with the number of advantages there because I can go on and on and on and tell you about more and more advantages. Let's quickly talk about the disadvantages for a second. Now, in terms of disadvantages, ladies and gentlemen, there are one or two disadvantages, unfortunately. Let's just get into the discussion of them. The first point is Scikit-Learn ML models don't scale very well linearly. See, learning is usually a linear process when it comes to, right? You build up generally and you go on and you go on and you go on and work with that. But small machine learning algorithms are very easily built and worked with Scikit-Learn, but as and when the complexity of your solution goes large, that's where they really don't scale well linearly. You might think that you might require X amount of effort for a small problem, 3x the amount of effort for a large problem, but at the end of the day, it might have come to a fact that it would have probably taken you 10x of the effort to actually get it to be extremely well optimized and extremely working really well. That is not a disadvantage to a majority of the audience, or definitely for you guys as learners, because you'll not be getting into that extreme depths of having a production ready application built right away. But yeah, this is something you have to think about in the long term as well. It's not a bad thing, but it's a small step in the way that will probably get to you at a later stage. The second point is tedious hyperparameter tuning and optimization. As I just told you, it's never a situation where you start writing a machine learning algorithm and boom, you are done with it and you close it. No, the first time your machine learning model gives you a successful output, you're going to be the happiest guy, and you're going to be this person. If you're like me, you're going to be wondering, how can I make it better? How can I make it faster? How can I get its accuracy to be even better? So you will be wondering about what are the different things that you can do to get your algorithm to learn better. In fact, I'm going to be showing you hyperparameter tuning in the demo that we're about to discuss as well. I'll show you practically about how you can find out if your machine learning models can work better and eventually get it to work better, right? And of course, the last point says it needs better model performance reporting capabilities. Yes, I definitely agree with this because I've been using Scikit-Learn for a lot of years right now. And at the end of the day, after you've created your model, after you have had your output at hand, the way that you would report your output, right? There's a lot of things. There's something called classification report. There's an accuracy score. There's a couple of measures of accuracy where you have a matrix that will give you a lot of answers. A lot of ways are there, but is it the best that can be done? I'll say no to that, definitely. I think the community is also working towards that. At the end of the day, we want better ways to denote that our model performance is better. We want better ways to track how the model performance, why the model is behaving the way it does, and we want to do it intuitively, we want to do it easily, and at the end when we're reporting it, we want to make sure that it's not just us doing all the tedious manual tasks, but wherever possible, Scikit-Learn can help us do it better, right? That is at the end of the day the goal of Scikit-Learn, the goal of machine learning here as well. That's what we're after, right? Fantastic, guys. So these are some of the advantages and important disadvantages you definitely need to know about. And with that, I think we can come to the next section, which you guys are really excited for, I can already tell. So guys, coming to the next section, practical demonstration in Python. Now we had a chance to take a look at so many things over the last 45 minutes in terms of theory, right? What is Scikit-Learn? A bit about machine learning. What does Scikit-Learn help us? How is it helping us in terms of machine learning? Why is it so popular? How old is it? What about the community? Is it free? Is it paid? How does it work? What are its popular applications? What are its advantages and disadvantages? We had a chance to take in a ton of valuable information theoretically, but I think it's high time we take a look at understanding maybe one algorithm practically, right? So, as I already told you, I didn't want to keep you guys like completely, in the dark and mysterious until the end. So I told you we're going to be using KNN algorithm. So KNN basically stands for K nearest neighbor algorithm. It's a beautiful algorithm. I am absolutely a huge fan of it and it works really well. First, let me take up one or two examples to explain what the algorithm does, and later let me take you to code to showcase how it works, right? To give you an example of nearest neighbor, basically you understand, if let's just say you are a data point in the algorithm right now, you understand what you would do based on your nearest neighbors, right? As in when I start explaining, it's going to make a lot of sense, but you're basically giving data certain meaning based on everything that is around that. Now, if you know clustering, if you know association, this is where, of course, it's a supervised learning algorithm, but those concepts are very similar to how this algorithm works. Now, I'll give you an example. Maybe let's just say you want to walk to your nearest ice cream store. The ice cream store, let's just say I can see it from my apartment. Maybe it's just 100 meters away. Now, there are a lot of ways I can reach that ice cream shop, right? Some meaningful ways, some meaningless ways. You might laugh at this, but this is a possibility and a probability. First way is I just get down, I walk directly to the ice cream shop, I buy a beautiful ice cream, I come home, done deal. The second way, the way that you will never do is probably you booking a flight to Delhi from Bangalore, going all the way to Delhi, not doing anything there, flying back from Delhi, going directly to the ice cream store, buying ice cream, coming back to your home. Yeah, I know you're surprised, but that is a possibility as well, right? So you can use one of these two concepts as an explanation to say there are probabilities you have to explore before giving your data some meaning, and that can never be better told than in the KNN algorithm that we are going to be discussing, right? So let's just talk about a very simple classification example in KNN. What I want to do is I want to have a certain data set at hand. I want to have the height and weight of a lot of people, male and female population in our hypothetical data set. And I want to try to predict if based on the height and just the height and the weight. So as I just told you, right, we're just trying to predict the height and the weight of a person regardless of their gender at the moment. And here is the data that we have at hand. Now look at this. Right now I know the male and the female population because I want to just plot it on a chart to show you guys. Here's all the height details. Here's all the weight details of a certain population, right? Let's just consider that all of this is hypothetical at the moment, but you can see a certain pattern when you actually plot it on a graph. Now what I have done is, as you can see, I have 7 details, right? Now this is details of 7 different individuals. Now out of those 7 people, 4 of them are male, 3 of them are female, correct? We know that. But if I plot it on a graph, as you can see, there is a common pattern that's appearing here. You can probably see that the females maybe have slightly lesser height and maybe they weigh slightly less than the male population of data. And you can see all of these pink triangles are females, and you can see all of these green circles or green spheres. These are the male population. Now we have 7 people's worth of data, and what I'm going to do is I'm going to add one more person. Now this person, all I know is that their height is 190, their weight is 100 kilos. That is it. I have no idea if this person is male or if this person is female. So let me plot it on the graph. Now as you can see, this new blue color square, this cute blue color square that I have here is this new population, right? This is the new data that I just plotted there. Now, even if you do not perform machine learning, even if you are not extremely well versed with machine learning, as soon as you look at that blue dot, in which area that it is placed, looking at its nearest neighbors, do you think that that person is a male or that person is a female? I bet at this moment that you guys are saying that's a male. How did you know that that's a male? I've just given you height and weight. What you would have probably done is you would have looked at all the points around that to say, hey, so this person weighs almost similar to weighs and has the same height as the other guys. Good chance the person is a guy. Exactly. This is how your machine learning algorithm is going to learn in KNN as well. Now, what I'm going to do is to give it some sort of meaning while learning. I'm going to say, hey, if you want to understand if you're a male or a female, just look at 3 or 4 people around you to figure out who they are. Now, if I say KNN, K is basically a value there from 1 to infinity. And now I'm going to tell, hey, take a look at the 3 nearest neighbors there. When I say K equal to 3, I'm telling my algorithm, take a look at 3 nearest neighbors around you to see if they're male or female. And based on that, you can learn if you're male or female. And it looks at 3 people around it. It says, hey, everyone here is a male. Good chance even I am a male as well. Now you might say, hey, why did you take K equal to 3? Now take K equal to 5. Even if I take K equal to 5, you can realize that 4 of its nearest neighbors are male people, and 1 of its nearest entity is a female. Now you might say, oh, now all are not male, 1 female is also there. What are you going to do? What you're going to do basically is to figure out the majority is what again? Majority of your nearest neighbors are whom? Male or female? You have your answer there, right? Now, why we go on to pick up k values to be odd, 3, 5, 7 and all of that is because it works really, really well when we have two classes that we are actually comparing. In this case, two classes, all we have is male, female for our hypothetical example. That is it. We're not considering anything else, right? So for that situation, k odd values work really well. You'll see that they do work well when we go on to actually take a look at practical discussion here, right? Now, I told you about the Boston housing dataset comes built in. Now, I have the dataset at hand, so I can manually go on to import it and start working with it as well. So what we are going to be doing with this dataset is we're going to be using the KNN algorithm to see if it can predict the price of the house in the area somewhere around in Boston, right? That's the dataset we have in hand. So all we are trying to say is get the machine learning algorithm to figure out why your house can be expensive. Now, you know a lot of reasons why your house might be expensive. It depends on the age of the house. It depends on how many people can stay in the house, how many cars you can park in the house, what locality is your house a part of, how far away is your house from the airport, how far away is it from the school, what is the crime rate in your neighborhood, right? Because even if it is the most posh house, if you're building a castle, if it's in a neighborhood which is very shady and very bad, it's not going to be worth a lot of money, right? So what is it that gives the meaning? What is it that has the most oomph, most emphasis when it comes to predicting the price of a house is exactly what we're going to be using KNN to work with this, right? Now, ladies and gentlemen, I'm going to be using Google Colab to showcase the code to you guys. Google Colab is nothing but a Jupyter notebook that is hosted on the Google Cloud platform. You can work with this code in any IDE that you want to use. If you're working with PyCharm, you can work with it. You're using a regular Jupyter notebook, you can work with it. If you're using Colab like me, I love Colab for multiple reasons. You can use that as well, right? So let's quickly go back to Colab and let's get started with the practical discussion. Alright guys, so as you can see, I have Google Colab open. We're going to be understanding Scikit-Learn using a small KNN algorithm demonstration. Now, my goal with this demonstration for you guys is not to show how to write Python code and how to ensure that you get to the result, but my goal is to tell you guys and showcase to you guys that it is really, really, really simple and very powerful to use a machine learning algorithm like KNN and get your solution done using the algorithm, right? So let us actually zoom in so all of you all can see the code. The first piece of code, while working on any sort of solution, my way and the most common way is to basically import all the libraries that you're going to be using. As I told you, NumPy and Pandas we're going to be requiring because as you can see right here, right, this line is talking about us importing our entire housing data set. This uses Pandas and we have multiple use for NumPy, Pandas and all of that, and this is the library we are after. Now, if you're wondering why it does not return Scikit-Learn, well, sklearn, whenever you see it in Python code, understand it's the same as Scikit-Learn. Now, in fact, as soon as I run this demo, it's going to give me a small error. It's going to say, hey, I have no clue where your data set is. You're asking me to execute a data set that I don't know where it is. Now, that is because it's sitting in the Google Cloud platform and the data set is in my laptop. Now, what I have to do is I have to import it into my working environment. I run this piece of code again and boom, it works like magic, right? Now it knows where the data set is. Look at that. So what are we trying to look at it here? Now, every single column here is basically, it's basically a data point associated with respect to house. Every row is a house worth of data. You can see the crime rate in the area where this house is. You can see the age of the house, the amount of tax that has to be paid. You can see like so many different things about a house that will eventually give it a lot of meaning. These are the reasons why a house might cost so much. You and me know this. Our machine learning model might not. So the first step, one thing you have to really be careful about when you're working with machine learning is your data has to be pre-processed really, really well. If you provide bad data, if you provide incorrect data to your machine learning algorithm, it will learn things incorrectly and it will not know what is right or wrong. Now, if I show you a cat and if I tell you guys this is not a cat, this is a dog and it says meow. Have you ever seen a dog which goes meow? Not really. You'll be like, hey, what the hell? But if I show that to my machine learning algorithm, while it is learning and say, hey, this is a cat, if I show you a dog and says it goes meow, machine learning algorithm will not know a difference. It's going to be like, oh, okay, so this is what a cat does, let me learn this. Or this is what a dog does, let me learn this. You know that a cat cannot go bow bow, or you know that a dog cannot go meow, right? So that's the thing, you have to provide high quality and good quantity of data. And in this step that you can see one line of code, all I'm trying to figure out if there are any NaN values. NaN stands for not a number. Now, for example, when this data set was created, when people were writing the age of the house, it is a number, right? You can see all of these are numbers. None of this is textual data. Someone might have entered a textual data by mistake. Instead of the age of the house, they might have written their name or the name of the house. that is incorrect, and your machine learning algorithm will flip when it's learning at that point, because it doesn't know why it's different, and your accuracy can fail really, really bad. So with this, we try to figure out if there are any such weird values which are not used, which in fact hurt the algorithm, and we have to remove it. Thankfully, my data set is already clean, so we don't have to do all of that. And we come to the next step, which is really, really important, because here is where we take the entire data set. Now, I showed you first 5 rows. We have hundreds of thousands of rows there. We take that entire data set, we split it into 2 pieces. One piece consists of 70% of data. Now, this is the data that my machine learning algorithm is going to use to learn. Similar to like a textbook in your college. Now, you're going to use that textbook to learn, and later you're going to see new questions or some similar questions asked in the examinations, right? So I'm going to hold 30% of the data away from it. It's never going to see it until the end after it learns. That is when I say, hey, now that you've learned something, let me give you a little examination. Let me give you a little test to see what you've figured out. So on an average, we usually send somewhere around anything above 50%, 50, 60, 70, 80, 90% of data for training. The rest is going to be for testing, right? So all we're doing right now is we are just basically splitting the data into 2 pieces. Now, I said 70% for training. How do you know that? Well, I have a attribute here which says test size equal to 0.3. Well, what I'm saying is take the entire data set, cut 30% out of it, keep it for testing, everything else, which is 70%, goes for training, right? And this is where the magic starts happening. You can see that you were using Scikit-Learn, we're importing the algorithm that we want to use, and basically we are loading that we want to. I'm saying to Python right now, saying, hey, I want to work with KNN, and I want a value of K to be 3. Right? This is what you see in the bracket. Wherever it says 3 here, it basically means that you're using K equal to 3 to work with this machine learning algorithm. I hit play, it executes it, and right now we are telling the Python model that, hey, we are using this algorithm. The next part is model fitting. Model fitting, for all of you all who are new to machine learning, here is where all the magic happens, and this is where you might have a really bright smile on your face right now, is me telling you that, hey guys, this is the step where your machine learning algorithm finishes learning one line of code, one simple line of code, and as soon as I run this, yeah, it basically told me that it has used a couple of metrics to go on to learn. Don't worry if you know what any of these means, it's okay at this moment of time. But as soon as I ran that piece of code, my machine learning model has now learned everything it has to know about that data set. Well, great, it has learned something, but I want to figure out what it has learned. So I'm gonna pass it the testing data right now instead of the training data. If I provide training data again, it's gonna give me 100% result. Think of it like you being in your examination hall, and I come in and say, here's a textbook, write your examination. You don't have to learn anything. You can copy paste, right? To avoid that, here is a genuine examination that I give. The process is called model prediction. And as soon as I run that, now basically the model has also proved its worth to me. But how will I know that the K equal to 3 value that I used here, that is the best value that I can use for the machine learning algorithm? How will I know that there is nothing better than that? This is where hyperparameter comes into the picture. Now, what I am going to be doing is basically I'm going to take the K value from 1 to 50, and I'm going to train the machine learning algorithm 50 different times, and to see where the error rate is the lowest. Wherever the error rate is the lowest, it means that there the model is working really, really well. Now, as soon as I hit play there, look at this. This is all the error rate that's obtained for various values from K1 to K value to be 49. Now, you can see that it's already put out in a sort of a numerical alphabetical order here, ascending order, not exactly, but you can take a look at this. K equal to 1, there's a very high error of 7.97, 7.1. The lowest that I can see right now is 7.004. This is the lowest error rate, and this is, we are obtaining this error rate when K equal to 4. Well, initially what we did, we thought that K equal to 3 will be the best accuracy for our machine learning algorithm. Now, when we are tweaking and tuning the algorithm, you can see that no, at K equal to 4, you have even better accuracy. This is how you perform this process called hyperparameter tuning. Now, all of this is happening again. Think about it. 1, 2, 3 lines of code. That's it, right? Well, what is the last step then? The last step is for us to tell you guys what is the accuracy of your machine learning model, or even the error rate. And as you can see, the error rate when K equal to 3, this was because we used K equal to 3 for training, you can already see that this is the error rate for the machine learning algorithm, right? So let me actually go on to remove all the outputs. I'll clear the outputs. I'm going to zoom out. You might not be able to see any code right now because it's going to become very tiny, but look at this. Here is where we started our demo, and we've done this in what? Everything is done maybe in 20-25 lines. 25 lines, right from us importing libraries all the way to us actually finding out the error, getting the machine learning algorithm to learn, predict, give us an output that we can use. Did this look like we used thousands of lines? Absolutely not. Did it look like we used hundreds of lines? Absolutely not. We used 25 lines. Yes, this is a very basic demonstration, but at the end of the day, even when you try to implement really complex situations, your Python code is still going to remain same. It's really going to be simple. The way you would implement it would change. That's it, right? So this simplicity that is Scikit-Learn, everything, all these individual lines that I just showed you, all of these are part of Scikit-Learn. Without these, probably for model fitting, if you have to manually do it, maybe you have to write another 100 lines of code just here in that one slot that I've highlighted. Now you replace 100 by 1. This, ladies and gentlemen, as you can see in the demo, is the power of Scikit-Learn. And I'm sure as soon as we complete this demo, as soon as you're done with the demo, you would have figured out on your own that this is a very, very powerful algorithm and a very powerful library, in fact, in Python, right? So coming to understanding SciPy as a library itself, right? One thing that I should tell you at this moment right now is the fact that SciPy is an extremely popular library in Python. There's thousands and thousands of users. And, when you say it's a library that is really popular, definitely you have to give reasons of why it is popular, right? Now, the entire scientific community, they required a library through which, you can perform certain tasks which you had to do manually otherwise, right? Think about working with algorithms. Think about already having functions which definitely will do the task for you, right? So sometimes what is a function, right? When you think about a function, it's basically, having an equation, solving a lot of things and eventually getting a result after you provide a certain input. That entire process from input to output will be automated if you have readily built functions that can take up the task. Right? So that is possible here as well. And when you think about working with the interactive Python sessions that are out there, right? So what SciPy does, the biggest advantage is that it provides us with high-level commands and classes which we can use to not only just visualize data, but also manipulate it and work with it in real time. Now I'm going to be showing you all the demonstrations, practical demonstrations through which you can see for yourself that, hey, yes, SciPy is a library which is very powerful and it definitely sees its fit in multiple domains out there, right? So whenever the world talks about scientific computing, whenever the world talks about technical computing where there is a requirement of Python, you can be rest assured that SciPy will be the library that's going to be popular there. Now, after you've understood this about SciPy, here's a very interesting fact you may or may not know about the library. SciPy is basically built, on top of NumPy, and therefore, whenever you have a situation where you have to use SciPy and NumPy as well, right? If you just import SciPy, you're good enough. You can work with all the functionality that NumPy brings to the table, right? In the data visualization scene, if you know that SeaBorn is built on top of Matplotlib, right? Similarly, here SciPy is built on top of NumPy, so it brings all the functionality of NumPy and then some, and that definitely is making it's adding more efficiency into the pipeline, and at the end of the day, it's simplifying not just the way you work with Python code, but the syntax through which you write, right? That is becoming more simple as well. So guys, with that introduction to SciPy, let us quickly come to a section where we can discuss how you can go about installing SciPy. Now, there are many ways about installing SciPy, and the biggest advantage is that just like Python, SciPy is supported across multiple operating systems that we have today. And of course, you can have a list of operating systems, but I'm going to be picking up the top 3 operating systems that we have today. One is Microsoft Windows. We have all the Linux flavors and distributions, and then we have Apple's Macintosh, right? Mac operating system. So, if you're using either one of these, I'm sure, you guys viewing this, you'll be using all 3 of these, or, you have definitely used either 3 of these, right? So it's going to be a real simple process to install it. We're going to be dividing the installation into 2 steps. One place, where we'll be discussing for Windows and Linux, and the other one is slightly separate because, Mac and Apple has their own architecture to play with, right? So coming to Windows and Linux. Now, one very good thing about Windows and Linux, and of course, whenever you're working with the Python command line here, is that you have this ability, you have something called pip. Pip basically stands for package installer, right? Pip, in fact, it's a recursive acronym which stands for pip installs packages, PIP. Pip installs packages. So it is basically a package installer, a package manager, which will help us install all of these libraries at ease, right? The advantage that pip brings to the table is that it's a standard package manager, as in it can be installed very easily on Windows, on Linux, and more, right? So to basically, to install SciPy using pip, all you have to do is run one simple command that you can see on your screen right now. Look at the last line, which is in bold. It says pip install SciPy. It's literally these three words, and with these you can definitely clear up. And I'm sure if you've if you're watching this course, you might have had some experience with pip and installing packages. So again, it's a very simple and a very straightforward process of how you can install it on Windows and Linux. But there isn't, there's more advantages to Windows and Linux. The fact that we have Anaconda distribution, right? Anaconda is an absolutely fantastic distribution, which will not just give you everything you require in Python, but it will also give you other libraries, other helpers, other tools, other frameworks, and it brings a lot to the picture through which you can start, creating applications. And eventually with Anaconda, right? When you start working with Anaconda's distribution, it's a fact where it will already come built with multiple libraries that you don't have to work with. Now, installing SciPy in Anaconda is very simple. All you have to do is go to Anaconda's website. You have to download something called as the Anaconda Navigator, and once you open it, start installing. You will have something called as the Anaconda prompt. Anaconda prompt is very similar to the command prompt or the Python CUI that you would have seen. Again, once you do all these steps, it's a very simple step of running one single command, conda install Anaconda SciPy. And that is it. As soon as you run this conda command or either the pip command, regardless of both ways, you will have SciPy installed and set up on your Windows. And it is the exact same steps that you'll be following for Linux as well. Now, if you're wondering, yes, Anaconda is available for both. It's available for all these Mac users. It's available for Linux. It's available for Windows and a lot of other operating systems as well. So again, you have one more way of doing something which is already simple, right? That, it's fun when you think about how simplified the process of setting everything up is these days, right? So, Windows and Linux aside, let's talk about Mac OS for a second. I'm sure, you viewers are, probably, watching this on your Mac right now. So, the slight disadvantage with Mac is that it doesn't come pre-installed, with any package manager out there. So, what you can do to sort of work around the small disadvantage is that you can install your own package managers there, right? So you can see two commands. You can see a couple of commands on your screen right now. If you actually head to the terminal and run these commands, guess what? With just these one command, right, the sudo port install command, you can go about, installing 3 libraries, 4 libraries, SciPy, Matplotlib, Pandas, and the NumPy library as well, right? Again, it's not a step where you have to break your head. You have to do like 100 different things to install the library. You just have to open up the terminal. You just have to copy paste what you see and eventually hit paste, and you're done, right? How simple is that? And doing that will set everything up in SciPy that you will require, to follow along with all the demonstrations that we'll go about doing it, right? And one advantage with Mac, I wouldn't say advantage, it's a slight helper is for a fact that just like Windows and Linux, where we had multiple ways of installing, here also you have multiple ways of installing. You can use Homebrew to install all these packages, right? But one thing, again, a small disadvantage here by using Homebrew is that whenever you try to install SciPy through Homebrew, it will not bring the entire library, right? Now, SciPy is a huge library, as you're going to see through the rest of the course. Of course, we're not going to be covering every single thing in detail, but we are going to be covering all the really important stuff that you guys have to know. And to get to that point, if you're using Mac, again, we have one command, brew install NumPy, SciPy, IPython, Jupyter, right? Now, this will install a lot of things. It's going to install NumPy, which is the library. It's going to install SciPy, again, which is the library under discussion. IPython stands for interactive Python, and we have Jupyter, basically a Jupyter notebook server client architecture there, right? So all of this is installed to you again using one command, and you really don't have to put a lot of effort in setting it up. Right? Now that we have some clarity on knowing what SciPy is, knowing where it is used, what it can do, and a bit of how we can go about installing it as well, and hoping that all of you all have SciPy installed at this moment, we can jump right into the next section where we'll be discussing all of these sub packages in SciPy, which is literally at the heart of the concept, right? Without knowing these, there is no understanding SciPy at all. So talking about the sub-packages in SciPy, one advantage is that SciPy supports multiple sub-packages that are out there. Now, there are many dedicated software tools which become necessary whenever you're working with scientific computing, right? Just the term scientific computing seems very complex to think about it, but when you have to implement it in Python, of course, you cannot just have one library, you cannot just have one single entity, tool, or technique that will always work for all the solutions. It doesn't happen, right? So what SciPy does is it is considered as a very important tool. It is considered as a library, which is not only just providing one single aspect of it. It's not saying, hey, just use statistics, just use image processing, just use this, right? It's offering multiple Python modules that you can use, and you can use all of these at once if you choose to tackle everything that's required to perform scientific computing or any sort of technical analysis that's required as well. This is a very popular tool to be used, right? Now, look at your screen. You have multiple sub-packages out there. Of course, we're going to be discussing a couple of these in a small bit of detail, but you have to understand that each of these are used in their own specific purposes, right? Now, you have clustering algorithms. Clustering is a very important part of machine learning, right? You've used clustering again. Just think of a simple example where you're given a couple of fruits and people say, hey, can you put all the oranges on the left side? Can you put all the apples on the right side? Can you keep all the bananas at a different place? You can do that, right? If you can do that, you basically know what clustering can be. There's various types of clustering. There's hierarchical clustering, divisive clustering, agglomerative clustering. There's a lot of types of clustering, but what you should know is that SciPy is going to be giving you a lot of functions and a lot of easier ways to go about doing everything that I said. Right? And since we're talking about scientific computing, of course, there's going to be a good amount of physics involved as well. So wherever people are using Python for physics solutions, guess what? SciPy is also providing certain mathematical constants that you can use, right? Now, we all know the most famous constant out there, pi, right? Pi is 3.1418. So on and so on. Now there's multiple, there's a lot of constants if you think about it. There's Boltzmann constant, there's a lot of numbers out there. All of these complex stuff, there's Chandrasekhar limit, there's many concepts. And if you are a astrophysics geek like me, you will definitely be familiar with how complex things can get there, right? So SciPy is providing a way of handling all of that easily. And FFTPack, if you're wondering what FFT stands for, basically it stands for Fourier transforms, right? Fourier transforms are a very important part of handling and working with differential equations. And if you've ever used that, or if you're trying to solve differential equations using Fourier transforms, and you want to apply all of these transforms, Fourier transform inverse, Fourier transforms, and all of that, you have helpers out here that will help you do it easily, right? And Fourier transform is a part of mathematics, but another very important part of mathematics that you might have studied in school or college is integration, right? So for all your integration requirement, there is again another sub-package called SciPy.integrate. And if that wasn't enough, guess what? Look at it, right? We have more. We have one thing to perform interpolation. We have another library, Linalg. Again, as I just told you, right? Linalg stands for linear algebra. So for all your linear algebra routines, you have a sub-package ready to go. If you have a requirement where you have to work with a lot of data input and a constant source of data filtering and data outputs, you have SciPy.io as well, right? IO talks all about how you can handle data inputs and outputs. And then you have Ndimage. Ndimage basically stands for n-dimensional image, right? So it's, you can work with images in one dimension, you can work with images in 2 dimensions, 3 dimensions, and all of that. So whenever you are working with multiple images, I'm going to be showing you all of these practically, but for now, to quickly give you a picture about what it is that you can expect going ahead, right? We're going to be discussing a couple of these libraries. Let's pick up 5 or 6 of these, which are super important for you to know in SciPy, and eventually we can get started with that, right? And if that wasn't enough, there is more. There are more sub packages, right? There's ODR, which basically stands for orthogonal distance regression. You have direct optimization helpers, and look at SciPy.signal, right? I told you it plays a very important role in signal processing. We have a sub package that does just that. We have sparse. Whenever if you have worked in detail with applied mathematics, there's a very good chance you might know what a sparse matrix is, right? So handling all of the operations that it brings can be done easily as well. And whenever you're working with data structures and algorithms, we have a library for that. Any sort of other special functions that you can think, we have libraries for that as well. And stats, of course, talks about statistics. Weaves talk about how well you can perform certain writing tasks by making use of these sub packages as well, right? So let me just quickly go back here, and you can see that each of these sub package can work as a standalone sub package, work in dependency with all the others. So depending on, you might be asking right now saying, so how will I know what sub package I should pick up for my applications? Well, what it is that you're doing in your application will directly influence what sub package you might be using. If you're working with signal processing, it is clear as day that you're going to be using this. If you're working with statistics, you have a package for that. If you're working with image processing and you want to use a bit of SciPy there, again, you know which sub package to go about now, right? So I hope this quick introduction to tell you that these are the sub packages which give power to the library are clear to all of you all. So without further ado, I think it's high time we jump right into understanding each of these, not only just theoretically, but practically at the same time, right? So let's talk about SciPy cluster. Now, ladies and gentlemen, clustering becomes a very, very important part of SciPy, of Python, of all the practical applications we have in today's world. Clustering talks about how you can take one common data set or a heap of data and how you can divide it based on certain data points, based on similarities, based on dissimilarities to other groups as well, right? Now, think about the apple, the orange, and the banana example that I gave you. An apple as a fruit is fundamentally different to an orange. An orange is fundamentally different to a banana, right? So when you bring it all together, it's a jumbled pack. But when I say, hey, I want clusters of different fruits, that's when you know you get to pick all the similar characteristics, right? Now, when I say, hey, keep all the bananas aside, it can be raw bananas, it can be ripe bananas, everything. Now, I'm asking you to filter it and cluster it based on the type of fruit, not based on the type if the fruit is either raw or if it's ripe or anything like that. And if that were the case, guess what? You can have more clusters to go about doing this, right? So whenever you do these, whenever you take this entire basket of fruits or anything for that matter, put it out into separate entities, each of these separate entities that we have in discussion right now, as you already know, they are called as clusters, right? So working with clusters, handling clusters becomes very, very simple in SciPy. And at this moment, you might be asking a question saying, okay, so clusters is a very wide term of how you can go about using SciPy. Is there any further modularity that will help you understand? Well, yes, there are two types of clusters that are out there. We have central clusters and we have hierarchical clustering as well, right? Now, let me give you a small example to tell you what we're going to be doing. Now, we'll be talking about a demo where we'll be using NumPy to generate set of random points. What we are going to be using is, after creating two sets of random points, we're going to be joining all of these and eventually we whiten the data. What basically whitening the data means is that whenever you take a look at a lot of data points, right, it usually has a way of distributing itself. Think about normal distribution, think about other distributions, right? So each of these distributions bring its own characteristic, and that characteristic is what gives Python, is what gives library the understanding, the fundamental understanding about what is going on with the data, right? Now, you look at data, you understand it. I look at data, I understand, because we have trained as humans. Your machine isn't, right? So to get to a point where it can figure out certain patterns, we require whitening the data. Now, whitening, as I just told you, it takes like a lot of data, it groups it, crunches it into a certain workable range. And this workable range becomes very critical for us, be it in binary operations, be it in non-binary multiple categorical variable based solutions as well. Now, k-means clustering is a very popular way of how you can go about clustering. And what we'll do is we're going to take all the data that we just took together and we eventually brought it together. We whiten the data. Now what we'll do is we're going to be using the k-means functions and just pass all of the data to it and eventually give it the number of clusters that we want. And those many clusters will be created at the end of the day. So what are we doing? We generated a couple of random data. We eventually brought it together. We ran it through k-means clustering. And after that, we ran it through a function where, we can go about talking about how divisive and, to what level of modularity that you require with the SciPy clusters that we're talking about, right? So guys, it's not just theory. Everything that we're going to be discussing from now on is going to be practical as well. So let me quickly open up Google Colab. Google Colab is nothing but a Jupyter notebook that is hosted on the Google Cloud platform, right? So it's basically your regular Jupyter notebook, but it has many advantages and it works on the Google Cloud platform. So you don't require extremely powerful CPUs, GPUs or anything to work with efficiently as well. To a certain extent, to 95 or 90% of the users, to all the applications that they are going to be devising using Google Colab, it is free. But of course, there's pro plans and all of that. But for now, for everything that we're going to discuss, the free version of Colab, and it's majorly free, right? Only a small chunk of people who require high amount of processing RAM and storage, they prefer the paid version of Colab, but for the rest of us, this should be fine. So let me quickly open up Google Colab and we can discuss this exact, example that we have in consideration. Alright guys, so as you can see, I just quickly opened up Colab. Colab, you can just follow through the same URL, colab.research.google.com, or just go to Google and type Google Colab, C-O-L-A-B, and it will bring you here, right? So as you can see, we're going to be discussing a lot of, these sub packages practically as well. But to quickly talk about clusters that we have, right? Now we discussed what we're going to be doing already. And whenever you're working with any sort of solution, the first step that you have to do is import all the libraries that you're going to require, right? Importing SciPy, importing NumPy, Matplotlib, SeaBorn, and all of these libraries which we require to work with. As I told you, we're going to be creating two clusters A and B filled with 50 random data points, right? 50 each. Overall, we'll have 100 points. 100 is being divided into two, and each of these is getting into one cluster A, and each of these is getting to one cluster B. And after that, we're going to be normalizing the data. Once we go about normalizing the data, now we have to understand, okay, so how can we go about creating clusters, right? So you have two very different data points which are random, but there has to be certain patterns and there has to be certain ways you can go about performing clustering using k-means, which will eventually create the clusters that we require, right? Now we're going to be using these two clusters to find data, find similarity, create clusters, and all we're doing is we're creating a plot to showcase to you guys how we can go about doing, right? Look at the logic, right? The logic basically is 1, 2, 3, 4, 5 lines. When you think about the entire thing, less than 10 lines is the heart of your logic, where you can create random data, create clusters, run it through k-means, eventually even provide a data visualization. Now, my goal here is not to walk you through each and every single line of code of what it means, because I'm sure if you are here at this moment of time, if you're looking forward to learning Python, you might know a bit about reading Python syntax and understanding Python's syntax, right? Now look at this. We had two very different data points, and here you can see that it has created two clusters for us, right? This is a graph that is showcasing what each of these points were mapped, and once the points got mapped, where were these clusters? So you can see these two red dots, which is basically plotting the center of these two clusters at hand. And again, 5-6 lines, and we can do a lot of these things, right? Now imagine you had to get to this result, but you had to do all of it manually. That would have been a pain, right? Because at the end of the day, you have to write a lot of code to not get a lot of output. But here it's the reverse. We are writing a small amount of code to have a very large output, right? So guys, this is SciPy Clusters, a very simple demo to showcase to you guys about how you can go about working with that. Now, the next thing that we're going to be doing after understanding SciPy Clusters is we're going to be taking a look at SciPy Constant. As I told you, whenever there's a requirement of you working with multiple constants, mathematical constants, constants in physics and all of that, at the end of the day, everything is a mathematical constant. But, these values which have a certain significance and they don't change, there, as I told you, there's hundreds of constants, and it becomes inhuman. It becomes impossible for someone to memorize what each of these constants are, right? They're very complex decimal numbers when you look at it, 3.141 8, or it just keeps going and going in many cases, right? So what is the way of how you can simplify this? One way of simplifying is you don't have to remember what the constant is. If you know what constant you require to be used in your application, in your solution, which of course you will know, it's as easy as importing it, finding its value, grabbing the value, using it for your applications. How simple is this? Right? So it's not just one or two constants that's actually provided in Python. There's various types of constants. SciPy.constants subpackage itself is a very, very popular subpackage. And whenever anyone is talking about the use in the case of general scientific purposes, this library, this subpackage is very popular there, right? So let's quickly take a look at how we can work with these constant variables, how we can import it, and how we can go about using it. But just before that, I want to also tell you that these are some of the constants that you can work with and you can take a look at as well. We know C, E is equal to mc square, Einstein's relativity. The C talks about the speed of light. You can have various physical constants that talk about it. G is basically the Newton constant for gravity. E talks about elementary charge, molar gas constants, Avogadro constant, Boltzmann constant, electron mass, neutron mass, Planck's constant. Look at this, right? It is absolutely a treat. If you're a person who's into physics, if you're a person who wants to use the world of computing, the world of IT to simplify something in an already complex world of physics, you have all of these constants right at the grab of your hands to go about working with them in an easy fashion, right? So let me quickly open up these cells here and we can go about working with it. Now, one constant that you would have seen in the world is something called as the golden ratio, right? The golden ratio is basically like a spiral which talks about having, it talks about almost everything in the universe having a certain pattern that you can trace and come about, right? It's called as the golden ratio. Now, the golden ratio is a very simple number actually. At the end of the day, it's 1.6 something. Yes. So it's 1.6180. And this is a number which again talks about, many cases where you're trying to, this number is very important. If you're trying to design a room for a home theater, for say, it has to be some specific dimensions. Whenever you go to a theater, it's not just randomly built. There's a very good chance someone, if it is designed properly to the utmost care, they would have used something called as the golden ratio there as well, right? So now I am a huge fan of theaters and all of that. So I just thought this is a good example to show you guys. Now for all you physics buffs out there who are saying, hey, show me a physics example, well, guess what? The Boltzmann constant that we just discussed, right? Look at this. It's just one line. And this command find is basically telling us what all it has, anything which has the name Boltzmann in it. And as you can see, right, you have Boltzmann constant and you have it in multiple SI units out here. SI unit is something that you would remember, right? Whenever we talk about temperature, it's degrees Celsius. Whenever you say EV, I think it's electron volts, and K stands for Kelvin. Hertz is a measure of frequency and all of that, right? So what it is basically saying is, hey, when I say, hey, tell me all the Boltzmann constant types that are out there. So the constant is going to be the same, but the value of the constant is going to change with respect to various SI units that you're going to be using, right? Various situations that it's going to be used. So it is telling me these are all the list of constants that you can use in terms of Boltzmann. I say, hey, okay, so now I know what constant I require it. I want it in Hertz per Kelvin. And as soon as I hit, play here, it's giving me the constant value that's out there right now. How simple do you think this is, right? At the end of the day, you don't have to break your head about remembering, a very complex number such as this. And that itself is a small advantage. And as you can see, with another advantage with Google Colab is all you have to do is move your mouse to the code and it will basically tell you how many physical constants that are out there. It'll tell you it's 444 physical constants that it has, right? Just like Boltzmann, you can pick up all the constants that I just showed you, speed of light and all of that, and you can have some fun with it. Right now, I want you guys to get your hands slightly dirty, and since it's just 2-3 lines of code, right? Overall, the entire thing is 3 lines of code. 1, 2, 3. That's it, right? Now, I want you guys to go about doing this for other constants that we just discussed. So quickly rewind back to the part of the video where I showed you the other constants. Try to figure out for yourself how you can go about doing it. It's very simple. You have to change 1 or 2 tiny things, and I am confident that all of you all watching this will get about how you can go about doing that, right? Fantastic. Next, let's quickly talk about Fourier transforms, right? Fourier transforms basically FFTPack, as we already told you. FFT. If you're wondering why we have two Fs, the first F stands for fast Fourier transformation. So whenever you're working with these algorithms, whenever you're working with generic computing and specific scientific applications, you're gonna be using multiple mathematical techniques to go about doing it. DFT is a mathematical technique where you take all these spatial data around you and you take the spatial data, convert it into frequency data. Now, I'm not going to be going into the depth of telling you, why they'd be doing this or how it is done in a detailed way, but a very simple example to show you how you can go about calculating the Fourier transformation is very simple. Now, let me quickly take you back to your school days or your college days where you might have read about these trigonomic functions, right? You have sine, cos, tan and all of that, right? So here what we'll be doing is we'll take a periodic function of sine. You know what a sine wave looks like, right? It's the AC power that you're getting at your home. It's a sine wave at the end of the day. So we're going to be using a simple periodic function and we'll see how we can use Fourier transform to transform that sine wave that we're going to be seeing into something else. Now, do not worry if you do not pick up on the nitty-gritty details out here. This is a very niche application of it, but at the end of the day, this is very important to know for you guys as learners, right? Now, let me quickly open up FFTPack here, and in FFTPack, we have one or two demos, right? Let me quickly zoom out a little so we can see the entire demo at one point of time. As you can see, starting, it's all just us importing libraries. And then, as I told you, right, we're going to be converting spatial data into frequency data. So we're going to have some frequency. And what is the unit for frequency? Hertz, right? The power in your house, the sine wave power that you get in your house is either 50 Hertz or 60 Hertz, depending on where you live. Right? And then the sampling rate. Sampling is again a fantastic part of, working with these analog and digital electronics if you have studied about it in college. And all we're trying to do is we're trying to take spatial data, convert it into simple frequency data, right? And look at this. This is what it might look like. Now, if you do not know what amplitude and all of that means, do not worry. Just look at the graph and understand that this is sort of something similar to what it would look like if you could see the power coming in through the wires to your house, right? It's a simple sine wave that all you're trying to do is we've just plotted the amplitude, we've just plotted the time out there, and it's simple, right? Now, the important part here is this is great. We have the sine wave, everything is good. Now, what we need to do, you have to understand is that we have to take this data. This is spatial data. We're talking about how the wave varies with respect to time and with respect to how much it moves and the power it gets. That's amplitude, right? So what we do here is we basically say, okay, so this is what you have as an input, a processed input. Now, what's going to happen if you do have to convert it into frequency data, right? Look at this. As soon as you say, hey, here is the magnitude in terms of all the spectrum that this is generating, and here is the frequency in Hertz. Again, we just took this, we used FFTPack, and all you have to do is Fourier transform, just converted spatial data to frequency data, and it did it in what? The logic is basically 2 lines out here, and the logic here is basically, again, another 1 or 2 lines, right? See, 4 lines at the end of the day. Now, you might say, hey, it's not 4 lines, we have 20 lines totally. But all the 20 lines out there, these are like boilerplate code, which again, once you start learning it and once you start doing it, your brain will not have to put any effort to understanding how that's gone about doing, right? So it's very simple. You take spatial data, you convert it into frequency. And if you're wondering about, why would someone do this? How is this done? What application in physics? You'll have to do a bit of reading on that yourself, right? Now, I'm a data science guy and I'm definitely not a physics guy, but I love astrophysics if you want to know. Alright, cool. Now that we're done with FFTPack, let's quickly take a look at the next thing wherein we are going to be discussing a little bit about interpolation. Now, interpolation is one of these concepts which is again super popular because when you have 2 values, right? Whenever you have 2 known values, let's just say 0 and let's just say 10. When you have 2 values, there are a lot of other values, right? There's infinite values between 0 and 10. But what if you had to estimate unknown values that are present in this range itself? That is where interpolation comes into the picture. And again, as always, since we're discussing it in SciPy, there is a sub-package that will help you do this easily. So you can perform one-dimensional or any sort of univariate interpolation. Univariate basically talks about one variable, right? So one variable interpolation is possible, and even multivariate interpolation is possible, as in you can use 2 or more variables to perform interpolation. Now, when you say multivariate interpolation, it basically is also called a spatial interpolation. It is one of a kind where, you can run functions, and in these functions, you will have multiple unknowns, multiple known variables through which you can process all of them easily, right? So let's quickly head over to Python again, and let's take a look at how we can go about understanding interpolation in a very simple manner. Now, what we're doing here, as you can already see, is let me actually print it out so you have a better idea about what we're doing. We are creating a couple of plots here, and all of these are like functions, right? You can see that we've used the cosine function here. We've run this entire thing becomes a function when you take a look at it, right? A mathematical function to be very precise. And as you can see, we have certain data that we have just plotted it out, right? Now, if these two lines weren't there, the data would still have been there, but it would have not been plotted. The convenience of data visualization is all you have to do is like plot it out, and here's a scatter plot that will give you all the details that you're going to need. Now, one thing that you have to do is wherever we have a situation where we have to create a function based on certain fixed data points. Think about the example that I just told you, 0 to 10, right? Here's where interpolation comes into the picture. Now, if you want to understand what is the difference, what happens after interpolation, again, there's multiple types of interpolation, linear, cubic, and all of that. So all I'm going to do is I'm going to run this tiny piece of code here, and you can see this, right? Your actual data, look at this. This is the data that we have in hand when we ran this cosine function, and all those blue dots that you see is exactly that graph. But over that graph, when you perform interpolation, we have linear interpolation on the solid yellow line, and of course on the dotted green line, we have cubic interpolation, right? Now, the way of us finding out how we can go about printing and knowing all these values. Now, you might be saying, okay, so why did we do this? Why do we have a graph there? Guess what? Between this blue point and this blue point, right? Two data entities. If you want something in the middle, if you want something in between these 2 points, guess what? You can have it now. But right now here, if you just look at the graph, you can still sort of get it. But unless you draw the shortest path, unless you start drawing straight lines from each of these entities, you will not get to know that, right? If I just gave you this and say, hey, now my mouse is pointed here, where is this? You can only guess, but you can't be specific. But if I say, hey, where is this point? Right now where my mouse is, you can quickly map the x-axis, map the y-axis, give me a very accurate number of how you can do this. Again, all of this is done with the 2 lines of logic out here and a couple of lines, right? Again, 2, 3, 4 lines. So all in all, 10, 15 lines, you're done with understanding a simple interpolation. So we have created 2 functions here, function 1, function 2, and all the sample points and variables that are associated with it, you can see here, right? You can see X, Y, and the way of how you're supposed to go about interpolation, doing interpolation. There's multiple ways. Linear and cubic are the popular ones that you can go about seeing. So we took something that looks as plain, as boring, as uninformative as this, to having understanding every single point that lies in between these 2 entities that we have in discussion, right? So at the moment, you understanding that you can go about doing this in a very easy way is the goal here. And I'm sure you can know the fact that if this simple small example can give you this much insight, think about actually using this in a scientific computing environment, right? There, you're going to have a lot more fun working with that. Right? Super. Now, as I told you, interpolation is basically a process of estimating unknowns that fall between 2 values. As we already saw, we have a library to go about doing it. We took a look at that practically as well. Right now, we discussed all of these multivariate interpolation, spatial interpolation, and all of that. So I'm going to run through the next type of sub-package that we have to discuss, which is Linalg. Linalg, as you already know, stands for linear algebra. And whenever you have a requirement that says, hey, I want fast linear algebra capabilities, guess the sub package that you're going to be using, right? Now, this sub package is actually built using something called Atlas. Atlas is absolutely fantastic. It stands for Automated Tuned Linear Algebra Software, and LAPACK. LAPACK basically stands for Linear Algebra Package, and BLAS, or BLAS as it's called, it stands for Basic Linear Algebra Subprograms. Now, these libraries, this is one library that is built using all 3 of these other optimized libraries out there. And if you can already think, just look at the naming. It seems like this is extremely complex, right? It is. And when you bring 3 extremely complex libraries and give the power to it to one single library, you must expect that, hey, this becomes way more complex than we started out initially. That's not the case. It actually becomes very, very simple of how you can work with all these algebraic routines. You can operate on multiple objects, convert it into two-dimensional arrays. If you want an output to be a two-dimensional array, guess what? That is also possible here as well, right? Now, if you are wondering at this moment of time saying, hey, so, this sub package that we have, it also provides us with functions to solve algebraic equations. So should you use, if you use NumPy, here will be your confusion. Should you use NumPy.linear algebra or should you use SciPy.linear algebra? Well, SciPy.linear algebra contains everything that NumPy.linear algebra brings. And apart from that, what did I tell you previously? That SciPy is built on top of NumPy. So with all the functionality of NumPy and then some is what you will get when you use SciPy.Linalg, right? So if there is ever a confusion in your head at any point of time in your learning which says, I don't know which to use, now you know which to use, right? And it's not just that. There's another advantage here. The other advantage of using SciPy.Linalg over NumPy.Linalg is the fact that it will always be compiled ready with BLAS or LPACK support. While for NumPy, it still is supported, but it is optional. It doesn't come as a standard entity that you can go about using. So the speed at which your equations will get solved is way faster with SciPy.Linalg rather than NumPy.Linalg, right? I know it sounds a little bit complex, but trust me, this simple slide will give you all the information you need to know about quick comparison, what can do what better, which should be used when, what is the advantage of SciPy.Linalg over NumPy.Linalg, right? Again, as always, let me quickly show you one or two demos on this and, we can go about doing it. Now, I'm going to take you back to your college days. I'm going to take you back to your school days because look at this. This is a linear algebraic solution, right? Now, when you take a look at the various equations that we have here, all we are trying to do is we're trying to solve these three equations and we're trying to find the value of x, y, and z for whenever these equations become zero, and you can eventually find out, right? So all we have to do is we have to move a couple of things around. We have to multiply certain equations with certain entities, and then you can get to solve. You start eliminating your variables. You solve for one. Once you start finding x, you can find out y. Once you start finding out y, you have the value of x and y, use it to find z. That is how we solve it. Now, I definitely can do this manually because I remember how we can go about doing it. But to get our linear algebra system to work with, we're going to be using all the inputs as arrays. Now, as you can see, right, it's 1x, 2y, minus 3z. Look at this, 1x, 2y minus 3z. The second equation is 2x minus 5y plus 4z. And then you have 5x, 4y minus z. Minus z is nothing but minus 1, right? So this is the input array that we have, and here is the solution array that we require. And guess what? You have you have the input, you have the solution. All you have to do is solve it, right? Get from that to this. Look at the line which talks about the logic of how you can go about doing it. One line of code, and as soon as I hit play, it's very easy, right? Look at this. One thing you have to understand is x is 2, y is minus 1, z is 1, right? It's 2 minus 1, 1. If you substitute 2 minus 1 and 1, your answer should be 0 in all three of these equations. This is what we're being told here. This is the value of x, y, z. And once you attach the value of x, y, z, or everything must be 0. If you get these values and these are not zeros, it means that your equation is not completely balanced out there and there's something that went wrong, right? Again, look at how, I know you would have thought this would have been very complex as we started out, but this was the equation. All we had to do is we had to move the equation, and we already know the solutions from the right side, minus 3, 13, and 5. All we had to do is create two arrays, run one command, print the result, done. Very simple, right? So this, again, at the end of the day is very, very simple of how you can go about working with linear algebra. Let me give you one more example. If you guys have worked on matrices, matrix as it's called, there are a lot of types of matrix, diagonal matrix, square matrix, finding the determinant of a matrix. It's a very important concept in applied mathematics, right? So all we're trying to do here again is we're trying to create this matrix that we're talking about. To find the determinant of that matrix is again one simple function dot det of a, where a is the values that you're going to be providing. Input, perform the operation, output, 3 lines of code, and you're done finding the determinant of a square matrix. Now, to do this manually will take a lot of time because you have to go about processing it and work with it. I'm very sure if you have taken up probably engineering for your bachelor's, you might have worked on these in your first 1 or 2 years of engineering, right? Understanding what a matrix is, operations, determinant, all of that. Now you can take a look at, this is the matrix that we have in hand, the matrix, the square matrix that we are discussing. It's a 3x3 matrix, and this is the determinant that goes with that matrix, right? It's very simple. At the end of the day, it just takes a very complex solution, simplifies it by a lot, as I told you at the start of the video, and I'm sure you are convinced of that by now. Right? So let's quickly take a look at another last sub-package that we have in hand, which is Ndimage. Ndimage stands for N-dimensional images. It's an image processing library which you can use to perform multiple processing tasks, and you can perform various analysis out there as well, right? So the first question you must be asking right now is, hey, we have OpenCV to do this task very easily. Why do we require this? There might be cases where, there are cases where SciPy might trump OpenCV out there. OpenCV is meant for computer vision, meant for images, meant for videos, but SciPy is not lagging in any regard, right? Take a look at the basic manipulations that you can go about doing. You can crop an image, you can flip an image, you can rotate an image, you can do all of these simple tasks by making use of SciPy itself. And if you ever have to perform image segmentations, right? If you have to understand what's going on in your image, what the pixels in a flower looks like, what the pixels in a car looks like in an image, you can go about doing all of that. You can perform classification tasks using your images. If you want to build a dog and a cat classifier, as in you'll provide input images of dogs, input images of cats, you will get your machine learning algorithm to understand what a cat looks like, understand what a dog looks like. So when you surprise it with another image, a random image of either a cat or a dog, it will have the capability to tell you if it's a cat or a dog. How cool is that, right? It's a simple binary classifier, which again, I love working with. And of course, you can do all of that. You can do feature extraction as well. If there is a case where you know this is what the solution is, this is my application, and if you're wondering what variables in your data will let you go towards the solution, the process of feature selections, feature extraction is very, very important, right? There is a very wide term which governs all of these feature concepts. It's called feature engineering, which you might have heard about if you've studied a bit of machine learning, right? Fantastic. Let's quickly go about taking a look at this demonstration. This one's going to be nice. We have a couple of images that you guys can take a look at. Now, all I'm trying to do is we're trying to print scipy.miss.face is going to print an image of a raccoon, and this is what a raccoon looks like, right? Looks pretty cute in my opinion. And all I tried to do was we took the image of a raccoon, and all we did is we printed the image using Matplotlib. You can see that plot.imshow stands for image show here, and this is the overall plot that we got. Fantastic. Now we have an image to work with. What are the 1 or 2 tasks that I can show you about how you can do? The first thing that we can go about doing is cropping the image. Cropping, this is the heart of the logic, right? One line of code, you can crop the image. Look at this. Now you have an entire raccoon out here with like a lot of grass on the top right, a lot of, I think palm trees on the bottom left or whatever it is. And now you can crop it. Now, if you're wondering about how you know where to crop and what to do what, you have something here called face.shape, wherein we have X channels, Y channels and all of that. And through which when you run integer of, LX by 4. So we're basically trying to say, pick up everything around the face and just crop it to us and just go about printing it. Right now, what I want you guys to do is, as soon as you see this code and you're trying to type it out, just change these values to see what output you get, right? Of course, changing these will change what and where the cropping happens. And I want you guys to figure this out. Now, don't Google this. This is very simple. You have to change 1 or 2 numbers. I've already told you what to do. Just give it a shot, right? So this is us taking an input image to us cropping an image. The next thing you can do is you can take an image and rotate it at any angle that you want. Now here all I've told is ndimage.rotate face by 180 degrees. Now all I can do is as soon as I hit play, you will see that the entire image will be flipped by 180 degrees. Now this is not the cropped image, right? Because we're still using the original image that we have in discussion. This is the input image. This is the output image. You can see that it just went all the way over to that particular angle, right? So as you can see, working with even basic image operations, working with linear equations, working with interpolation, working with constants and clusters are very, very easy with respect to SciPy. Right, guys?
In this particular part, we are going to talk about anomaly or outlier detection. What is anomaly? What is actually mean by outlier detection. We will talk about everything. So let's see and let's go to objectives and let's see what are the things we are going to talk about in this particular part. So first we will start with what is statistics. Right, so this anomaly detection or outlier detection is nothing but the basic part of statistics you need to know. Then we will talk about what is population. Then from there we will have a look at what is parameter and sample. These are nothing but basics of statistics. Then I know you all have idea about what is mean, median and mode. Again, for your recap, we will talk about that. Then we will see what is normal distribution. Then types of analysis and statistics we have. Then we will start with what is an outlier, what is interquartile range, in short, which is known as IQR. Then we will see what are the interquartile range, like upper range or lower limits. What it is, we will talk about in depth for interquartile range. Then we will do a demo how to handle outlier in the data set. Right? So let's start with our what is statistics. So first question is what is statistics? So what do you think? What is statistics? Right? Let me know in the comment box before we talk about what is statistics. And if you like the video, do not forget to like it. Do not forget to subscribe. Great learning. So statistics is a part of integrated applied mathematics which deals with data. Right? It helps to collect data and analyze them properly. Okay, so if we know maths, it's a integrated applied mathematics, right? So basically, it's help us to understand our data in a more better way. It gives us the idea that, okay, maybe your data is coming from this. It's like, these are the insights you can actually have a look at. That's why we go for statistics. Right, in a very basic part, as a data scientist, you need to have an idea about what is stats, right? How can you understand your data using statistics concepts? So it helps to collect data and analyze them properly. From there, with the help of statistics, we can read the data and organize them in order to get the hidden information from them. The main reason behind it to use statistics, it gives us really some, we cannot even think of by looking at the data, but actually the data has those insights or the information. So they are nothing but our hidden information. So this is what statistics stands for, and that's why we try to use all the concepts from stats. In data science domain, statistics concepts are used to process the complex data to get the insights from them using mathematical computations, right? So it's basically, again, it helps you to process your, it's a complex data and it give you a really good insights from them just by using stats. So let's start with what are the terms we have in statistics. So this is the slides we talk about. You can see stats, what is stats, why do we need it, and why we say while it comes to data science or artificial intelligence, you need to know the basics of stats, right? I think you got all the idea about why do we need stats. So please let me know in the comment section if you feel like you are not yet convinced that why do we need stats, right? Then we will talk about what is population. The terms population in statistics is used to refer the total set of observation. Okay, let me tell you what actually I mean by total set of observation. So total set of observation is nothing but when you have a data set, right? Or you can think about the example of the whole population of the world. Yes, that's what population stands for. The whole population, the whole total number of human beings we have in the world, right? So suppose again, we want to study a diabetes data set to understand the symptoms and the other factors in the whole data set is referred to as population, right? Now, if I just go and talk about what is parameter? So parameters are referred to as characteristics which describe the population, right? It's help us to describe our data set, right? So this is what stands for parameter. Parameters are like average or percentage which help you to describe the entire population. Suppose you have a diabetes data set and you want to understand what is the average age of being diabetic. I know, how can you do the average? So this average is going to represent your whole data set, right? So you can understand what is parameter. Mean and standard deviation are two common parameters of population, right? Now, example, I have given you already average age for being diabetic is the parameter for whole diabetic dataset population. Now we will jump into what is sample. So if you have a lot, like, we have the whole population in the world. Now, if you just want to talk about West Bengal, or if you just want to talk about India, right? Then the India will be your sample from the whole population, from whole world population. This is what sample stands for. Sample is basically a small part or the portion of the large population. Now, suppose from the whole diabetes dataset, you picked 100 rows of information to do the analysis. That 100 rows of information will be referred as sample, right? Now let's move further. We will talk about what is mean. The term mean is referred to as an average value of the whole population that we already know. Now if we talk about median, so median is the middle value of the data when your data is sorted in the manner. Yes, to get the median value, you have to make sure that your data is sorted. Now we will talk about mode. Mode stands for the most occurring element in the data set. So mean, median, mode is the very basic things, right? We start learning those things when we are kid. So still, if you have any doubt regarding what we have talked about, why do we need statistics, what is population, what is sample, then we talked about what is mean, median and mode. Now we will talk about what is normal distribution. The normal distribution is a probability function which describes you how the values of the variable are distributed. Now we will say, why do we need it? This basically gives you an idea about your data points. Who are your data points? Suppose you are talking about diabetes dataset. All the rows you have about the description or the information about the person, these are your data points. Now, this normal distribution is basically comes from probability function, and it helps us to describe how our values of a variable are distributed properly to give us the idea what is the range of our data set, right? This is what normal distribution stands for. Now, properties of normal distribution, the mean, median and mode all are equal, right? The curve is symmetric at the center. Then this is also referred as Gaussian or Gauss distribution, right? The parameters of normal distribution, mean, standard deviation, like we have the parameters of normal distribution, that is mean and standard deviation, right? Now, we will talk about the types of analysis in statistics. Basically, we have two types of analysis. One is descriptive statistics and second one is inferential statistics. What is descriptive statistics? It helps to describe the data in the mathematical or a graphical way. Now, when it comes to inferential statistics splits the data into samples and applies probability to arrive the conclusion, right? This is what descriptive statistics and inferential statistics stands for, right? I hope you understand what is actually mean by descriptive statistics and inferential statistics. So as a name suggests, again as a recap, describe the data, you need to have descriptive statistics. Now, if you want to use, split to your data to samples, I hope you understand what is sample and how can you apply probability to arrive the conclusion. We use inferential statistics, right? Now let's move further. We will talk about what is an outlier. Outlier in the data set are referred to as the usual values which can distort and violate statistical analysis. Now you will ask me, what is outlier? Maybe in the class there will be always an outlier. What is an outlier? Suppose we have students who are mediocre, or we have student who is really good, like the first boy or the first girl, right? So they are nothing but the outlier, right? So this is what outlier stands for. Now, outlier are basically experimental errors in the data set, or like in the case of data, it's an experimental error, but in the case of what example I get, it's not an error, right? Now, some outliers are good for dataset to detect anomaly, like detecting fraud transaction. Now, you will ask me, how can we detect a fraud transaction? Let me tell you. So, basically, detecting fraud transaction is like, suppose you have a dataset where everyone has does the credit card fraud analysis, or everyone has the idea, like description or the information about their credit card. Suddenly you see there is a sudden spike in the transaction when a person is used to buy something between 10,000 to 20,000. He's going to buy something in 10 lakhs. It's nothing but the outlier, and there is a possibility it's a fraud transaction. I cannot say it's not a fraud transaction. So it can be a genuine transaction, but yes, but there is a possibility. As the outlier is there, we would need to give a good look on that, what is happening. So this is how we actually use our outliers. Now it affects the mean and the standard deviation of the data, that's obvious, and the data and the most of the machine learning techniques does not perform good with outliers. If you see outliers is not needed, you can just cut it off, because it's gonna affect your model, and it's gonna affect your data, mean, standard deviation, everything, right? Now we will talk about what is interquartile range. Interquartile range divide the dataset into quartiles to measure the variability and the spread of the dataset, right? So what is that? It's basically help you to divide your dataset with 4 quartiles to measure that how your data is spread, what is the variability, what is your data points, so give you the every possible way information about your data. Splits the data set into 4 equal parts, but in sorted manner, right? So Q1, Q2, Q3, Q4, right? We will have 4 parts. So Q1, Q2, Q3 are called first, second, and third quartile. Now, what is Q1? Q1 is the 25th percentile of the data set. What is Q2? 50th percentile of the data set, and Q3 is 75th percentile of the data set. This is what IQR stands for. Now, what is the formula for IQR? That's nothing but third quartile minus first quartile. Now, we will talk about what are upper and lower limits in interquartile range. Yes, you have to have an upper limit and lower limit. Now, let's have a look at what is upper limit and lower limit. Now, we've had upper limit and lower limits in the interquartile are basically the ranges where your data points are lying. Suppose it starts from 0 to 15. So upper limit is 15 and lower limit is 10. Sorry, lower limit is 0, right? So formula to find the lower limit is basically Q1 minus 1.5 into IQR. Now, formula to find the upper limit will be Q3 plus 1.5 into IQR, right? Now we will see how can we handle outlier in the data set, and what are the concepts we have learned about what is statistics, what is sample, what is population, what is mean median mode, what is IQR. We will do everything, right? And how can you find outlier as well, right? So let's start with the dataset demo, and do let me know if you have any doubt in the comment section. In this case, we are going to use a dataset from Kaggle, which is known as PIMA Indian Diabetes Dataset, right? So this is your dataset link. If you just click over here, you will redirect to the dataset, right? Let me do that. Okay, so again, it's a free dataset from Kaggle where you have the information about diabetes patient. Can you see? This is how you will redirect, and you will directly download the dataset from here. It's from Kaggle, right? Can you see? This is what the dataset is. Right. Now we will talk about what is this dataset all about, what are the things we have. The PIMA Indian Diabetes Database is the is from National Institute of Diabetes and Digestive and Kidney Disease. It consists of 9 variables. We will talk about that. Out of which outcome is the target variable. The objective of this data set is to aid in pending if a person is likely to have diabetes or not. What are the different types of diabetes we have? The most common type of diabetes are type 1, type 2 and gestational diabetes, right? Now, what is type 1 diabetes? Type 1 diabetes, if you have type 1 diabetes, your body does not make insulin. So we all know about diabetes that it does not stop making insulin. Your immune system attacks and destroys the cell in your pancreas that make insulin. Now, type 1 diabetes is usually diagnosed in children and young adults, although it can appear at any age. People with type 1 diabetes need to take insulin every day to stay alive. Right? Now it comes to type 2 diabetes. If you have a type 2 diabetes, your body does not make or use insulin well. You can develop type 2 diabetes at any age, even during childhood. However, this type of diabetes occurs most often in middle age or older people. Type 2 is the most common type of diabetes. Now, if we talk about gestational diabetes develops in some women when they are pregnant. Most of the time, this type of diabetes goes away after baby is born. However, you have gestational diabetes, you have a greater chance of developing type 2 diabetes later in life. Sometimes, diabetes diagnosed during pregnancy is actually type 2 diabetes. Other types of diabetes less commonly include like monogenic diabetes, or which is an inherited from diabetes, and slightly fibrosis related diabetes. So these are the type of diabetes. Maybe you think why I'm talking about diabetes, just to give you a heads up if you do not know what is diabetes, right? So we have talked about different type of diabetes. Now we will see what is the data description we have in our data set. What are the 9 variables we have? We have pregnancy, the number of time the patient got pregnant. Then we have glucose, that plasma glucose concentration. Then we have the column called blood pressure. It's like, we all know that is BP, right? Then we have skin thickness, that tricep skin folds thickness, right? Then we have insulin, the 2-hour serum insulin. Now we have BMI, that is body in mass index, weight in per kg. A weight in kg per height in like to the power 2. This is how we calculate BMI. Now we talk about diabetes predictive function, which is nothing but again diabetes predictive function. Then we have age and outcome, that will be your class variable, 0 or 1, right? So these are the total column we have. Now you will say, what is this outcome stands for? This outcome is basically if your outcome is 0, this person is diabetic, not diabetic. If the person is diabetic, then the class variable will be 1, right? So this is what the, different type of columns we have. Now, if we go further and if we have a look at what are the, library we need to import, then we have talked about Pandas, NumPy, Matplotlib and SeaBorn. We are going to import this 4 library, right? We have written import Pandas as PD, import NumPy as NP, and if you know why we use as, please do let me know in the comment section. I would love to hear from you, as we have talked about this particular as so many times. So what actually I mean by import Pandas and then as PD, right? Please do let me know. Now, after you write this comment, then again start the video and let's see what you have written. It's right or wrong. And guys, if you like the video, do not forget to like it. Do not forget to subscribe. Great learning. So you will get updated with the all new content we are going to come up with, right? And please do let me know in the comment section, do you like the video? If you like the video, what are the things you want to learn from us as well, right? So now we will do what? We will load the data set. How we do the loading the data set? We can write data equals to pd.read_csv. What is CSV file? comma separated value, right? Yes, this is what CSV stands for. And then we have written diabetes.csv, right? So you have your data, and if you just want to read them using pandas, you just need to use dot read underscore CSV. So my data is a comma separated value, right? So CSV stands for comma separated value. Now, if you ask me how can I upload data in Google Colab, I have talked about so many times, but for your reference again, just click on this particular box. Here you will get an option for upload to session storage. It will redirect to your local system and you just need to upload the dataset from there. So this is how I have done. Now here pd.read.csv, you have to give the path. How can I get the path of the dataset? Now, if I just click over here, you get an option for copy path. Let me just copy the path. Now, just copy paste it here, right? This is how this copy path option works. And this is how you can read the dataset using pd.read.csv and you can upload dataset in Google Colab. Right? I hope you do not have any doubt till so far what we have talked about. Give me a quick confirmation on that as well. Right? Now we will see the basic part of pandas, and then we will jump into all the all the techniques we have learned, and we will see how can we implement them using Python. Now we have written data.head. Why do we write data.head? I have talked about this again for so many time while we were talking about PD, like pandas, right? Okay, I have asked you guys question that why do we use as PD? As PD is nothing but giving the alias to your library, right? So if I don't want to use like pandas for all the time, I can easily call them as PD, right? It's a nickname to your library, you can see in a layman term. Now, if we just write data.head, it will return you the first 5 rows of your data. Let me just execute that. Right. So in default, it will return you the first 5 rows, right? Now, if you say, no, I want to see the first 10 rows, how can you do that? Just need to do data.head, then you can specify the number, the first 10 rows or the first 15 rows you want to see. You will get total that many of 0 to 14, that many of data set, that many of rows, right? So this is why we use .head. Now comes data.tail. Why do we need to use data.tail? Data.tail will give you the last 5 rows of your data set. I hope you get the difference between head and tail, right? So then, as the name suggests, basically tail will give you the first 5 rows of your data. Now let me just execute that. Yes, this is what you get. The last you have 768 total columns you have, total rows you have. Now I want to see all the 9 columns we have talked about, only the columns. How to do that? You have to write you have to write data.columns. So the columns will return you all the column you have in your data set. You have column called pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetic predictive function, age, outcome. Right? So this is what you get after you write data.columns. Now, I just want to talk about what is my data shape. So total columns, I said 9. How many rows we have? In order to get that, you have to write data.shape. So after you write data.shape, you will get the total shape of your data. That is 768, 9. So total rows you have 768 and columns you have 9. Alright, so we have already talked about this data.head. Now we will see how can we treat the missing value detection and treatment. In this part, we are going to do the missing value detection and treatment. So how can we do that? So in this case, how can we understand we do have missing value? The following value in the data sets are considered to be missing values. Suppose you have blank values or you have null or null, or some continuous columns might have zeros to indicate missing data. This is where we can understand this particular that is having a missing value. Now, how can you get that? Let's start by checking the count of the records in each column of the data set. So if the count of the record is lesser than the total number of records, then suppose 768, we can conclude that there are blank records, right? I have written data.info, right? Can you see what I get? The count of the records for all the columns is 768. This indicates there are no blank columns in the data set. Yes, you do not have any blank column. Now, if I just want to understand, do we have any null value? How to understand? We can use a function called isAnyFunction. This isAny function is used to understand, do you have any null value in your data set, right? Let me just execute that. What it's going to return? It's going to return that true or false, right? If you don't have any null values, then it will give you like false. But if you do have, it will give you true, right? Suppose you have written data.isAny.any. For each and every column, it's going to give you, do you have any null value for this particular column? So in the case of pregnancy, you said no. It said basically no. For glucose, it said no. Blood pressure, skin thickness. For any of the column, we do not have any null value. Now, if you just want to get the summation of the null value, right? So there is an option. We have data.isAny.sum. So it will give you total number of value, like total number of null value you have in every column. So you can see for all the column you have 0, 0, 0. That means you do not have any null value. Since all the predictor columns are continuous in nature, there might be a chance that zeros in these columns indicates missing values. Let's say, do you have any 0? So if I just write data.describe, what is describe function? A describe function from the, it's going to give you what is total count of the data, what is the mean of your data set, what is standard deviation, then what is minimum value, then your interquartile range and the maximum value. Now, if you look closely, you can see the minimum value for pregnancy is 0. That can happen. The glucose is 0. Will that possible that a person has a 0 glucose? No. A person can have 0 blood pressure. No, it's not gonna happen. Skin thickness 0, insulin 0, BMI 0. It's not possible even. So you actually have null values, or that is nothing but representing as 0. Let's see what I have written here. From the above description of the data, we can see that columns pregnancy, glucose, blood pressure, skin thickness, insulin and BMI have minimum value of 0. It makes sense to have 0 pregnancy, but it does not make sense for other mentioned variable to minimum value of 0. So we can conclude that glucose, blood pressure, skin thickness, insulin and BMI have missing data. That zeros in the columns should have replaced with the median. We always replace with median since the median is least affected by outliers, as we have already talked about outlier. If you know what is outlier, please do let me know in the in the comment section what is outlier. And if you like the video, do not forget to like it and do not forget to subscribe. Great learning. Now, if I just do data of glucose, so basically I just want the column for glucose. I have written that data of glucose, you will get all the data from the Google, from the glucose column, right? Let me just execute that. Okay. Now, if I just write replacing the zeros with nan, we need to import one particular part from NumPy, that is known as import num. The records that have zeros in the column glucose, blood pressure, and skin thickness and insulin and BMI will be replaced with nan. To understand how many nan values we have, which are hiding behind 0, right? That's why I have written data of glucose equals to data of glucose dot replace 0, np dot nan. So if you want to replace any value in the data set, you have to use replace function. Now I have 0. I want to replace 0 with nan, right? So this is why we use np.nan. Now, if I write data of blood pressure the same way, I have written replace 0 with np.nan for skin thickness, for insulin, for BMI. Right? You can see this is how we can do this, is replacing 0 with np.nan. Now, if I write data.head, so this data.head will give you like suppose you have 0, you can see in insulin, normally you can see for the first 3 record has nan value. For skin thickness has nan value. So basically these were replaced, like the zeros were replaced with nan. Now if I just write data.describe, you can see there is minimum value for glucose is 44, for blood pressure is 24. So we do not have any 0 values because as they are already replaced with nan. So this is how you can find it out your missing value. But finding out missing value is really problematic, and also you need to keep your mind working. As I said, working with data is easy, but understanding data is not easy. You have to first understand data. You have to make sure what are the information you are getting from data, it's worthy of getting, right? So these are the things you have to keep in mind while you are talking about the exploratory data analysis, which is nothing but again, our module name is anomaly detection or outlier detection, right? So I have written data.isNull.sum. So you can see total number of null value we have, we will get the summation of that. So for the case of Google, we have 5 null value. Sorry, for the case of glucose, we have 5 null value. And the case of blood pressure, we have 35 null values. In the case of skin thickness, oh my god, for 227, and for insulin, we have 374. You can see how many mean value, like, how many missing value we had, and which was just hiding behind zeros. For BMI, we have 11. Right? As in for 2 column, glucose, blood pressure, skin thickness, insulin, and BMI have missing data. Glucose, blood pressure, and BMI have less number of missing data, while the case of skin thickness and insulin have the high or very high amount of missing data. Now, removing this missing data from the data set will result in information loss, and it is not advisable to remove these records since we have only 768 records. Hence, we will input this missing value with median of their respective columns, since median is the least affected by outliers. We will replace all the nan value with median, right? This is how we are going to handle missing values, right? Please do let me know if you have any doubt about missing value, about outliers, about whatever we are talking about. Right? So I will happily help you and help you to solve your doubts as well. Now, if you just write data.median, this median value or we know how median works, right? So just by calling the function median, it will give you the median for each and every column you have. So for pregnancy, median is 3, glucose is 117, for blood pressure is 72. For skin thickness, we have 29. For insulin, you have 125. For BMI, you have 32. And for diabetes predictive function, you have 0. And for age, you have 29. Right? So this is how your median function is going to work in your whole data set. Now, what we need to do? We need to import, or we need to not import, we need to fill our nan values with data.median. How can you do that? Inputting missing values with their respective columns, median, and to fill nan value, we need to use a function called .fillNA. So we have written data.fillNA. What you need to fill? Data.median. So your value will be data.median and in place equals to true. All right. Let me just print data.head. So can you see your skin thickness is replaced. Your insulin that we got, that nan value, this 125.0, 125.0, this first 3 columns are replaced with median. So you will not have any data loss. It is actually recommended not to delete the data or not to cut the data. If you have a huge data set, maybe you can go for, while you have just 768 data set, this is not recommended to remove the data with nan value. With like, except like this, you can replace nan values with median, right? Now we are going to check if the missing value have been imputed or not. How to do that? We just need to again use data.isNull.sum. Why to use .isNull? We use .isNull and sum to check how many null value we have in our data set. Can you see? Now we just have 0 null values. Right? In the next part, we are going to talk about how can we handle outlier detection and how can we treat them. Right? I hope you have all understood about missing value. If you do not know in the normal way that you have missing value, then now you have to go deep and you have to investigate little more to understand, do you really have missing value or you don't? If you have missing value, then go and remove them if you have a big data set. If you do not have big data set, then replace them with median. And after that, you are ready to use your data set, right? So this is what missing value, treatment works for and how can you find it out. Then in the next part, we will talk about how we will find it out, outlier detection, and how can we treat them. Now, in this part, we are going to talk about outlier detection. I know you all have idea about outlier detection, right? Give me a quick confirmation in the comment box. What is outlier? What example I have given about outlier? Please do let me know in the comment section. And if you like the video, do not forget to like this video and do not forget to subscribe. Great learning. Now we will talk about outlier. Outliers are extreme values that deviate from the other observation on data. They may indicate a variability in the measurement or experimental error or novelty. Box plots are a great way of detecting outliers. We already talked about box plot, right? So yes, it will help you to find it out, the outliers. Once the outlier have been detected, they can be imputed with the 5th or 95th percentile. We will talk about that, how to do that. So how can I do that using boxplot? You have to write plt.figure to make your figure size. Now you will go for plt.subplot. In one plot, there will be subplot you want, right? So you have written 441. Now we are going to use SeaBorn and I have given SeaBorn as SNS. So SNS dot boxplot and data of pregnancy. So for the pregnancy column, you just want to plot the box plot. Now in the case of glucose, you will again write plt.subplot 442. Can you see the number changing that where you want to place this particular box plot? Now I have written is dot box plot, then data of glucose. Then move further, we have plt dot subplot 443 and SNS dot box plot, data of blood pressure, right? So for again we will going to write plt dot subplot 444, your data place where you want to put your box plot, and I have written data of skin thickness. The same way we have done for data insulin, we have done for BMI, diabetes pulmonary function, and age, right? So it's going to give us the box plot. Now, if you don't know box plot, then I should suggest please check the previous part of the video where we have talked about box plot. Now, in the case of pregnancy, can you see there is a 3 dots? So basically, it's showing there is outlier. In the case of glucose, you do not have any outlier. In the case of blood pressure, you again have outlier. In the case of skin thickness, obviously you have outlier. Age has outlier. Diabetes pedigree function has outlier. Insulin has lots of outlier, and BMI also have the outlier. Now, if I go for the observation apart from glucose, all the other attributes shows the presence of outliers. This lower level and upper level outliers will be replaced by the 5th and 95th percentiles respectively, right? Now we have talked about IQR. What is interquartile range, guys? Let me know in the comment section. Again, for your WhatsApp, for your heads up that the interquartile range, that IQR, is a measure of variability. Based on dividing a dataset into quartiles, quartiles divides a rank order dataset into 4 equal parts that we have talked about, which the parts are known as quartiles. So the value that divide each part are called as first, second, third quartile, and they are denoted by Q1, Q2, Q3 respectively. Now what we are going to do, we are going to, that we have talked about interquartile range. Now what we are going to do, we are going to write numpy dot clip function. So the numpy dot clip function will help you to clip our data as we have outlier, right? So what is how to use clip function? So if this clip function, you need to give the limit, the values in an array. Syntax numpy dot clip, and the parameters you have, the array containing elements to clip, you want to clip, then minimum value. If none clipping is not performed on lower interval age, not more than 1 of a underscore mean, and a underscore max may be none, and a max is nothing but your maximum value, right? Now if I just need to clip, what I need to write, I have written data of pregnancy. You want to work on the pregnancy column, then I have written data of pregnancies dot clip. I want to clip my data. Now what I need to do, for the lower limit, I am going to give data of pregnancy dot quartile 0.05. Then we have written that upper will be data of pregnancy quartile 0.95, as we have talked about here, right? That the values divide each and that not. So yeah, this lower and upper level will be replaced by 5th and 95th percentile respectively. So your 5th quartile, 5th percentile and 95th percentile, while it comes to upper, and then while it comes to lower, right? This is lower, right? So this is how we can do that. Now let me do that. Okay, now I have written data of blood pressure and data of blood pressure dot clip. Again, you are going to clip the blood pressure column data. For skin thickness, yes, you are going to again clip skin thickness. For insulin, you will clip insulin. You will clip BMI, diabetes pregnancy function, and age, right? Wherever we have seen this particular, outlier. Then what we need to do, we again need to plot our box plot to understand, do we have again any outlier in our data set? If we have, how can we, replace them again with the clip function to clip our data to remove outliers, right? So we are going to write plt.subplot the same way, 441, then SNS.BoxPlot, and then for pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes predictive function, and age, right? Can you see? For the case of pregnancy, again, you do not have any outlier. Glucose, blood pressure, skin thickness, age, diabetes predictive function, and BMI are fine. For skin thickness also, you have a little outlier, right? So skin thickness and insulin is not worked out, right? As we can see, there are still outliers in the column called skin thickness and insulin. Let's try manipulating them with the percentile value. Now we will try to do heat and trial. Now we have written that, again, we are going to clip, and quartile will be 0.07 to 0.93. Let's see how it's going to work. And for insulin also, we have written 0.21, the lower one, and the upper one we have written 0.80. Now if I just plot both of them, insulin has worked, insulin didn't work, but skin thickness has worked on. Now let's manipulate insulin little more. I have write quartile equals to 25% for the lower, and the upper will be 0.75%. Now if I just plot it, can you see your insulin is also worked and there is no outlier for your insulin. So this is how we can actually help to remove outliers from the data. The outliers of data skin thickness were treated by minor changes in the percentile, but the outer layers of insulin require a major changes in the percentile. This might result in too much data manipulation, which might again, it's not good for your model. Attribute insulin might have to be removed from the dataset. It will give you good value, because as you have to manipulate your insulin for so many times. So this is what missing value and outlier analysis stands for. Now after this part, we will talk about data visualization. How can you visualize our data using Matplotlib and SeaBorn? Now we are going to see how can we do the data visualization. But what are the things we have done so far? We have talked about how can you understand data using pandas. Then we will jump into how can I see that my data is already uploaded. Then we have used pd.readcsv. Then we go for understanding missing value and basic terms to understand your data like describe, info and all. Then we have talked about missing value. How can I find it out? Missing value. Maybe in the simple case, you will not get any missing value. You have to go and deep dive and need to see, do you really have any missing value or not? If you don't have any missing value, then it's fine. If you have missing value, you have to make sure that you are those missing value are treated. Then we go for outlier analysis. So it's basically trying to understand, do we have any error in our data set or any anomaly? If we have outlier, we will try to replace them using interquartile range, right? Now we will do the data visualization. Now we are going to use SNS.CountPlot. So we just try to understand what is the data set we have, where how many people are diabetic, how many people are non-diabetic. Right, in that case, we are going to use outcome column. As I said, outcome is 0 means the person is not diabetic. Where your outcome is 1, then it's showing that your person, the person is actually diabetic. So you have written data SNS.CountPlot. This SNS.CountPlot is basically give you the total count of your data for 0 and 1, the different class we have. Now in the case of count, you can see 0 is high, 1 is low. So 0 means the more person you have is non-diabetic and 50% of the person you have diabetic, right? So this is where the SNS.CountPlot stands for. We have already talked about CountPlot, right? Why don't you guys see what are the things we can do using this particular data set where we can use CountPlot, right? Now we will see the observation again. From the above plot, we can infer that the majority of the data consists of non-diabetic patient. Let's try to understand the percentage distribution of diabetic versus non-diabetic in the data set. Now what you have written? You have written total equals to float and then length of your data. A little bit of programming we have done here. Now you have written AX equals to SNS.CountPlot and your X equals to outcome and data equals to the data set you have. For P in AX.patches, height equals to P.get height. AX.text P.get underscore X plus P.get underscore width divided by 2. Height plus 3, right? Why do we have done those things? To get the percentage of the data. You can see the 65% of the data contains records belonging to non-diabetic patient and the 35% of the data is saying you have a diabetic patient. The dataset has a class imbalance and might have to be treated in future during the model building stages. While you try to build a model, maybe logistic regression, we will talk about linear regression analysis. We will talk about machine learning as well. But yes, if you want to model, you have to make sure you are going to use the class imbalance technique. Not now, you need to don't know about it. But yeah, these are the things. It's as suggested. Now we will see if we will do a correlation. What is correlation? So let's now plot a correlation plot. That is this plot will help us understand if there is a multicollinearity in the data set or not. So what I have written f comma ax. Again, we are going to understand this figure size, that plt.fixsize, fix size equals to 20 comma 10. Then for correlation, you have to just write data.correlation, what type? Pearson. Now you have written SNS.heatmap and then your correlation, right? So you will get what? You will get this correlation 1. Can you see correlation with pregnancy and pregnancy? It will be always 1. That's why diagonally all the index you have, that is 1, right? This is something like the read part is the more high, like morely highly correlated, right? Now from the above correlation, it can be inferred that there is no high multipolarity in the data set. The correlation plot shows the relation between the parameters. Glucose, age, BMI, and pregnancies are the most correlated parameters with the outcome. Insulin and diabetes predictive function have little correlation with outcome. Blood pressure and skin thickness have tiny correlation with the outcome. There is a little correlation between age and pregnancies, insulin and skin thickness, BMI and skin thickness, insulin and glucose, right? Now we are going to work on pair plot, right? And this is what we are going to do, and that's all for our data visualization. What is pair plot? Pair plot is a pairwise relationship in the dataset. If you want to see pairwise relationship, the pair plot function creates a grid of axes such that each variable in the data will be shared in the y-axis across the single row, in the x-axis across a single column. Now to get the pair plot, I have written SNS.pairplot. Data u equals to outcome, and like this, what how we are going to do a pair plot. But working on pair plot, it takes time. Why? Because pair plot is making pair plot each and every columns you have, right? Let's see how it's going to work. We will see about pair plot. Let's see how it's going to work on pair plot. So I hope you guys have understood all the technique we have done so far. If you have any doubt, do not forget to let me know in the comment. I will happily help you to solve your doubts. And if you like the video, do not forget to like it and subscribe. Great learning. So can you see, this is what the pair plot we get. Now what I want to understand from the pair plot, what are the things we can conclude? We can infer that the most of the predictor variables are weak predictors of outcome. The kernel density plots the diagonal suggest that the distribution for diabetic and non-diabetic are very similar and are overlapping each other significantly. Hence, they won't be able to differentiate between a diabetic patient and a non-diabetic patient. The scatter plot also suggests very poorly correlated data with not hidden patterns or relationship. Hence, model built on this data might not be able to find out any hidden patterns or might identify nonsense patterns that do not make sense. The plot shows that there is some relationship between parameters. Outcome is added as hue, that variable. What is hue? The variable in data to map the plot aspects to different colors. We see that blue and orange dots are overlap. Pregnancies and age have some kind of a linear line, and blood pressure and age have the little relation. Most of the aged people have blood pressure. Insulin and glucose have some relation. This is what we can actually conclude from the pair plot we have done. Right? I hope you understand how to do a anomaly and outlier detection. How can you make sure that you are making sure that whatever the exploratory data analysis you are doing in your data, it's giving you enough insights to work with your data. Right? This is what we have done about this particular diabetes data set. Now, in this part, we are going to do one more exploratory data analysis on different data set. We have done exploratory data analysis, outlier detection in diabetes data set. Now we are going to use automobile dataset. Where you will get the dataset? You will get the dataset on www.kaggle.com. Just click on the link. You will redirect to this particular dataset. It's a free dataset and you will get this dataset on Kaggle. Now, if you want to download this particular dataset, just click on download and it will automatically start downloading. Right? So this is pretty much about the dataset where you will get the data. Now let's talk about the dataset description, right? So in 1985, model input car and truck specifications, and 1985 words automate yearbook. So personal auto manuals, insurance service office, 160 Water Street, New York, NY 10038. Insurance collision report, Insurance Institute of Highway Safety, Watergate 600, Washington, DC 20037. Right? So this data set consists of three types of entities, right? What are those entities? So basically entities is nothing but the columns we have. And the specification of an auto in terms of various characteristics. B, it's assigned insurance risk rating. It's normalized losses in use as compared to other cars. The second rating corresponds to the degree to which the auto is more risky than its price indicates. So cars are initially assigned a risk factor symbol associated with its price. Then if it's more risky or less, this symbol is adjusted by moving it up or down the scale. Actuarians call the process symboling. A value of +3 indicates that the auto is risky, and -3 that is probably pretty safe. The third factor is the relative average loss payment per insured vehicle year. This value is normalized for all autos within a particular size classification: two-door small, station wagons, sports or specialty, etc., and represents the average, represent the average loss per car per year. Right? So I know this is little complicated while we are talking about the dataset description. So let's talk about more in depth in the dataset. So if you do not know how to, upload the data, you have to just click on this particular button, and from there is an option for upload the station storage. We have talked about before as well. Just click over here, it will redirect to you to your local system, right? And this is how you can upload your data in the session storage. My dataset is automobile_data.csv. Now I have imported few packages. I have imported Pandas, NumPy, SeaBorn, and Matplotlib. So a quick, a question for all of you. Why do we use SeaBorn and Matplotlib? Please let me know in the comment section. And if you like the video, do not forget to like it. And if you want to get updated with the new content, then do not forget to subscribe. Great learning. Right? So how can you load the dataset? You have to use a function called .read_csv. We have talked about that before as well. But as a recap, just to remind you, so we use .read_csv function to read CSV file. So I have written automobile_data.csv. Right? Now, okay, I forgot to install this, importing these libraries. Okay. Now if I just write it, yes, it gets executed. Now if you want to see the first 5 rows of the data, how can we do that? We just need to write data.head. Right? Let me do that. Now if you want to see the columns in your data set, how can you do that? You have to write data.columns. Right? I have written data.columns. Now, if you want to see the shape of your data set, how can you do that? You have to write data.shape. So it will give you the total shape of your data, how many rows you have, how many columns you have. Let me do that. Right. Now, I want to see the first 10 rows of my data. What I need to do? I have to write data.head. And under the parentheses, you have to write 10. Otherwise, in default, it will give you 5 rows. So here it gives me 10 rows, right? Now, if I want to see the last of the data, from the last, if I want to see the rows, I have to write data.tail. What it will return? It will again return the 5 rows from the last from your data set, right? So total data, how much you have? 205 data. So as it counts from 0 to till 2043,210. You got the last 5 rows of your data. Now, if you want to check, do you have any null value or not? What we need to do? we have to use a function called dot is null. And why we are using any, please let me know in the comment section, because I have already explained that. Right? I have written data dot is null dot any. So basically it's going to return, yeah. So if you have any null value in your data set, it will show here. So for all the cases, it's false. So you do not have any null value. Now, why do we use data.describe? It's basically describe few things about your data set. So total count of your data, what is the mean value for each and every column you have, then what is the standard deviation, then minimum value you have in the data set. Then if you just want to like part your data that IQR range, right? First part, second part, third part, fourth part. So first quartile, second quartile, and so on, right? So 25%, 50%, 75%. And then you have max value in your data, right? So this is what a data.describe function describe us about the data. Okay. Now you can see from the above snapshot of the data, we can see that some columns have missing values. What are the missing values? No, I cannot see here. Okay. Right. So yeah, can you see here? This is the like maybe you did not get any null value, but you have the question marks, right? Can you see? Okay, if you can see, please do let me know in the comment section. So yeah, can you see we have this? We have to remove this. Okay. So for is null, maybe it's not taking as null value, but we do have few values that's inappropriate while we are going to do this data analysis. Now we have to what? We have to remove them as a missing value detection and treatment, right? So let's start by checking the info, right? The count of the records in each columns of the data. If the count of the records is lesser than the total number of records, so we can conclude there are blank records. So no, we do not have any blank records, right? But the records are representing this. These are the actually blank records, right? Now, since some of the predictor columns are continuous in nature, there might be a chance that zeros in the columns indicates the missing value that we have done earlier as well. Now, if I just try to write data.describe.t, then you can see here the same thing, right? So here we are saying none of the continuous seem to have a missing value represented by 0. We can also see there are a total of 11 continuous variables, but the describe table has only 10 continuous variables. This is because of column normalized losses has missing values, right? So here, how can we do that? So here we can see we are going to use NumPy. So we have written from NumPy import nan. And data of normalized losses equals to data of normalized losses dot replace that question mark, comma. I want to replace the question mark with np.nan value. If I just do that, and then if I just do the data.head, you can see we do have nan values. These are the different way you can understand you do have missing value and you have to handle them with care, right? Now you have to write data.head if you want to see again. Now I want to see something that data.isNull.sum. Now I will get the actual sum of the null values. So for normalized losses, we have 41 null values, right? So normalized has 41 missing data points, and we will replace this missing values with the median of normalized losses because median is least affected by outliers, right? So if I just write data.fillNA data.median, comma, in place equals to true, right? So I want to fill my nan values with the data of median. Now, if you want to see what is median differently, let me show you. I have shown it in the previous project as well. Let me just show that. Okay, data.median, it will give all the median value for each and every column you have. So for normalized losses 115, it will automatically replace those with the 115. Let me show you. Yes, can you see all the nan values are replaced with median? This is how you can actually replace your nan values, and how can you treat these missing values. Now if I try to see data.isNull.sum, then it will give me 0, that we do not have actually any null values. Now if I just don't want to go for data.info, right? So now what we need to do, so you can see over here that notice that the data type of normalized losses is object. We have to change its data type to numeric float. Yes, because we don't want to have a data type of object, we want to make it a numeric value. How can you do that? You have to write data of normalized losses equals to pd dot, right, to underscore numeric, if you want to change something to numeric. And then I have given data normalized losses comma down class equals to float, right? Now if I just write data.info, it will show that normalized losses is float 34.2, right? It's not numeric value. We have done it, right? Okay, what is this? Okay, right. So now if I just do the info, it's done, right? Now that we have treated the missing value, let's move to the outlier detection and treatment. Now we will see how can we do the outlier detection. So outlier detection is basically, we can find it out by using BoxPlot, are a great way to detecting outliers. Once the outliers have been detected, they can be inputted with the 5th and 95th percentiles, right? So I have written data.columns, right? And then we have just done the outlier detection using BoxPlot, right? We have written plt.flicker fixed size 20, 15. Then we have written plt.subplot 3, 4, 1. So what subplot you want? Like, this is the portion you are giving while you have a plot, and then you have the subplots, right? And your figure size will be 20, 15. Then you have given the normalized losses, symboling, wheelbase, length, width, all the columns you have given to see what are the columns has the outlier. You can see this at the outlier for highway MPG. You have compression ratio, you have engine size, width, OTG, MPG. You have the outlier. Okay, few of the columns have the outlier, right? So you can see how the outliers, this dotted are nothing but the outliers you have. Now, like from the above box plot, we can infer that out of 11 continuous variable, 8 of them have outliers. These outliers will be imputed with the, right? Imputed with the 5th and the 95 percentile. How we did? We have used a clip function. So again, for your a sweet question to all of you guys, what is clip function? Why do we need to use clip? Please do let me know in the comment section, for that we can understand you are actually listening to us. If you like the video, do not forget to like it and do not forget to subscribe. Great learning. Now we have written data of normalized data equals to data dot normalized losses. Okay, clip lower data dot quantile 0005 upper is equals to quantile 0.95. Let me just do the for all the columns we have, and then we are going to again plot the box plot. Can you see? All the columns have no outliers. So you have successfully handled the outlier we have in the data set. Now you can see you can go forward with the data. Now we will do few data visualization. What are those data visualization? We try to understand the pair plot. How can we do that? We have written sns.pairplot. What is sns.pairplot data, and then it will give you the pair plot. Pair plot is nothing but giving the relation between different columns you have, right? So let it get printed. Let's see. Let's wait for a few minutes, and in the meanwhile, if you have any doubt, please do let me know in the comment section. For that, I can help you out to solve your doubts as well, right? Let's see. Okay, it's coming. SeaBorn. And pair plot we are using from SeaBorn. So that's why it's sns.pairplot. As the data set is little bit, big, that's why doing the pair plot, it's taking little much of time. Okay, so it takes a little bit of time, but you can see this is what it's showing, that you get the pair plot, right? Okay, So some of the kernel density estimate plots show more than one peak and indicating the presence of clusters in the dataset. So basically, maybe you have clusters in the dataset, right? Now, if I just want to go for decorrelating data, like understanding the correlation between different columns we use data.code, that's Pearson, and then we have used the sns.heatmap. So this heat map is nothing but your correlation between different columns you have. So with symboling it's one, you can see, and this is the it's more of a rate. This is the more of like your columns are correlated, right? So the above correlated plot shows presence of multicollinearity in the data set. You can see there are multicollinearity we have in the data set, right? And if you just want to go for few understanding few visualization, how to do that? So I just write data.symboling.histogram. I want to understand the histogram. Then I have given the title as insurance risk rating of vehicle, number of vehicles, risk rating. This is the risk rating according to the vehicles, right? From the above histogram, we can infer that a major part of distribution lies between the range of 0.5 to 1.5. We can also infer that a large number of cars in this dataset are safe. Obviously, cars are mostly safe. Now, if I just want to understand the frequency chart, then fuel type, that data of fuel type dot value counts dot plot that kind equals to bar, right? And we have written plt dot title, frequency chart and fuel type, number of vehicles and fuel type, right? Let's see, number of vehicles and fuel type. Yes, you can see this is the number of vehicles and this is the, like we have gas is more, diesel is less, right? So the above bar chart, we can infer that the majority of the car recorded in these data sets run on gas, right? Now we will do few things about the data set, the data pre-processing. This data set has 15 categories variable and most of them have more than 2 categories. We cannot run a regression model on the text data. So we actually are going to talk about regression model. You have to keep tuned to know about regression model. And in the meantime, let's see how can you do the data processing. So in the order to deal with this challenge, let's learn about level encoding. Level encoding is the process of converting categorical data into numerical data. Let's see how this is done. In the example, we will be working with the variable body style, which has 5 categories, namely convertible, hatchback, sedan, wagon, and hardtop. Now what we have done, we have just done data of body style, head 20. So I just want to see the 20 data from this particular column. Now we are going to do a level encoding. How to do a level encoding? So basically for each and every vehicle, you will get an idea, you will get a numeric value. Suppose you have the person is diabetic or not, you have 0 and 1. So you have 5 different parts, like 5 different types. So you will have 0, 2, 0, 1, 2, 3, 4. This is what stands for level encoding. So I have written Scikit-Learn, that is Scikit-Learn import pre-processing, and from Scikit-Learn pre-processing import label encoder. Then I have just called the label encoder and just I have given my label encoder dot feed transform data of body style. Then if you just write .k20, you can get that what are the thing you have for a particular, suppose you have for convertible, it's converted to 0. Then hatchback converted to 1. So for all the hatchback, you will get 1. For all the convertible, you will get 0. For all the sedan, you will get 2. This is how we did the label encoding, right? So after running the label encoding code, we can see the variable body style has numeric values ranging from 0 to 4. The problem with the table encoding is that it introduces an order between the categories, that 0 greater than 1, 1 greater than 2, 2 greater than 3 and 4. This might confuse the model into thinking that convertible is greater than hatchback. So to deal with this problem, let's understand the concepts of one-hot encoder. In one-hot encoding, categorical columns have been labeled encoded are split into multiple columns and the values are replaced with zeros and 1. 1 marks the presence of value and 0 its absence, right? Let's look at the example. So I have done this particular label encoding And then now I'm going to go for one hot encoding. So again, to import one hot encoding, I am going to import it from Scikit-Learn. And then I have called one hot encoder handle unknown equals to ignore. And then I have given my dataset to transform. Now, if I just want to show you what's happened, can you see you get 1000. So you have total 4 class, right? Total 5 class, 0, 1, 2, 3, 4. So if your class comes under 0, it will be 1. If your class comes under 2, it will give 1, and other than everything will be 0. So there will be no like 0 greater than 1, 1 greater than 2. These concepts will not be there. That's why we went for one hot encoding. Right. So this was pretty much about the data pre-processing. We have done the data visualization. How can you handle outlier? How can you handle like different multicollinearity, and also like how can you find it out multicollinearity in the data set, and how to do the outlier analysis as well using BoxPlot. Right. So we have talked about everything in the both of the data set. I hope you will like it.
So we have an interesting case study now. We have a IPL dataset, and we'll be thoroughly analyzing this IPL dataset with the help of the Pandas library and the visualization library, which is Matplotlib. So our first task would be to import all of the required libraries. So what we'll do is we'll go ahead and type in import pandas as PD. PD is the alias for pandas. Then we'll also go ahead and import the PyPlot submodule from the Matplotlib module. So here we'll have from Matplotlib import PyPlot as PLT, and PLT is the alias which we are giving for PyPlot. And finally, we'll also include one more visualization library, which is SeaBorn, and that is why we will have import SeaBorn as SNS. Let me just go ahead and click on run, and let's wait for all of these libraries to be loaded. So it'll take a bit of time. So these are the 3 important libraries which we'll be needing to thoroughly analyze this dataset. So now that we have loaded all of the required libraries, we would have to load the CSV file. And we have the CSV file called as matches.csv, which has all of the details of the different IPL matches. And we already know that to load a CSV file, we would need to use pd.read_csv. And inside this, we will given the name of the file, which is matches.csv. And that we will store in this object called as IPL. So now that we have loaded this matches.csv file and we have stored it into the IPL object, let me go ahead and have a glance at the head of this data frame. So I'll have IPL.head, and we also know that the head method gives us the first 5 records of any data frame. So if you see over here, I have 1, 2, 3, 4, and 5. So these are the 5 records, or the first 5 records from this IPL data frame. So let's just look at the different columns which are present in this data frame. We have the ID column, which would tell about the unique match ID. So here each record represents one unique match, or one match which was played between different teams. So here, as you see, the match ID is 1, and this match ID 1 represents that particular match in 2017 between Sunrisers Hyderabad and Royal Challengers Bangalore. Then we have match ID 2, which would represent the match between Rising Pune Supergiants and Mumbai Indians. So this is how, or this is what the ID column tells you. Then we have the season column, which would tell you in which season or in which year this match had been organized or this match was played. So as you see over here, the first 5 records, these represent the matches which were played in the year 2017. Then you have the city over here, in which city was the match played in. So this match between Sunrisers Hyderabad and Royal Challengers Bangalore was played in Hyderabad. Then you have the date column over here, and the date tells you the exact date on which this particular match was played. So this match was played on, so you have 2017-04-05. So this would be 5th of April 2017. So team 1, team 2, this just indicates who are the or what were the two teams playing against each other. Then you have the toss winner. Which team had won the toss? So between these two teams, Royal Challengers had won the toss. And after winning the toss, what did the team decide to do? So here you have the toss decision column. And this column tells you that after winning the toss, Royal Challengers Bangalore had decided to field. Then you have the result column. So in result column, we have three categories, and those three categories we'll look at them later on. Then you have DL underscore applied. This DL underscore applied tells you if the Duckworth-Lewis method was applied or not. And Duckworth-Lewis method would obviously only be applied if there was rainfall. After that, we have the winner column, which tells us which team has won the match. So this match between Royal Challengers Bangalore and Sunrisers Hyderabad, this match was won by Sunrisers Hyderabad. Then you have win by runs and win by wickets. So this column over here tells us that since Sunrisers Hyderabad had batted first, they have won by 35 runs. Over here you have the win by wickets column. Now you'd have to understand this interesting thing over here. So if a team bats first and wins the match, then it will be winning by a certain number of runs. But on the other hand, if the team batting second wins the match, then it will be winning by a certain number of wickets. So here, since the team batting first has won the match, that is why you have a value in this column and you don't have a value in this particular column over here. Let me give another example to make you understand it better. So let's say the team batting first has scored 100 runs and the team batting second was all out on a score of 75. Then we would say that team batting first has won by a margin of 25 runs. On the other hand, let's say if team batting first has made 100 runs and team batting second has achieved that score by losing 2 wickets, then we'll say that the team batting second has won by 8 wickets. So that is what is meant by win by runs and win by wickets. So if a team batting first wins, then we'll have a value in this particular column. And similarly, if a team batting second wins, then we'll have a value in this particular column. Then you have the player of the match column over here, which absolutely tells you who was the man of the match or player of the match for that particular game. And in this game between Sunrisers Hyderabad and Royal Challengers Bangalore, Yuvraj Singh, the sixer man who hit sixes on a well, was the man of the match. Then you have the venue over here, and this match was played at Rajiv Gandhi International Stadium, Uppal. Well, I've actually seen an IPL match over there, so it's a pretty stadium. Then you have 3 columns which would tell you who is the first umpire, the second umpire, and the third umpire. So this is all about this particular data set. So now that we have comprehensively looked at this data set, let me see how many rows and how many columns are present in this data frame. And for that purpose, I will have the shape method. So I'll write down IPL.shape, and this will tell me the number of rows and number of columns present in this data frame. And as you see over here, I have 636, 18, which would mean that there are 636 records and 18 columns. And the 636 records also tell you that there were 636 unique matches played. Then I would want to know the frequency of most man of the match awards. So here, this column which you see, player of match, I would want to know which player has won how many man of the match awards. And since this is a categorical column, we have seen that if you would want to find out the frequency of a categorical column, we would have to use the value counts method, and that is what we'll be doing over here. So what I'll do is I will give in the name of the data frame, which is IPL, and inside parenthesis I will give in the name of the column, which is player of match. After that, I will give in the dot operator, and then finally I will use value counts method, and this will give me the frequency. So here, as you see, Chris Gayle, the universe boss, has the most number of man of the match awards, which is 18. Then you have Yusuf Pathan, who has got 16 man of the match awards. After that, you've got AB de Villiers, who's got 15 man of the match awards, and you have David Warner, who's got 15 man of the match awards, and so on. Now, from this list, I would want to get only the top 10 players with most man of the match awards. So here the entire command will be the same. It's just that I will give in another parenthesis over here, and inside the parenthesis I will give in 0:10, which will give me the 10 players with most man of the match awards. So this, what we are doing is just a subset of this particular result. So here, as you see, we have Chris Gayle, Yusuf Pathan, AB de Villiers, David Warner, Rohit Sharma, Suresh Raina, Gautam Gambhir, MS Dhoni, Michael Hussey, and Ajinkya Rahane. So these are the top 10 players with most man of the match awards. And similarly, instead of the top 10, if I would want only the top 5 players with most man of the match awards, in parenthesis, I will give in 0:5. And here, as you see, these are the top 5 players with most man of the match awards. Going ahead, what I'd want to do is, I would want to make a bar plot for the top 5 players with most man of the match awards. And if I would want to make a bar plot, obviously I would have to use the Matplotlib library. So I have already imported the PyPlot submodule from the Matplotlib library and have given it an alias of PLT. Now what I'll do is I will write plt.figure, which would help me to set a figure size. So plt.figure, inside this I will use this parameter called as figure size, and I will set the figure size to be equal to 8,5, which is just the dimension of the plot which I'll be displaying right now. Then we have also seen that to make a bar plot, we would have to use plt.bar. So I'll write down plt.bar, and inside this we have seen that the first parameter needs to be a categorical value and the second parameter needs to be a numerical value. So here the categorical value will be the name of the player or all of the names of the players. So here, as you see, we've got the names of the players and also we've got the values of, or the result or the number of man of the match awards of these players. So to get the categories or the names, we would have to use the keys method. So here, as you see, this is the command which will give me this entire result, which is what I have over here. So this is the same thing. It's just that after this, I'll use dot operator. Then I will use the keys method and only get the names out of this. And that is what I'm showing you out above here. So as you see, when I use the keys method, this will only give me the names of the players. And similarly, if I would want only the values, I will just use this. That's it. So this command will give me only the values. So I have taken the categories, I have taken the values as well. Now after that, I would want to set a color to these bars. So here I have given color as equal to G, which will give a green color to all of these bars. And to finally show out the image or to plot the image, I would have to use plt.show over here. So as you see, we have successfully made a bar plot which would tell us or give an interpretation of the top 5 players who have received the most number of man of the match awards. And you see there's not much of a difference over here. So you have Chris Gayle leading, then you have Yusuf Pathan, AB de Villiers, David Warner and Rohit Sharma. Now, we had the result column over here. So I would want to know the frequency or the different categories of this result column. And if I would want to know the frequency, again, what we have to do is use the value counts method. So as you see over here, IPL is the name of the data frame, and inside parenthesis, I will give in the name of the column. So here the name of the column is result, and I will use the value counts method when I click on run. As you see over here, I have three categories: normal, tie, and no result. Normal here would mean that the match has progressed normally, which would mean that one team has won the match and another team has lost the match. Then you have tie. Tie would mean that both the teams have scored the same number of runs. Then you have no result. No result would mean that either the match was called off or it was washed off because rain or some other disturbance. So these are the three different categories which we have. And out of all of these matches, most of the matches have been done normally, and there were 7 instances where there was a tie. So out of all of these seasons, so I guess there would be 8 or 9 seasons. So out of the 636 matches, there were only 7 instances where there was a tie. So this is a very interesting insight over here which we have found out. Going ahead, I would want to find out which team has won the most number of tosses. So here, let me just show you this particular column, toss winner. So this toss winner column would tell us which team has won the toss. Now what I'm doing is I would want to know the value counts or the frequency of different categories of this toss winner column. And here, as you see, Mumbai Indians seem to be very lucky. So they have won the most number of tosses. So Mumbai Indians has won 85 tosses. Then we have Kolkata Knight Riders close behind with 78. Then you have Delhi Daredevils with 72. After that, you have RCB with 70 and so on. Now, I would want to know what team or how many teams have won the match batting first. So what is the percentage distribution of a team batting first and winning the match? And I've already told you guys that if a team wins the match by batting first, then we will have a value in this particular column. So it cannot be a 0. So if you have a 0 in this column over here, it would mean that the team batting first has lost the match. But I don't want that. What I want is, I would want all of those records where the team batting first has won the match. Which means I would want all of the records where the value is not equal to 0. And that is what I'll be extracting from this entire data frame. So here, as you see, from this IPL data frame, from the win by runs column, I am extracting only those records where win by runs is not equal to 0. And I will store all of those records in this new object called as batting first. Now that this is done, I will have a glance at the top 5 records of this. So I'll have batting first dot head. And here, as you see, I have the list of all of those records where the teams have won batting first. And also, if you look at this particular column over here, I don't have a 0. We have some values. So here, between this match of Sunrisers Hyderabad and Royal Challengers Bangalore, we have already looked at it. So Sunrisers Hyderabad has won the match with 13 runs. Then between the match of Royal Challengers Bangalore and Delhi Daredevils, RCB has won the match by 15 runs. And this seems to be a huge margin over here. So this is the match between Delhi Daredevils and Rising Pune Supergiants. And Delhi Daredevils has won the match by 97 runs. So going ahead, I'd want to do more of visualization. And I'd want to see the distribution of this particular column, win by runs column, for all the teams who have won the match by batting first. And since this is a numerical column over here, I will obviously be making a histogram. So first, to make this histogram, I'll have to use plt.figure. I'm setting a figure size over here, and the dimension I'm setting it to be 7x7. Then to make a histogram, we already know that we will have to use plt.hist. And inside this, I will just directly pass in the column for which I'd want to make the histogram. So here it will be batting first, which is the name of the object, and I'll give in parenthesis and given the name of the column, which is win by runs, and I'll have plt.show. So here this is interesting, as you see over here. So on the x-axis, we have the number of runs by which the team has won. On the y-axis, we have the number of instances this has happened. So let's say if I take this over here, so this bin tells us that there have been around 100 matches where teams batting first have won in the range of 0 to 20 runs. Similarly, if I look at this particular bin, so this particular bin would tell me that there have been around 80 matches where teams batting first have won in the range of maybe 15 to around 30. Similarly, if I look at this particular bin over here, this would tell me that there would be around 18 matches where teams batting first have won in the range of maybe 75 to 85. And similarly, there would be very few matches. There would be only 3 or 4 matches where teams batting first have won by more than 120 runs. So all of this is some sort of insights which we were only able to find out after building this beautiful histogram. And also, if you would want to add a title, that is something which we can absolutely do. So here I'll just write down plt.title, and I will give this the title of distribution of runs. So here, as you see, I have given this title, and if I would want to give an x-axis label, I'll write down plt.xLabel, and I'll just write down runs over here. And as you see, the x label is runs and the title is distribution of runs. So after this, I'd want to find out the number of wins with respect to each team after batting first. So when I say this, what I basically mean is I have the winner column over here. So I just want to get the frequency of this winner column. So I want to know which team has won how many times after batting first. Let me just scroll down over here. So batting first, and in batting first, I am selecting the winner column and I'd want the frequency of this. So here, as you see, Mumbai Indians has won the most number of times after deciding to bat first. So Mumbai Indians has won 47 times after deciding to bat first. Then closely following behind, you have Chennai Super Kings with 46 wins. Then as you see, you have a huge difference over here between Kings 11 Punjab and Chennai Super Kings. So the top two teams, it seems that they win a lot after batting first. But then you see this disparity over here. Kings 11 Punjab, the third team to win the most number of times. There's a difference of 14 times over here, or 14 wins over here. And that's a huge disparity. Now, what I want to do is, I want to make a bar plot for the top 3 teams with most wins after batting first. And again, we'll do the same steps. First, I'll have to set the figure size. So I'll have plt.figure. Inside this, I will use this parameter fig size, and I'll set the dimensions to be equal to 7,7. Then I'll have plt.bar, and we already know that this takes in 2 parameters. So the first parameter is basically all of the categories, and the second parameter is the values for all of these categories. So to get the categories, which are Mumbai Indians, Chennai Super Kings and Kings 11 Punjab, so this command will be the same over here. This entire thing will be the same. It's just that after that I will give in the keys method, and this entire thing I will pass in a list. So I've got the categories. After getting the categories, I would need the values. So it'll be batting first, winner value counts 0 to 3. And I'm setting colors for, or I'm basically setting 3 different colors for all of these different bars. So I am setting blue color for Mumbai Indians, yellow color for Chennai Super Kings, and orange color for Kings 11 Punjab. And as you see over here, this is what I have. I have a beautiful representation of the top 3 teams winning most number of times after batting first. So here, as you see, there's not much of a difference. But here, this is a huge gap over here between Kings 11 Punjab and Chennai Super Kings. Going ahead, I'd want to make a pie chart for the distribution of wins. So to make a pie chart, I'd have to use plt.py. And also before that, again, I just have to set a random figure size. So by default, I'm setting the figure size to be equal to 7,7. And since I would want to make a pie chart, I will have plt.py and over here. So the difference between, as you see over here, between making a bar plot and a pie chart is the first parameter we will give in the numerical entities and the second parameter we will give in the categorical values. So the first parameter will have batting first winner dot value counts. The second parameter is batting first winner value counts dot keys. Now that we have given this, I will have auto PCT is equal to %0.1f which would help me to show the percentages on top of the pie chart which I have created. So as you see over here, with 16.4% wins, when compared to other teams, you have Mumbai Indians leading. So you have the biggest slice over here. Then you have Chennai Super Kings with 16% wins. After that, you have Kings 11 Punjab with 11.1%. Then you have Kolkata Knight Riders with 10.8% and so on. Now over here, let's say if I don't want these percentages, what I can do is I will just go ahead and remove out this parameter over here. Now, as you see, if I have removed the auto PCT parameter, I will not have anything on top of this pie chart. So till now we have analyzed how teams have performed after batting first. Now, similarly, I would want to look at those teams who have performed well after batting second. Now, for this, we have already seen this. So, if a team has won the match after batting second, you will have a value in this particular column. Or in other words, we will extract all of those records from this entire data frame where the value in this column is not equal to 0. Let me scroll down. And here, as you see, from the IPL data frame, I am extracting only those records where the value in win by wickets column is not equal to 0. And I will store all of those records in a new object called as batting second. Now, I will have a glance at the first 5 records of this new object which we have created. So, as you see over here, if I show you this particular column, you would see that we definitely have a value over here. And if you look at win by runs, you have only zeros present. And that is because if a team batting second has won the match, you will have a value over here and not over here. Now, as we had done with teams batting first, similarly, I would want to understand the distribution of this particular column. That is, the distribution of how teams have won with respect to number of wickets. And since this is a numerical column, I'll be making a histogram. First, I will go ahead and set out the figure size. I will have plt.figure. Inside this, I am using the parameter fig size and I am using a default size of 7,7. Going ahead, I will use plt.hist and inside this I will just pass in the win by wickets column and I am setting the number of wins to be equal to 30. Then I just go ahead and show you guys the plot. So we have an interesting histogram over here. So what this tells you is there have been around 70 instances or 70 matches where the team batting second has won with 7 wickets in hand. And if I look at this, so this bin over here tells me that there have been around 15 matches where team batting second has won the match with 3 wickets in hand. If you look at these two, 1 and 2, so there have been maybe let's say only 3 or 4 matches where teams batting second have won with 1 wicket or 2 wickets in hand. So it seems that if a team batting second has won the match, then most probably it would not have lost a lot of wickets, right? So here, as you see, you have this peak over here. So this is in the shape of a bell curve, and the peak is over here at 6 and 7. So you have this peak over here. So 4, 5, 6, 7, 8. So this is the normal distribution, or this is how normally the teams lose wickets. So normally it seems that the team batting second, if it has won the match, then it would lose around 4 to 8 wickets. Let's say if it loses more than 8 wickets, then there are very few chances for the team to win the match after that. And also if you look at this, there have been very few instances where the team has won with all of the 10 wickets remaining. So here maybe you have only exactly 10 matches. So that would have been exactly 10 matches where the team batting second has not even lost a single wicket and has gone on to decimate their opponent. So this again is an interesting analysis over here. Now after this, again I would want to make a bar plot for all of the teams who have won their matches batting second. So for this, let me just find out which of the teams have performed well batting second. So here from the batting second object, I am choosing the winner column and I'm using value counts method. So it seems that Kolkata Knight Riders have performed really well batting second. So Kolkata Knight Riders have won 46 times batting second. Then close behind you have Mumbai Indians who have won 44 matches batting second. Then you have Royal Challengers Bangalore also close behind who have won 42 matches. Then you have Delhi Daredevils who have won 41 matches after batting second. Now similarly, since I would want to make a bar plot for this, first I'll have plt.figure, fig size is 7,7. Then I'll have plt.bar over here. Over here, the first parameter, I would have to set, or I would have to choose the top 3 categories, which are Kolkata Knight Riders, Mumbai Indians and Royal Challengers Bangalore. So here what I'll do is I'll have 0 to 3 dot keys since I would want only the categories. Then since I would want the values, this is what I'll give over here. Then going ahead, I will give in colors. So to Kolkata Knight Riders, I am assigning blue color. For Mumbai Indians, I am setting green, and for Royal Challengers Bangalore, I am setting orange. Let me actually change these colors. So let me give in a purple color for Kolkata Knight Riders. Then I have, who do I have next? I have Mumbai Indians. For Mumbai Indians, I will give in a blue color. Then I have Royal Challengers Bangalore, and for RCB I will give in a red color over here so that this represents their jersey color. And as you see, I have changed the color. So Kolkata Knight Riders, since their jersey color is purple, I've given it a purple color, and Mumbai Indians, since they have a blue color, I've given them a blue color. Then we have RCB who have a red color, and that is what I've given them. Now, as we had done for teams batting second, I had made a pie chart to look at the distribution of the percentage of wins across different teams. And that is what I'd want to know with respect to teams batting second as well. So again, plt.figure, fig size will be equal to 7,7. Then I will have plt.py. Over here, the first parameter will be batting second winner dot value counts. So again, first I'm giving in a numerical value, then I'm giving in the categories. Again, auto PCT is equal to %0.1 F %%, which will give me the percentage values on top of the pie chart. Here, as you see, Kolkata Knight Riders with the maximum percentage of wins batting second, which is 13.6. Then you have Mumbai Indians close behind with 13%. Then you have RCB with 12.4% and so on. So these were some different visualizations which we had performed. Going ahead, I would want to look at the number of matches played in each season. So in the IPL data frame, we had the season column, and since I would want the frequency count of that, I'll just use value counts after that. IPL season dot value counts. And here, as you see, in 2013, we had the most number of matches played, which were 76. Then in 2012, we had 74 matches. In 2011, we had 73 matches. And over here in 2010, 14 and 16, we had exactly 60 matches played. So this is something which again is interesting. So most number of matches were played in 2013 and the least number of matches were played in 2009. Then I'd want to know which city has hosted the most number of matches. So IPL city dot value counts will give me the frequency count of this, and Mumbai hands down has won this. So Mumbai has hosted the most number of IPL matches, which are 85. Then close behind you have Bangalore, which has hosted 66 IPL matches. After that you have Kolkata with 61. And now I would want to do something interesting again. I want to know what is the percentage of a team winning if a team has already won the toss. So what I'm going to do over here is I have two columns over here, toss winner and winner. So if the value in this column is equal to the value in this column, it would mean that the team which has won the toss also has won the match. So if I compare this and this, the result would be no, because Royal Challengers has won the toss but has lost the match. Then if I compare this and this, here you would see that Rising Pune Super Giants has won the toss and also has won the match. So this again is interesting over here. So I'll be importing the NumPy library, import NumPy as NP. Then I will use np.sum, and inside this I will set toss winner is equal to winner. And this will give me 325. So it means that out of the 636 matches, 325 times, the team which has won the toss has also won the match. So what I'll do is I'll have 325 divided by 636, which tells me that 51% of the times a team winning the toss also wins the match. So this actually means that, there's not much of an effect of the toss. 50% is actually, well, it's 50-50, isn't it? It's either heads or it's tails. So toss maybe doesn't really affect the match that much. Now after this, we have another data frame called as deliveries, or another CSV file called as deliveries, which gives us ball by ball information of all of the matches in the above CSV file. So let me go ahead and read this file. I'll have pd.read_csv. Here I am giving in the name of the file, and this I will store in this object called as deliveries. So now that I have stored this, let me go ahead and have a glance at some of the records of this data frame. So here, as you see, I have ball by ball information. So here match ID. So in the previous data frame, we had looked at the match ID for Sunrisers Hyderabad and Royal Challengers Bangalore was 1. and this represents the same match. So for this particular match, Sunrisers Hyderabad and Royal Challengers Bangalore, for which the match ID is equal to 1, here these 5 records represent the first innings, which is Sunrisers Hyderabad's innings. And here, as you see, the first 5 balls, David Warner is on strike. So you have a ball by ball information of what is actually happening over here. And I'd want to know how many unique match IDs are there. So unique match IDs will tell me the unique number of matches. So deliveries match ID dot unique. So this, as you see over here, the values are from 1 to 636, which tells me that there are 636 unique matches. Now, out of all of these unique matches, I would want to extract only those records where the match ID is equal to 1, which means that I just want to analyze this particular match between Sunrisers Hyderabad and Royal Challengers Bangalore. So deliveries of match ID is double equal to 1, and this I will store in an object called as match1. And let me have a glance at the first 5 records of this data frame, and this we have already seen. And I'd want to have a glance at the shape of this data frame. So the shape of this data frame tells me that it has 248 records and 21 columns. Now let's understand this 248 records. What does this 248 mean? Well, a T20 match has 20 overs per side, and 20 overs per side would mean 120 balls. So 120 balls plus 120 balls would be 240 in total. So in the entire match, 8 extras were bowled. So counting both of the teams. So because you have 240 legal deliveries, so those 8 extra deliveries were either wides, no balls, byes, or something else. So this is also something which you were able to understand by using the shape method. And now, from this first match, I just want to analyze the first innings. So I'll set the inning to be equal to 1. And since the first inning is by SRH, that I would want to store in this object called as SRH. And I'd want to know the frequency of the different types of runs scored by SRH batsmen. So SRH batsman runs dot value counts. So this would tell me that 57 singles were taken. Then this tells us that there were 32 dot balls. We have 17 fours, we have 9 sixes, there were 9 couples as well, and there was 1 triple taken. Now I do want to know what were the different kinds of dismissals. So SRH dismissal kind dot value counts. So here it seems that only 4 wickets were fallen of the SRH team, and 3 of those were caught and 1 was bowled. And now we'll do the similar sort of analysis for RCB as well. So for RCB, what I'm going to do over here is, since the inning is equal to 2, match 1 inning is equal to 2, and this I will store in this object called as RCB. Now once that is done, I would want to know the different number of runs scored by the RCB batsman. So here, as you see, there are a lot of dot balls for RCB. When you compare the number of dot balls of RCB and SRH, this tells you the story of the match. So in SRH innings, there were only 32 dot balls. But in RCB's innings, there were 49 dot balls. And you have 44 singles, you have 15 fours, you have 8 sixes, and you have 7 twos. And I'd want to know the different kinds of dismissals. So RCB dismissal kind dot value counts. So 622, which would mean that all of the 10 wickets of RCB have been fallen. And out of those 10 wickets, 6 of them have been caught, 2 of them have been bowled, and there were 2 runouts. So here we have the FIFA 20 dataset, and we'll be performing exploratory data analysis on top of this dataset. And now we'd have to import all of the required libraries. So we are importing Pandas for data manipulation, obviously. Then we have Matplotlib and SeaBorn. So Matplotlib is a library which is used for data visualization. SeaBorn is also a library which is used for data visualization. So SeaBorn you can consider as it's an extension of Matplotlib. Extension in the sense that SeaBorn is built on top of Matplotlib. So these are the three libraries which I would need. And what I'll do is I'll actually restart the kernel so that you're not able to see the output initially. So for you, it will be much more easier to understand. Now I'll hit on run and let's wait for these libraries to load. All right, so we have loaded the required libraries. Then going ahead, we have this file called as players20.csv. So this is a file which I have already loaded in Jupyter Notebook. And to read a CSV file, we would need this method called as read_CSV. And this method read_CSV is a part of the Pandas library. So here, since I have loaded Pandas, so I'll write down pd.read_CSV. And inside this, I will give in the name of the file, which is players20.csv, and I will go ahead and store it in this object called as FIFA. And I'll just hit on run. Now, if I would want to have a glance at the first 5 records which are there, so I need to use the head method. So by default, this head method gives you the first 5 records which are there in this data frame. So FIFA.head. And here you would see that you have all of the different columns. So you have the FIFA ID, you have the player URL. So if you'd, so this is a column which just gives you the home page or the description of this player over here. Then you have the short name of this player. So here you have El Messi, obviously Messi, long name is Lionel Messi. You have Cristiano Ronaldo and you have Cristiano Ronaldo's long name. You have Neymar, you have Oblak, you have Eden Hazard. And here this column obviously tells you the age of this person. Here you have the date of birth. Then you have the height in centimeters of this player and the weight in kilograms of this player. Then you have the nationality. So Messi is obviously from Argentina. Ronaldo, we all know, is from Portugal. Neymar is from Brazil. Eden Hazard is from Belgium. And these are the clubs for which these folks play. Cristiano Ronaldo, he plays for Juventus. Messi plays for Barcelona. Neymar plays for PSG. Eden Hazard plays for Real Madrid. Then you've got all of these different stats over here. So for now, we'll just leave out those stats. So let's actually see how many columns are present in this particular data frame right now. So what we'll do is I will start a for loop and I would want to know all of the columns which are present. So what I'll write down is for call in FIFA.columns, and I will print out each of the column which is present in this entire data frame. So for call in FIFA.column, so what will happen is it will iterate from the first column. So it will start from this first column and it will go to the last column over here, and we are printing all of the columns which are present over here. So for call in FIFA.columns, print of call, when I hit on run, you would see that these are all of the columns which are present. You have FIFA ID, player URL, short name, long name, age, date of birth, height in centimeters, weight in kg, and so on. So you have a lot of columns over here. Now I'd want to know how many records are there and how many columns are actually present in this data frame. So for that purpose, I will use this shape method. I'll write down FIFA.shape and I will hit on run. And you would see that there are 18,278 records and 104 columns. So this is actually a huge data set. So, I mean, for performing a simple case study. So here, 18,278 records would mean that you have a list of 18,278 players in this entire data frame. and 104 columns are just the different features with all of these different players. So we've looked at the shape, and there is this column called as nationality in our data frame. So here, if you go up, you would see that there's this nationality column, and I would want to see how many players belong to which particular country over here. So since nationality is a categorical column, and if I want to understand more about a categorical column, I can use the value counts method. The value counts method gives me a frequency count of the different categories which are present. So what I'll do over here is, first I'll give in the name of the data frame, which is FIFA. Then inside the parenthesis, I'll give in the name of the column, which is nationality. Then I'll use the dot operator and use the value counts method. And when I run this, this is what I get. So you see that in this particular data frame, most of the players are from England. So you have 1,667 players from England. Then you have 1,216 players from Germany. And you have 1,035 players from Spain. Then you have 984 players from France. Then followed by 886 players in Argentina. So this basically tells you that in this data set, you have a lot of players from England, and that could also be a reason because you have more number of clubs participating in the English Premier League. So you also have all of these relegation zones. So you have tier 1 clubs, you have tier 2 clubs, you have tier 3 clubs. So maybe this data frame comprises of all of the players belonging to tier 1, tier 2, as well as tier 3. And that could tell you why, why there are more number of players belonging to England. Then, so let's say from this entire result, if I would only want to have a glance at the first 10 records, or the top 10 countries where most of the players belong to, what I'll do is I'll write down FIFA nationality dot value counts, and again I'll just give in 0 to 10 inside this, and when I hit on run, you would see that so most of the players belong to these 10 countries over here. Again, at the top you have England, Germany, and Spain. Then let's say instead of top 10, if I would only want to have a glance at the top 5, so over here I'll write down 0:5, and you would see that I have these 5 countries. I have England, Germany, Spain, France, and Argentina. Now I would want to make a bar plot for these top 5 countries where most of the players come from. So if I would want to make a bar plot, I would need to use this library called as Matplotlib, and we have seen that we have imported the submodule, which is PyPlot, and we have given it an alias of PLT. So here, first I need to set the figure size. So as you see, I'm setting the figure size over here, plt dot figure, and inside this fig size is a parameter inside this method, and using this parameter I set the dimensions of the image, and as you see I set the dimensions to be equal to 8,5. Now once I set the dimensions, then I go ahead and create the bar plot using plt dot bar. And when I write down plt dot bar, you have all of these different parameters over here. So when we are creating a bar plot, the first parameter which we give inside it should be the categorical values. Now, after that, what we do is we give in the numerical entries over here. So what we do is first, if we say categorical entries, these are the categorical values over here. Now, if I only use dot value counts method, that gives me these categorical values along with these numerical values. But what if I only want the categorical values, only the names of the countries? So in that case, what I can do is I can use the keys method. So here, as you see, Till here, the command is the same. FIFA nationality dot value count 0 to 5. Then I am using the dot keys method over here, and I will hit on run, and you would see that I am able to extract the names of these top 5 countries without the values. And since I need to pass in categories as my first parameter, this code is what I'm passing in as the first parameter over here. Then going ahead, the next value is the same command without the keys method. Then going ahead, I have another parameter called as color, and I set the color to be equal to green. So G is, again, it's just a short form for the green color. So I have first passed in the categorical entries, then I've passed in the numerical entries, then I have passed in the color over here. Then I hit on run. So here you see that this is the bar plot which we have created, and it's pretty evident, isn't it? This is what we saw in the list as well. So most of the players, they are from England. Then you have around 1200 odd players from Germany. Then you have 1000 odd players from Spain. Then you have France and Argentina falling behind. So right now we have looked at the nationality column. Now we will go ahead and do some more analysis. So we have the wage in euro column. And now I'll just show you if we can. So now as you see, like some of the columns wouldn't be listed over here because this is a huge data frame, but we have this column called as wage underscore euro. So this tells me the salary of these players in euros, and I'd want to see, I'd actually want to see over here which player gets, what is the salary of some of these players. So what I'd want to do is from the entire FIFA data frame, I'd want to extract only 2 columns. The first column would be the short name of the player, and the second column would be the wage in euro. And this I will go ahead and store in this object called as player salary. Now that I have created this sub data frame from my original data frame, then I would want to have a glance at the first 5 records of this. So here, player salary dot head, I will click on run. Here you see that in the first column, I have the short name of the player, and in the second column, I have the salary of the player. And here, as you see, Lionel Messi, his wage is, you have 65,000 euros. Then you have Ronaldo with 405,000 euros. Neymar is at 290,000 euros. Oblak is 125,000 euros. And Eden Hazard is at 470,000 euros. So I'm not sure if these are the latest salaries which these players get, but according to this particular data frame, it would seem that Eden Hazard and Lionel Messi actually get more salary than Cristiano Ronaldo. And now, what we will do is I'd want to see who is the highest paid football player. So from this data frame, from this sub data frame, what I'd want to do is I would want to sort this with respect to the wage column. So what I'll do is I'll write down player salary dot sort values, and inside this I have this parameter called as by. And what I'm doing is I'm just sorting this data frame with this column called as wage underscore euro, and I'll set ascending is equal to false because I would want that player with the highest salary at the top, and that is how it will proceed. And this again, I'm storing it back in the same object called as player salary, and I'll go ahead and hit on run. Now I will have a glance at the first few records of this. So when I say player salary dot head, so obviously as you see over here, Lionel Messi is the highest paid football player at 565,000 euros. Then you have Eden Hazard at 470,000 euros, Ronaldo at 405,000, Kevin De Bruyne at 370,000. You have Griezmann at 370,000 euros. So quite an interesting analysis, isn't it? So again, we will do the same thing. We will make a bar plot for these top 5 football players with the highest salaries. And since we have these categorical entries over here, we would have to make a bar plot. So you'd have to understand why we're using a bar plot. So normally whenever we do want to understand the distribution of a categorical entity, that is when we go ahead and make a bar plot. So here, what we are doing is first, the same thing, we will set the figure size. This time we are creating a bar plot for the players with highest salaries. Here, as you see, first I am setting the figure size. So I'll write down plt.figure. Inside this, I'm setting the figure size using this parameter called as fig size. And I given these dimensions. So the dimensions are 8, 5. 8, 5, 8 is the width, 5 is the height. So I've given the dimensions of the figure. Now, after I set the dimensions of the figure, I can just go ahead and create a bar plot. So to create a bar plot, I'd have to write down plt.bar. Inside this, so in a bar plot, always remember that the first parameter which you given has to be the categorical entries. The second parameter which you given has to be the numerical entries. So here, the first parameter, since it has to be capital, it has to be categorical. What I do is I would have to, so we have a categorical column, we have a numerical column. So obviously it is the names of the players which will be passing in over here. So this basically is your x-axis. So on the x-axis, we would need the names of the players. So I'll extract this particular column. So this short name column is from player salary data frame. So I'll write down player salary and I given the name of the column, which is short name. And obviously I'd want only the top 5 records. So I'll given 0 to 5 inside this. Then I will go ahead and in the next parameter, as you see, I have a wage in euro. So again, since it has to be numerical, this time I'm extracting the wage in euro column, and I'll go ahead and set the color over here. So color, as you see, is equal to red. Then I will go ahead and plot it out. I will hit on run. And as you see, this is the result which we get. So on the x-axis, we have the names of the players, and on the y-axis, we have the salaries. So Lionel Messi obviously is leading the chart. Then you have Eden Hazard, Cristiano Ronaldo, Kevin De Bruyne, and Annie Griezmann. Now let's say if I would want different colors for all of these different bars over here. So that is something which we can also do. Now let's say instead of just keeping this as red, if I would want different colors, so what I'll do is I'll pass in a list of colors over here. So for Lionel Messi, let's say I given blue color. Then for, let me just keep it small b. So for Lionel Messi, I'm keeping blue color. For Eden Hazard, I'll give green color. Then for Cristiano Ronaldo, maybe I'll give in red color. Then for Kevin De Bruyne, I'll give, let's make it pink. And finally for Griezmann, let's keep it, let's say orange. And let's hit run. Seems like we have an error over here. The spelling which I've given is incorrect. So let me just keep pink and I'll hit on run. And as you see, this is the result which we get. So we can change the colors which are there in all of these bars as well. And now what I'd want to do is I'd want to do a simple analysis for the players who belong to Germany. So what I'm doing is, so let's say if I, from this FIFA data frame, if I set the nationality is equal to Germany and I hit on run, I get a bunch of true and false values. So when you have these bunch of true and false values, what does this actually mean? So if you have a false over here, this means that that in that particular record, the nationality of the player is not equal to Germany. And if it is actually equal to true, then it would mean that the nationality of the player is Germany. So what I'd want to do is, from this list, I would want to extract all of those records where the value is actually true. So I will take this command and I will paste it again inside the FIFA data frame, and I will store it in this object called as Germany, and then I'll print it out. So I'll write down Germany.head, and if I would want to have a glance at the first 10 records of it, so Germany.head, inside parenthesis, I'll write down 10 and I will hit on run. And this is the result which we'll get over here. So as you see, this is the list of all of the players whose nationality is Germany. And now what I'd want to know is, I would want to see who is the tallest German player. So Germany.sort values, I will use by, and I would want to sort this with the height in centimeters column, and I will set ascending is equal to false. And I would only want to have a glance at the top 5 records. So I would want the top 5 tallest players of German nationality, and I'll hit on run over here. And as you see, so you have Aaron Seidel right now as the tallest player of German nationality. His height is 199 centimeters. Then you have Michael Esser, whose height is 198. You have Lars Unestal, whose height is 198 again. Then you have Dominic. Then you have Lucas. So these are the players with the, these are the tallest players. Then similarly, let's say if I would want to sort these German players according to their weight, I would want to see which player has the maximum weight. So again, this will be similar. I'd have to write down Germany.sort values, and I would have to sort it with respect to weight, and ascending, I'll set it to be false, and I'll hit on run. This time you would see that weight over here, so it's Lucas Woltowiak, who has the highest weight of 103 kgs. Then again you have Lars Unestal, whose weight is 103 kg. Then you have Ralph Farman. Then again you have Michael Esser, and you have Nicholas Sule. And then I would want to see who is the highest paid German player. So this time I have the wage in euro column, and I am sorting it with respect to the wage in euro. Ascending is equal to false, and .head method. Now if I show you these players, let's see what are these names. So Tony Cruz is the highest paid German player, and he plays for Real Madrid. So obviously if you're playing for Madrid or Barcelona, you would be paid a lot. Then you have Marc-Andre Stegen, and he plays for Barcelona, so he's the second highest player. And then you have Leroy Sané, who plays for Manchester City. Then you have LK, who plays for Manchester City as well. Then you have Thomas Müller, who plays for Bayern Munich. So top 5 players of German nationality who have the maximum wages. Now, again, what I want to do is I just want to make a simple data frame again. So I just want what I want is I would want 2 columns. The first column should have the name of the player, the short name of the player. The second column needs to have the wage in euros, and I would want to sort this with their salaries. So Germany, from this data frame, I'm selecting only short name and wage, and then I'm sorting this data frame by their salaries, and obviously I'm sorting this in descending order, and I would want to have a glance at the top 5 records. Now if I click on run, you would see that this is what I get. So obviously it is Tony Cruz, who has whose salary is 330,000 euros. Then Stegen has 250,000. Then you have Sani at 195. And at fifth place, you have Mueller at 170,000 euros. Now, after this, what I want to do is from the original data frame, I would want to see who has the best rating for his shooting skills. So what I'll do is from the FIFA data frame, I'll extract only two columns. The first column is shot name. The second column is shooting. And I'll extract these two and I'll store them in this object called as player shooting. I'll hit on run and I'll go ahead and sort it again. Now, when I hit on run, you would see that Cristiano Ronaldo has the highest rating for his shooting skills. So he's got a rating of 93. Then you have Lionel Messi, then you have Harry Kane, then you have Sergio Aguero, and you have Quagliarella. So these are the top 5 players with highest shooting skills. Now, similarly, I'd want to see which player has the maximum defending skills. So player defending. So this time from the original FIFA data frame, I'll be extracting the shot name, the defending column, which would tell me his defending skills, the rating for his defending skills. I have his nationality and I also have the club for which this person plays for. Player defending. And now I would want to sort this by his defending skills. So obviously player defending dot sort values by is equal to defending, and this has to be in descending order. Then I'll hit on run. So you see that you have Chiellini, who plays for Juventus, and he's from Italy. He's got the maximum defending skills. Then you have Van Dijk. Van Dijk plays for Liverpool and his nationality is Netherlands. Then you have Koulibaly, then you have Gordon, and you have Hummels over here. So Hummels plays for Dortmund. And then finally, what I'd want to do is I'd want to analyze the list of players who play for Real Madrid. So Madrid is one of the topmost football clubs across the world, and I'd want to see what makes this club so special. I'd want to analyze the some of the features of different players over there, and that would be the final analysis for today. So what we'll do is from the original data frame, which is FIFA, I will set the club value to be equal to Real Madrid. So from the original data frame, we are extracting only those records where the value is equal to Real Madrid, and that I'll go ahead and store in this object called as Real Madrid again. Now I would want to see who is the highest paid player in Real Madrid. So Real Madrid dot sort values, and I would want to sort it with respect to the wage in euro column. And when I hit on run, you would see that Eden Hazard is the highest paid player in Real Madrid currently. Then you have Luka Modric. So Luka Modric is the second highest paid. Then you have Toni Kroos, Sergio Ramos, and Karim Benzema. So Eden Hazard plays for Belgium, Luka Modric plays for Croatia, Toni Kroos plays for Germany, Sergio Ramos plays for Spain, and Benzema plays for France. And now we have looked at who are the highest paid players in Real Madrid. Now let's also see who has the best shooting skills in Real Madrid currently. So Real Madrid dot sort values, and I would have to sort it with respect to the shooting column. Ascending is equal to false because again I'd have to sort it in a descending order. And as you see, Gareth Bale has the best shooting skills currently in Real Madrid. Then you have Jimmy Rodriguez, who is the second best shooter, followed by Eden Hazard. Then you have Karim Benzema. Then you have Luka Jovic. Finally, I'd want to see who are the best defenders in Real Madrid. So Real Madrid dot sort values by is equal to defending, and I'll hit on run. And here, as you see, so it seems that Sergio Ramos is the best defender in Real Madrid currently. then you have Casemiro, after that you have Varane, then you have Carvajal, and finally you have Militao. So these are the top 5 defenders currently who are playing for Real Madrid. So as I've told you, we'll be working with these 2 libraries. We will not actually require SeaBorn. So SeaBorn is also another visualization library, which we will not require today. So I'll just delete it from this command. So we would need Pandas. The alias for Pandas is PD. We would need PyPlot, which is a submodule in Matplotlib. And I'm giving this an alias of PLT. Again, let's just wait for these libraries to load. So that is done. What I'll do is I'll actually remove the results from over here so that it will be much more interactive so that you actually know what is happening over here. Now, let me start off by running this again. And now, if you'd have to load any CSV file, so CSV file is something which has the extension of .csv, and these are normally your Excel files. So if you have a CSV file, this is how you load it. So you write down pd.read_csv, and read_csv is a method in the Pandas library. And we have a CSV file called as character stats, which has all of the statistics of all of your Marvel superheroes and DC superheroes. And this I go ahead and store in this object called as Marvel. Now, I'll go ahead and have a glance at the first few records of this Marvel data frame. So I need to write down marvel.head, and by default, this head method gives you first 5 records which are present. Now you see this is our Marvel data frame, and this comprises of all of these columns. So you have the name of the superhero over here. So you have 3D Man, A-Bomb, Ape Sapien, Abencer, Abomination. Then you have the alignment, whether the superhero is good or so. Basically, we are saying if he's a superhero or a supervillain. So that is what the alignment tells you, whether he's good, bad. You also have another category called as neutral. So I guess there are very few neutral characters which are there in this particular data frame. Then you have the intelligence over here. So as you see, 3D Man has an intelligence of 50, A-Bomb has an intelligence of 38, Abencer, Abomination. So all of these superheroes are alphabetically listed. Then you have the strength of these superheroes. Similarly, you have the speed, durability, power, combat, and total. So these are some columns which are present over here. Now, then we will go ahead and see how many records and how many columns are actually present over here. So for that, we have the shape method. So we will write down marvel.shape, and I hit on run. And you would see that this has 611 records and 9 columns. So this 611 records tells you that there are 611 superheroes or supervillains present in this particular data frame. Now, going ahead, I want to see how many of these characters listed in this data frame. So how many of them are good, how many of them are bad, and how many of them are neutral. So that information will be coming from this column called as alignment. So that is what this alignment column tells us. And this is a categorical column. So all of the other columns are numerical. So as you see, numerical columns would basically mean you have numbers. Categorical column, as the name states, you have categories over here. So if you have to do some sort of analysis on the categorical column, if you'd have to check the frequency of the categories, then we have a method called as value counts. And as you see over here, so first I given the name of the data frame, which is Marvel. Then, so we have this parenthesis. Inside the parenthesis, I given the name of the column, which is alignment. Then I use the value counts method and I hit on run. And you would see that, so out of the 611 characters which are present, 432 of them are good, so we'll consider them to be superheroes. 165 of them are bad, so we'll consider them to be villains, and 11 of them are neutral. So this is some interesting information which we have out of this. And this is a data frame which comprises of both your Marvel superheroes as well as your DC superheroes. So now that we have had a look at the different categories which are present over here, what I'd want to do is I would want to extract all of these good characters from this entire data frame. So out of these 611 characters, I'd want to extract all of the good characters. So let me explain this command properly to you folks. So what I'm doing over here is, so first, when I given the name of the data frame, inside this, I given the column name. So let me write down alignment over here. And when I set the alignment to be equal to good, what this actually does is this gives me a bunch of true and false values. So wherever the value is true, this would mean that the record over there is equal to good. Wherever we have a false, this would mean that the record over there is bad. So here, as you see, so you have 0, 1, 2, 3, 4. You have these index values over here. And if we go up, so we had true, 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 and false. You had trues for all of these because you have good over here. You have a false for this because you have a bad over here. So this is how we give the condition. Now, out of these true and false values, I would want to extract only those records where the value is true. So what I'll write down is, I'll give in Marvel over here. I'll cut this out and I will paste it inside the Marvel data frame. Now when I hit on run, and if you look at this particular data frame over here, so you would see that I have only extracted the superheroes out of the entire data frame. So this is something interesting which we've done. Now, so again, good.head over here will give me only, so what I'm doing is the same command over here, I'm storing it in a new object called as good. Then I go ahead and have a glance at the first 5 records. So again, here you'd have to understand that this is alphabetical. So when we say alphabetical, again, if you have any superhero who has a number, who has his name starting with a number, so that's why you have 3D man at the top. Now, I'd want to see which of these superheroes has the maximum speed. So, speed over here is a numerical column. And if I'd have to sort my data frame with respect to a numerical column, I have this method called as sort values. So I will write down good.sort values, and I would want to sort this data frame with the help of the speed column. And I will set ascending is equal to false because I'd want this data frame such that that particular superhero whose speed is the maximum, his record is at the top place and it goes in a descending order. And I'd want to have, so let's actually remove head over here. Let's have a look at the complete list of this data set. So here, as you see, Flash 3. So Flash obviously has the maximum speed. Then you have Jack of Hearts with a speed of 100. You have Impulse with a speed of 100. You have Stardust with a speed of 100. You have Quicksilver with a speed of 100. So it seems like there are a lot of superheroes who have a speed of 100. Let's actually see how many of these superheroes have exactly a speed of 100. So what I'll do is I'll again insert a cell above this. Now from this data frame, from the sub data frame good, I have this speed column and I want the speed to be equal to 100. And this I will store in an object called as max speed good. I'll actually have to, again store this in a data frame. So let me cut this out over here, paste it over here. Now I will go ahead and insert a cell above this and I'll have max speed good. So it seems like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So it seems like we have 12 superheroes who have a speed of 100. So this is quite interesting over here, isn't it? So if you, so again, this is, you'd have to keep in mind that this is with respect to alphabetical. So you have Black Bolt, Flash 1, 2, 3, and 4. So again, so you have different versions of Flash over here on the basis of the comic books. So you have, again, Flash is obviously the fastest superhero. His speed is 100. Then you have Crypto, Nova, Quicksilver, Stardust, and obviously Superman. So Superman can fly. So obviously we are assuming that if Flash is the fastest person on land, then Superman must be the fastest person in air. So that could be a reason why Flash and Superman have the same speed level over here. So this is quite an interesting analysis. Now, let's say if I'd want to find out all of those superheroes whose speed is the lowest. So you have, as you see over here, there are a lot of superheroes whose speed is only 1. So what I'll do is I'll change this to equal to 1, and I will change this to min speed. So min speed good. So here, wherever the speed value in this good data frame is equal to 1, I'll be extracting all of those records and I'll store that in min speed good. Then again, I will have min speed good over here. So here, as you see, all of these superheroes do not really seem to be, that strong. So all of these values are quite low over here. Their intelligence, strength, speed, durability, and power, they are extremely low. So White Queen, Whiskit, Wandra, so all of these, I'm pretty sure that you wouldn't even have heard of all of these superheroes. So these must be just random characters in the Marvel DC universe who have extremely low stats with respect to this. So similarly, what I'd want to do is I'd want to see who is the most powerful superhero. So we have a tab called as power. So again, good.sort values. So I'll delete min speed good, and over here I'll also delete this. So now from this data frame good, I'd want to this time. So initially we had sorted this with respect to speed. Now I'd want to sort this with respect to power. So as you see, good.sort value, still here it's the same. It says that when it comes to buy, I am sorting this data frame with the help of this power column, and I'll set ascending is equal to false because I don't want the superhero who has the maximum power to be at the top. So again, let's actually have a glance at only the first 5 records. So here, as you see, we've got these records over here. So you have Zatanna, Thor, Beyonder, Beta Ray Bill, who have a power of 100. So that's quite interesting. And I'm personally a big fan of Thor. So if you've seen Avengers Endgame, then you have fat Thor in Avengers Endgame. So even though he was fat, he was extremely strong. So I personally love Thor's character in Marvel's Endgame. What do you guys think about that? So now, similarly, what I'd want to do is I'd want to extract all of those superheroes who have a power of 100. So here, good. Again, I need to give in the name of the column, which is power, and I will set the power value to be equal to 100. Then again, I'd have to extract this. So again, this will become good. I'll cut this out. I'll paste this in the good data frame, and I will store in, let's say, I'd have to store this in good. Let's just say actually good max powerful. I'm just giving random name over here. I'll insert another cell over here. So let me just good max powerful. And when I hit on run, so seems like we have a lot of superheroes. So as you see over here, we have a lot of superheroes. Let's actually get the count of this. So again, I'll insert a cell about this over here. Let me see the shape of this. So Control C, Control V dot shape. And when I hit on run, So you would see we have 33 superheroes who have a power of 100, and that is amazing, isn't it? So you have all of these superheroes, and this is right now listed in alphabetical order. So let's see how many of these superheroes, are actually famous, are actually there in the Marvel or DC universe, or quite famous. You've got Doctor Strange over here, who obviously is extremely powerful. And then, seems like we also have Goku. So if some of you watch anime, so seems like, I don't know if Goku comes under why Goku has been listed over here, but seems like we also have Goku over here. Then obviously we have Iron Man with a power of 100. Then we have Martian Manhunter, we have Marvel Girl, we have Nova, Silver Surfer. Something interesting over here. So if you see, we do not have Superman. So this is quite interesting, isn't it? So let's actually go up and see what is Superman's power. So this is something we had done above. Where was that? Sort values, speed. Okay, seems like we've lost that. So anyhow, so as we were looking over here, so seems like Superman does not have a power of 100. So that is something interesting to find out over here. So we have done analysis till till the power of all of these superheroes. Now what I want to do is, so till now what we've done is data manipulation. Let's actually do a bit of data visualization. So when it comes to data visualization, again, we will be needing Matplotlib, and Matplotlib again has a submodule called as PyPlot, for which we have given this alias of PLT. Now I will insert a cell above this, and what I'd want is, I would want to make a simple bar plot for the top 5 superheroes with maximum power. So here we have this particular over here, max power. I'll actually get this again. So here we have this particular record. So as you see, we have the top 5 superheroes with maximum power. Now, what I'd want to do is, if I'd want to make a bar plot of this list, so not actually power. So you have see this total column over here. So I'd want to look at the top 5 list of those who have the maximum total value, right? So here, as you see, Martian Manhunter seems to be best when it compares to everything, right? So Martian Manhunter, only when it comes to speed and combat, it is less than 100. For in all other aspects, he's got an absolute 100 over here. And we were talking about Superman. So Superman, it seems that he does not have a power of 100. He only has a power of 94. So this is quite interesting. So seems like Thor is much more powerful than Superman, which is quite an interesting take, isn't it? Then you have Stardust, Thor, and Supergirl over here, and these are the total values. Now, so these total values basically indicate the most powerful superheroes in the DC. And when I say powerful, that would mean with respect to all aspects, with respect to intelligence, strength, speed, total power, and combat. So obviously, if you add all of these, this is what you will get over here. So now what I'm doing is, I'd want to have a look or make a simple bar plot for all of these top 5 superheroes across DC and Marvel franchises. And to make a bar plot, first we would need to set the dimensions, and I am using plt.figure, and inside this I have a parameter called as fig size, and I set the figure size to be equal to 8,5. So these are just the dimensions of the image which I'd want to create. Going ahead, if I'd want to create a bar plot, I would have to use plt.bar, and in plt.bar you have these 3 different parameters over here. The first parameter which I give, normally when you're creating a bar plot, the first parameter needs to be a categorical entry, and that is what we are doing over here. So you have good max power. So this is from good max power. First, on the x-axis, I would want to list out the names of the superheroes, and on the y-axis, I would want to list out the total values. So first, I will extract all of the names over here. So as you see, good max power name. So obviously 0 to 5 because I only want the top 5 superheroes with the most total value. This is what I'm giving as the first parameter. Then in the second parameter, I will take in the total value. So this time from the good max power data frame, I am extracting the total column. Again, 0 to 5 because I do want the top 5 columns. And I'll give a color to this bar plot, which is basically green. So if I give in color is equal to G, that would basically mean that the bar plot which I've created is of green color. Then plt.show, and this is the result which you get. So as you see, these bars are, there's not much of a difference, but these are slightly decreasing. So Martian Manhunter, Superman, Stardust, Thor, and Supergirl. So this is a bit of visualization which we have done. And we have done this basic analysis for all of the superheroes. Now let's actually do the same sort of analysis for villains as well. So this time from our original data frame, which was Marvel, I am extracting all of the records where alignment is bad. So as you see over here, Marvel alignment is equal to bad, and I'm storing this in this object called as bad, and I click on run over here. Then I have a look at the top 5 records. So you have all of these villains over here, or supervillains: Ammo, Amazo, Airwalker, Abraxas, Abomination. Now I'd want to see who has the maximum speed among these supervillains. So again, it will be bad.sort values. And this time by it will be speed ascending is equal to false. So similar stuff what we've done. And as you see over here, so you see that a lot of these supervillains also have a speed of 100. So you have Zoom, Airwalker, you have Amazo, you also have General Zod over here. So then you have Superboy Prime. So all of these supervillains have a speed of 100, which is quite interesting. Then similarly, I want to see who is the most intelligent among these supervillains. So this time I will sort it by intelligence. I'll click run. And as you see over here, you have Mr. I'm not sure how do you spell this, but this, so Mr. MXYZPTLK seems to have an intelligence of 113, which is amazing. Then you have Lex Luthor, the villain in the Superman series. Then you have Leader, you have Brainiac, and then you have Doctor Doom with an intelligence of 100. So this is something interesting over here. Then I'd want to see who is the most, who is the most badass of all of these supervillains. So again, I would want to look at the total column over here. So bad.sort values, by is equal to total, and ascending is equal to false. So it seems that Superboy Prime seems to be the most powerful among all of these supervillains. Then you have General Zod, then you have Amazo, then you have Dormammu. Dormammu again was the villain in Doctor Strange comic series. So if you've seen the movie Doctor Strange, then you would know about Dormammu from that movie. So it was also amazing how in the end, Doctor Strange was able to put Dormammu in a time hole. So if you've seen Doctor Strange, you will find that quite interesting. So you will see that, how Doctor Strange, who is equally intelligent as Dormammu, who is able to outwit Dormammu over here. Then going ahead, what I'd want to do is, similarly, I would want to make a bar plot out of this. So I would want to make a bar plot for these top 5 supervillains over here. So again, plt.figure, fig size, dimensions 8,5. So if you want me to change this, I will maybe change this to, I don't know, let's keep it 10,5. I don't know, 10,5 seems fine. Plt.bar. So how to give different colors in the bar. So I'll show you how it's done. So plt.bar here, the first parameter will be the name of the supervillain over here. So that is why I'm giving the name column. Again, I would need only the top 5 records. Next is the total column. Then over here inside color, I'll give in a list of colors. Since I have 5 bars, so I have 5 superheroes for which, 5 supervillains for which I'd have to create this bar plot. So inside this parenthesis, I'll give in 5 colors. Let's say the first color is red. Next color I'll give in green. Then I'll give in blue. Then I'll go ahead and give in, let's say, orange. And then final color, let's say I'll give in pink over here. And I have plt.show. Why do we have an error over here? Bad max bar. Okay, let me also run this first. Now let me run this, and as you see, I have different colors for each of these different bars over here. So again, this will come sequentially. So the first bar has the red color, second bar has the green color, similarly followed by blue, orange, and pink. So this was about the supervillains. Now, what I'd want to do is I'd want to make a distribution of speed for all of the superheroes. So I'd want to see what is the range of the speed for all of the superheroes. So since speed is a numerical column, what I'm doing over here is, again, setting the dimensions over here, plt.figure, figure size is 5 and 7. Then I will go ahead and use plt.hist. So plt.hist, which I'll be using to make a histogram. And here you'd have to understand the difference between a histogram and a bar plot. A bar plot is used to visualize something with respect to categorical columns, and a histogram is used to visualize something with respect to numerical columns. And as you see over here, since we have names over here, since we have categories, that is why we've made a bar plot. Now, on the other hand, if I just want a distribution of speed, so speed is only a numerical column. That is why I'm making a histogram. So I'll write down plt.hist. So from all of the superheroes, I am only making a histogram for all the superheroes. Then I'll set the title for this as distribution of speed. I'll set the X label to be equal to speed, and then I'll just print it out. So this is something interesting over here. Let me increase the width. Let me make it 10 actually. That would be interesting. Let me decrease the height. 10,5 would be better, I believe. All right. So as you see over here, most of those superheroes, their speed would be somewhere between, so you have 140 superheroes whose speed would be somewhere between 0 to 10. And there are very, very few superheroes. There would be around 20 odd superheroes whose speed is between 90 and 100. You have 2 peaks over here. So there are 140 superheroes for a speed of 0 to 10. And there are around 85, or you can say somewhere between 85 superheroes whose speed is between 20 and 30. So this is how the speed of superheroes varies. Then similarly, if I'd want to have a look at the combat for all of these superheroes, again, I'd have to do the same thing. It'll be plt.figure. I'll set the figure size. I will make it 10,5 actually, because it'll be better to visualize. plt.hist. So now this is actually the combat for super villains, because I'm using bad over here. So let me change the comment over here. Let me change this to be equal to super villains, and title as distribution of combat, and here X label as combat. And here you see, again, there are also we have very few superheroes, very few supervillains in general. So out of those very few supervillains, there would be around maybe at max 10 supervillains whose combat value lies somewhere between 90 and 100. And there are around 40 supervillains whose combat is between 0 to 10. And again, you have a peak over here. So there are around 30 odd villains whose combat rating is between 50 and 60. What if I need only some selected columns as an output, not all columns? Sure, I will show how to do that. So let's say from the original data frame, which is Marvel. Now I'll write down Marvel. From the Marvel data frame, if I'd want only the name column and the total column, so this is how I'll do. First, I'll give in this column, the name of this column, then I'll give in the name of this column. Then maybe I'll store it in a new object and I'll call it as Marvel total. I'd have to give in 2 braces over here. Let me cut this out. Let me paste it inside this. Now, let me print out the head of this. So it will be Marvel total.head. And as you see over here, I have extracted only 2 columns from the entire data frame. So you just need to give in the name of the data frame, and inside the parenthesis, you need to give in 2 braces over here. And inside those 2 braces, you need to give in the columns that you'd want to extract. So this was all about the exploratory data analysis for the Marvel and DC superheroes. Now, let me quickly jump onto this. So we would require like these 2 libraries, which we have learned about. So we have learned about Pandas, we have learned about NumPy. Now I have quickly loaded these 2 libraries. Now I have this data frame called as battles. So this is a CSV file which comprises of different battles which have happened in the Game of Thrones series. So to load this file, I'll just write down pd.read_csv. So this read_csv method helps us to load a CSV file. So this is how I'm loading this file, and I am storing it in this object called as battle. I have successfully stored it. Now I'll have a glance at the first 5 records which are present in this battles data frame. So we have our, this is the first of 2 data sets of the Game of Thrones. So here in this data frame, we have all of these columns over here. So this name which you see is the name of the battle. So we have around maybe 40 odd different battles which have occurred through the 7 books. So you have Battle of the Golden Tooth, you have Battle at the Mama's Ford, you have Battle of River Run, you have Battle of the Green Folk, and so on. This column tells us in which year the battle occurred in. So Game of Thrones was mostly based throughout the 298, 299 and 300 AC years. Then you have the this column which would tell you who is the attacker king. So here for this battle, which is Battle of Golden Tooth, the attacker king was Joffrey and Tommen Baratheon, and the defender king was Robb Stark. So here attacker 1 basically tells you who is the primary attacker. So primary attackers are Lannisters over here. I mean, we already know that the Lannisters have started most of these wars, so this is not really, not really new information. Then we have this major death column. This major death column tells us if any major death has occurred in this war. So let's say if someone such as maybe Jaime Lannister has died or Robb Stark has died. So if there's any major death involved in this battle, then we'll have the value 1. On the other hand, if there's no major death, then we'll have 0. Similarly, we have this major capture column. So if the value is 0, it would mean no major captures have occurred in this battle. Similarly, if we have the value 1, that would mean some major captures, someone really powerful has been captured. Then we have attacker size over here. Attacker size would tell you the number of people who have fought on the attacker side. Then you have who's the commander who was leading the army of the attacking side. Similarly, you have this column which would tell you who is the commander who is leading the defender side. Then you have the different regions in which all of these battles occurred. So let's say if we take this particular battle, which is Battle of the Golden Tooth. So this battle has occurred in Westerlands. So this is some basic information about our data frame. So before we do EDA, it's actually important to understand what is the data about. Now, if I want to know the number of rows and number of columns which are present in this data frame, I'll just have battle.shape. And you would see that we have this value 3825, which would basically mean there are 38 records present in this data frame and 25 columns present in this data frame. Now, Some of these columns are not very intuitive. So let's say I have attacker 1 over here. Now instead of attacker 1, I'd want this to be more intuitive. So I'd want to rename this column from attacker 1 to primary attacker. So for that purpose, I have this method called as rename. I'll use this rename method. I'm using this rename method on top of this battle object, and inside this I have this parameter called as columns, which would help me to rename this column. So for this columns, I'll pass in a dictionary. Key would be the column which I'd want to rename. Value is to which particular value would I want to rename this column. So I am renaming this column attacker 1 to primary attacker. And when I set in place is equal to true, this would mean that the change directly happens in the data frame itself. Now, once I make that change, I'll just go ahead and have a glance at the change data frame. So you would see that initially the name of the column over here was attacker 1, but after using this particular method, we have changed the name of the column from attacker 1 to primary attacker. Similarly, we have the defender 1 column over here. Defender 1 means who is the primary defender. So here I'll use the same method, which is battle.rename. So rename is the method, and I'm using this method on top of the battle object, and I'll have this parameter columns, and you would see that I'm passing in this key value pair. Key is this particular column, value is to which value I'd want to change this name to. So I am renaming defender 1 to primary defender, and when I set in place is equal to true, the changes automatically are saved in this data frame. Then I'll have a glance at this modified data frame. So you would see that I have changed the name over here. So this was some basic pre-processing for this data frame. Now, if I'd want to know how many times a king has attacked, so I have this attacker king column. So let's say if I'd want to know the number of times Robb Stark has attacked someone, the number of times Joffrey and Tommen Baratheon have attacked someone, then I can use the value counts method, which would give me the frequency of a categorical column. So this is a categorical column, as you see. So all I'll do is I'll have battle, and inside this I'll give in the name of the column, which is attacker king. And when I use the value counts method on top of this column, this will give me the frequency of values. So here it would seem that Joffrey and Tommen Baratheon have attacked 14 times. So it seems like Joffrey and Tommen are mostly the starters of all of these wars which have happened in Game of Thrones. And over here when we see Stannis Baratheon, so Stannis Baratheon has only attacked 5 times. Then similarly we have Robb Stark over here. So Robb Stark has started an attack 10 times. Then we have the Greyjoys. So the Greyjoys have started the attack 7 times. So this is a simple information which you can find out about attacker king. And if I'd want to know how many battles have occurred in different locations, so we have the location column. Now, let's say if I'd want to know how many battles have occurred at Golden Tooth, how many battles have occurred at River Run, then I'll just use value counts again for this particular column. And you would see that Winterfell and River Run have the most number of battles. So at Winterfell, 3 battles have occurred. Similarly, at River Run, 3 battles have occurred. But from over here to here, you would see that only 1 battle has occurred at these different locations. And we have Storm's End over here. Storm's End again has only 2 battles which have occurred. So that was understanding about those categorical columns. Now that is done, what we'll do is we'll do some basic visualization to understand this data frame better. So to do visualization, we have already imported the SeaBorn and Matplotlib earlier. So these are the 2 important libraries for visualization. I'll go ahead and load these 2 up. Now that these 2 are loaded, I'd want to understand, how many, so over here we had looked at the frequency of attacker king. So now I'd want to know I'd want to know so here what I'm doing is, let's say if a king has attacked, then I'd want to know what is the size of his army. So that is why I'll have attacker king mapped onto the x-axis, attacker size mapped onto the y-axis, and I am creating this bar plot on top of the battle data frame, obviously. So here this SNS.set, I'm just setting the figure size over here because there are a lot of things which are present in this visualization. So here we have 4 attackers. We have Joffrey and Tommen Baratheon, then we've got Robb Stark, then we've got the Greyjoys, and then we've got Stannis Baratheon. So here, it seems that whenever Stannis Baratheon attacks, he has a huge army size. So if you look at Stannis Baratheon's army size to other Baratheons, or to even Robb Stark, or to even Greyjoy, so if we look at this, so Stannis Baratheon, he would have a size of around 30,000 in general. Similarly, if we look at Greyjoys would have the army, the size of their army would be somewhere maybe close to around 1,000 or 2,000, not more than that. Similarly, Joffrey and Tommen Baratheon, their army size would be around close to 10,000. So this is an interesting observation. So, it seems that Stannis Baratheon had a huge army along with him when compared to other attackers. Now, similarly, if I'd want to know the army size of the defender, so this time, what I'm doing is I am mapping the defender king onto the x-axis, and I'm mapping the defender size onto the y-axis. Now, when I run this, so these are all of the defenders. So this time we see that whenever, so out of all of these kings, whenever Renly Baratheon was attacked, he had the maximum army size. So maybe in some battle, Renly Baratheon would have been attacked, and in that particular battle, he had an army size of 20,000. Then followed by Joffrey and Tommen Baratheon over here. So it seems that whenever Joffrey and Tommen Baratheon are attacked, their army size is around 8,000 to 9,000. Then we've got Stannis Baratheon. Now compare this to this over here. So whenever Stannis Baratheon is attacking, it seems that he'll have a larger army. But on the contrary, whenever it's Stannis Baratheon who is being attacked, in that particular point, it seems that he'll have a very small army. So this is very interesting, isn't it? So that was about attacker size, and defender size. And now if I want to know what are the different battle types that these attackers have engaged in. So this time I'll be using this method called as count plot, and I am mapping the attacker king column onto the x-axis, and hue. Hue basically determines the color of these bars. So the color of these bars is being determined by the battle type. Now when I hit on run, so you would see that again we have the same attackers who are Joffrey, Tommen Baratheon, Robb Stark. So we've got the Greyjoys, then we've got only Stannis Baratheon. So it would seem that when it comes to Joffrey and Tommen Baratheon, they mostly engage in a pitched battle, and it's they have ambushed someone very few times, right? So Joffrey and Tommen Baratheon, they have been in a pitched battle 6 times, but they have only ambushed someone 3 times. But when you talk about Robb Stark, so it seems that Robb Stark mostly ambushes his enemies, or ambushes against someone else. So Robb Stark has ambushed the opponent 5 times. And then you have the Greyjoys. So it seems that it's only the Greyjoys who have engaged in this raising type of battle. Then you have Stannis Baratheon. So here, if you look at this, you have no orange color bar, which would mean that Stannis Baratheon has never ambushed anyone. So either Stannis Baratheon was part of a pitched battle, or he was part of a siege battle. So quite interesting observations over here. Now there is another data set. So till now we were looking at the battles data set. Now we have another data set called as character deaths, which would tell me about the different deaths which have occurred over here. So I have this character.csv file. I am storing it in this new object called as death. And then I'll have a glance at the first few records. So these are the names of all of the characters who have died in the series. So, and this is in alphabetical order over here. So you have Adam Marbrand, who was, whose allegiance is Lannister. You've got Adric Humble, who belongs to the Greyjoy clan. Then you have the death year over here. So death year, obviously, it has occurred either at the year 298, 299, or 300. Then you have the Book of Death. So in which book has this character died? So when you have 3.0, this would mean that this character has died in the third book. When you have 5.0, this would mean that this character has died in the fifth book. Then you have the death chapter, which would mean, so in the fifth book, Adric Humble has died in the 20th chapter. Similarly, Egon Frey has died in the third book in the 51st chapter. So interesting observation again. Then you have the gender over here. So if the gender value is 1, that would mean this guy is male. And if the gender value is 0, that would mean this character is female. And then you have nobility, which would tell you if this person is is actually noble or not. Then you got then you basically have all of these names of different books over here. So this is the first book, this is the second book, and so on, which will tell you if this person has appeared in this particular book or not. So that is pretty much it about this. Now what we'll do is we will look at the shape of this. So we have 9, 17 and 13, which would mean that there are 917 records which are present in this data frame and 13 columns present. So overall, we have 1917 deaths. Now, if I want to do a gender comparison with respect to the number of deaths over here, so I will just pass in this gender column and I'll use the value counts method. And here you would see that out of these 917 characters who have died, 760 of them are male characters. So 760 male characters have died, and it's only 157 female characters who have died. Similarly, if I want to know how many people who have died belong to nobility and how many of them do not belong to nobility. So this is sort of even. So out of all of the people who have died, 487 are not nobility, and 430 of them do belong to nobility. Then similarly, what I'm going to do is, so this was with respect to the character categorical columns. Now, if I want to understand about the death year, which basically means in which year, how many number of deaths have occurred, I'll use count plot over here, and inside count plot, I am passing in the death year column. So you have this death year. This is the column which I'm passing over here. And when I hit on run, you would see that. So you have all of these years. So these books basically depict this particular decade or this particular time zone from 297 AC to 300 AC. So it would seem that most number of deaths have occurred in the year 100 and in the year 299. So you have close to 160 deaths. So that's huge, isn't it? So you have close to 160 deaths which have occurred in the year 299 AC. Similarly, in the year 300 AC, you have around 100 deaths occurring. Then in the year 298 AC, you have around 42 deaths occurring. So it seemed that there was a lot of peace in year 297. There were maybe a lot of battles did not occur in that year, or maybe people were just more, more peaceful. So maybe you would have around only 5 to 6 deaths occurring in this year. So interesting plot again over here. So after this, now I'd want to know, out of these characters who have died, to which allegiance do these people belong to? Allegiance is basically to which clan have they, do they fight from? So again, for this, I'm using a count plot. Let me zoom this for you guys so that the text over here is clear. This is too much of zoom, so let me reduce this a bit. So if we look at this, so this is none. So you basically, so basically these are people who have died, but the allegiance is not stated. So it would seem that most of the deaths belong to the Night's Watch. So you have around maybe 110 or 115 deaths from the Night's Watch side. Then you have some allegiance over here who have around close to 100 deaths. Then you have the Greyjoys. So the Greyjoys seem to have around 50 deaths. Then we have the let's say House of Stark. The House of Stark has around maybe 30 odd deaths over here. But if you compare the other houses, so let's say if you talk about House of Baratheon, seems like very few people have died from the House of Baratheon. And similarly, if you look at the House Tyrell or maybe even House Martell, very few deaths have occurred from their side. All of this is the exploratory data analysis which I have done with respect to the different columns which are present in this data frame. When it came to confirmed cases, Tamil Nadu was at the second place. But when it comes to deaths, you see that Delhi is at the second place. So this again is an interesting analogy over here. And also if you look at this, Uttar Pradesh was nowhere. So Uttar Pradesh, when it came to confirmed cases, it was not present in the top 5 states. But when you talk about the number of deaths, it seems that Uttar Pradesh is at the 5th place. So this is again interesting. So you see that even though the number of cases is not, the number of cases in UP are not as much as the other 4 states, but it seems that there are more number of deaths in UP when compared to other states with those number of cases. So you can call it per capita death of the number of cases. So that seems to be high in UP. So interesting analogy over here. And now that was the number of confirmed cases, number of death cases. Now we'll do a similar sort of visualization for all of those cases which have been cured. So on top of the today dataset, again I'll be using sort values method, and I'll be sorting the dataset with the cured column. I'll set ascending is equal to false. Let me see this. So here, as you see, the number of deaths are maximum in Maharashtra, the number of cured cases are maximum in Maharashtra, and also the number of confirmed cases are maximum in Maharashtra. Again, quite interesting. So then we've got Tamil Nadu, Delhi, Gujarat, which were also there in the top 4. So the top 4 don't really change. Maharashtra, Tamil Nadu, Delhi and Gujarat are always there. Then we've got Telangana over here suddenly. So it seems that even though the number of deaths and number of confirmed cases are not so much, but the number of cured cases are a lot. So it seems that maybe the Telangana government is doing something better than maybe these 4 states over here to maybe cure all of those patients who've been contracted with the COVID-19 disease. So once we have this, I will extract the top 5 rows again. So max cured cases, I'll have 0 to 5. I'll store this in top states cured. And again, I'll use SNS dot bar plot, and I'll be making a bar plot where state is mapped onto the x-axis and cured column is mapped onto the y-axis, and the data which I'm using is top states cured. And again, the color of the bars is being determined by the state column. As you see, Maharashtra at pole position again with number of cured cases, closely followed by Tamil Nadu and Delhi. This time you see the number of cured cases in Tamil Nadu and Delhi. They are almost similar. Then you have Gujarat over here. Again, there is a very stark contrast. So in Delhi, the number of cured cases are almost equal to 1 lakh over here. But in Gujarat, the number of cured cases are 30,000. So this falls down. The number of cured cases falls down very steeply over here. Then you got Telangana, which was not there in the first 2 graphs. You got a new entrant over here. Now, we'll go ahead with the rest of the part which we'd have to do. So now that we've analyzed all of this, let me go ahead and just analyze some statistics with respect to the state of Maharashtra. So this time from the entire data frame, I am selecting only those records where the state is equal to Maharashtra. So df.state is equal to Maharashtra, and I'm storing this in an object called as Maha. Now let me print this out. So as you see, starting from 9th of March. So starting from 9th of March till 17th of July, these are all of the entries which we've got with respect to Maharashtra. So as you see, on 9th of March, there were only 2 confirmed cases in Maharashtra. But as of 17th of July, Maharashtra is the state which has maximum number of confirmed cases. So the cases have exploded. They are exploding exponentially in Maharashtra. So initially, if you looked at the earlier data set, you would have seen that the first case was found out in Kerala. In Kerala, the first case was found out in maybe 30th of January. So you have almost 2 months over here. So between those 2 months, Maharashtra did not have a case. Their cases started in March. But from March to July, the cases have peaked. But Kerala has managed to stop those cases. So when you compare Maharashtra with Kerala, it somehow happens that Kerala has managed to, if not flatten or maybe at least dumb down the curve a bit. So interesting observation over here to note. Now we looked at this. So what we're going to do is we are going to make a line plot. So earlier we had made bar plots. Now we are going to make a line plot. So I'll use the sns.lineplot method over here. I will map the confirmed column onto the y-axis and the date column onto the x-axis, which means that I'd want to know the number of confirmed cases with respect to dates. And the data which I'm using is this Maharashtra dataset which I've just created, and the color of this line would be equal to green. So this attribute which you see, color is equal to G. So I'm setting the color to be equal to green, and I'll just use plt.show to plot the line. And this is what we get. So the date, as you see, this starts over here. This is 22nd of March, and this is 22nd of July. So from 22nd of March till maybe if you take this particular date, 1st of June, or maybe we can even take 22nd of June, right? So if we take this, so from 22nd of March till 1st of June, the number of cases are, they're not increasing exponentially, but from this point of time, you see that there is an exponential increase. This part which you see over here. So it seems that from maybe the date between this. So let's say this is around, maybe call it 10th of June. So somewhere around 10th of June, the cases started exploding in Maharashtra. So something might have happened around 10th of June in Maharashtra, which has led to this. So this is about the number of confirmed cases with respect to date. Now we'll do a similar analysis where we'll try to find the number of deaths in Maharashtra with respect to date. So this time I am making a line plot over here. Let me just zoom this again. And this time a line plot where we have date on the x-axis and deaths on the y-axis. Let me run this. And the color of the line is R, which is red. So here, as you see, till this is, we've got 22nd of March till you've got 1st of June over here. And this is 22nd of June. So maybe you can call it somewhere around 17th of June. So here, this is sort of a curve shape, a bell curve, but here what you see is this is just a straight line over here. So something might have happened around 17th of June, which has led to a lot of deaths. So as you see, somewhere around 17th to 18th. So maybe the 16th, 17th, 18th June in Maharashtra, this had a lot of deaths over here. Also, if you see from maybe 17th of June till here, the deaths again, so this line, so this what you see, the slope is not so steep. Here it's just a straight line. So you've got a lot of deaths. So from this would be around 4,500. So from 4,500 to around maybe 5,500, that's almost 1,000 deaths in just a span of 2 or 3 days. Then from 6,000 to 11,000, again, this again has increased exponentially over here. So this was an interesting analysis of the number of confirmed cases and number of deaths in Maharashtra. Now, similarly, we are going to do that with respect to the state of Kerala. So this time from the entire data set, we will be extracting only those records where the state is equal to Kerala. And I'll store the object in Kerala. Let me print this out. So as you see, the first case in Kerala was on 30th of January. But from 30th of January till 17th of July, the number of cases is 10,275. This is very interesting, isn't it? So the first case in Maharashtra was 2nd of March. So from 9th of March actually. So from 9th of March till 17th of July, this is an insane amount of cases. But when you compare that with the number of cases in Kerala, from 30th of January till 17th of July, the number of cases are only 10,275. So it seems that Kerala has somehow managed to, if not flatten, at least maybe dumb down, at least, make sure that the growth is not as fast as in other states. So I have two interesting analogies. One, we have Maharashtra, where we have maximum number of cases. Then we have Kerala, which seems to have, somehow, or maybe we need to give proper credit over there to the folks to the citizens of Kerala who've taken proper measures to ensure that the disease does not spread. Now we're going to do a similar analysis of the number of confirmed cases over here. So I'm going to use SNS.LinePlot, where I'll be mapping date column onto the x-axis, the number of confirmed cases onto the y-axis. The color is green again. So here from, this is February. So it seems that from February of 2020 till June of 2020, the number of cases is less than 2,000 till June of 2020. Right, so but from June of 2020 till July, so in just a span of 1 month or maybe 2 months, again the cases have increased to 8,000. So in 4 months, so from February till June, in these 4 months, the number of cases were only 2,000. But from June to July, in a span of the last 2 months, the number of confirmed cases have increased from 2,000 to 10,000. So that's 4 times increase in the last 2 months when you compare it to the last 4 months. So it again seems that, Kerala again has to maybe impose another lockdown to ensure that this does not spread. Kerala has managed till at least the month of June, so that the cases does not spread, but the cases somehow seems to increase because maybe folks from other states are coming into Kerala and proper checks have to be done. So this was about the number of confirmed cases. Now we will also have a similar line plot with respect to the number of deaths. So we've got date onto the x-axis and we've got number of deaths onto the y-axis. And again, the data is for the Kerala dataset, which we have just created. So this is sort of a bizarre line over here. Till the month of maybe April, so till the starting of April, you did not have any deaths. And this sort of maybe you had like 2 or 3 deaths over here. Again, maybe 2 or 3 deaths in a span of 2 months. But from, as you see, June till July. So again, till June, the number of deaths were below 5. But starting from or below 10, you can say. But from starting from June till July, the number of deaths increased from 10 to more than 35. I'll just zoom this over here so that you can analyze this properly. So this was an analysis about Kerala. So now we've analyzed this. So we'll just analyze one more state over here. So we have analyzed the state of Maharashtra. We have analyzed the state of Kerala. Now we are going to analyze the state of Jammu and Kashmir. So here df.state, I am extracting all of those records where the state is equal to Jammu and Kashmir, and I am storing this in the object called as JK. Now, as you see over here, in Jammu and Kashmir, it seems that the first confirmed case was on 9th of March, and as of 17th July, the number of cases are 12,156. So from 9th of March till 13th of March, you just had one confirmed case. And on 17th of July, you had 12,000 cases in Jammu and Kashmir. Now we will go ahead and make a line plot for this. So we will map the date column onto the x-axis. We will have the number of confirmed cases onto the y-axis, and we'll set the color of the line to be equal to green. And the data on which I'm making the line plot is obviously this JNK dataset, which I've just created over here. And as you see, from 22nd of March till, we can maybe either take this particular point over here till from 22nd March till 1st of June, the cases are not much. It's, from 0 to 4,000. But from 1st of June till 22nd of July. So in just last maybe couple of months, so in couple of months time, the cases have increased from 4,000 to 12,000. So as you see, from March to June, in 3 months, the number of cases were 4,000. But the next 2 months, the cases have doubled. So this again is interesting over here. First 3 months, it was only 4,000 cases. Last 2 months, it is 8,000 cases over here. Now we'll also see the number of deaths in Jammu and Kashmir over here. So line plot, date goes onto the x-axis, deaths go onto the y-axis over here. So again, maybe we can take this particular point over here, which would be around, let's say 15th of June. Till 15th of June, we can say there were 50 deaths, exactly 50 deaths if I'm not wrong. But from 15th of June till 17th of July, we've got 150 cases more. So again, the first 3 months, only 50 deaths, but the last 2 months itself, there were 150 more deaths in Jammu and Kashmir. So it's time that most of the states, so it seems that the last 2 months have been very critical in India. Even so Maharashtra, we already know they are already increasing exponentially. But even if you look at states such as Kerala and Jammu and Kashmir, it seems that till the month of June, they were able to properly contain the spread of COVID-19. But from the month of mid-June or maybe starting of July, even the states which had properly controlled, seems like even in those states, the virus is spreading rapidly. So maybe the government needs to take a quick decision and ensure that there is a lockdown again throughout India to ensure that, this does not spread again. So government has to take in also the economic factors as well. So that would depend on, that would again lead to a lot of economic loss. So that is something which the government has to think. So now that we have done this, what we'll do is we will go ahead and look at the number of tests done by these states. So till now we have looked at the number of confirmed cases, number of deaths, and number of cured cases. Now we'll see the number of tests being conducted by different states. So I have another data set over here called as state-wise testing details.csv, and I'll go ahead and store this in this object called as tests. So I have all of these different states over here, starting alphabetically from Andaman and Nicobar Islands, going till West Bengal. And these are the number of samples, or these are the number of tests done by the different states. So on 17th of March, Andaman and Nicobar had conducted 1,403 tests, out of which 12 were found out to be positive. Similarly, as of 16th of July, West Bengal has conducted 663,000 tests, and out of them 36,000 cases came out to be positive over here. Now Again, from this entire data, I'd want to see only the dates of 15th July, which is 4 days back. Today is 19th of July. I'd want to test the dates of 15th of July. So wherever the date is 15th of July, I'll extract that and I'll store it in this object called as test latest. Now, we've got all of these different states starting from Andaman Nicobar going till West Bengal again, and the date is 15th of July. And as you see, you have the total number of samples, which is basically the total number of tests conducted by all of these different states over here. Now, what I'll do is, again, I'll go ahead and sort this data set with respect to the number of tests conducted by these states. So, by total samples is number of tests conducted by the state, and I'll set ascending to be equal to false because I want the maximum number of tests done to be at the top, and I'll store this in an object called as max test state, and I'll just print it out. I'll click on run. And as you guys see over here, so Tamil Nadu has conducted the most number of tests. So even though the maximum number of cases were in Maharashtra, so in Maharashtra we had 2,80,000 cases. In Maharashtra we have 2,80,000 cases, but the total number of tests done are 14 lakhs over here. But as you see, so it seems that this is interesting if you guys see this properly. So if Maharashtra does more number of tests, it is very likely that there are more, there would be more positive cases in Maharashtra. Now, if you look at this, similarly in Tamil Nadu, there have been 17 lakh tests. Out of the 17 lakh tests, 1,50,000 were found out to be positive over here. Then we've got Uttar Pradesh. Uttar Pradesh had conducted 12,77,000 tests, out of which 41,000 came to be positive. Then we have Andhra Pradesh, which has again conducted 12,17,000 tests, out of which 35,000 came positive. So we've got, then we have Rajasthan, then we have Karnataka. So in Rajasthan, there have been 11 lakh tests, out of which 26,000 came to be positive. Then again, so if you look at this over here, so this again for Karnataka is really interesting. So Karnataka has done 90,000 tests, out of which 47,000 came out to be positive, which is almost half of it. So again, it seems that Karnataka needs to amp up the number of tests, which, to ensure. So again, it seems that there might be cases where people are not reporting. So it seems that out of the 90,000, almost half or more than half people have tested positive. It might also be that there would be more cases in Karnataka actually. Now that we've done this, again I'll go ahead and make a bar plot for this. So this time I'll be mapping state onto the x-axis, the total samples onto the y-axis, and this would go from 0 to 5. I would want the first 5 records over here, and I'll set the color of the bars to be equal to state, and I'll go ahead and print this out. Now, as you see over here, the maximum number of tests have been done by Tamil Nadu, closely followed by Maharashtra. Then we've got UP, AP, and Rajasthan. So this was all about the basic visualization and basic analysis on top of this data set. Going ahead, we'll build a linear regression algorithm to predict the future number of cases in Maharashtra. So here you'd have to understand this is a very, very basic algorithm. So this is just a prototype which we'll be sort of building. Right, so someone has pointed that it's 9 lakh tests. So sorry, I had read it wrong. It's not 90,000. It's actually 9 lakh tests. So sorry for that. So we are done with the analysis part. Now it's time to go ahead and build the linear regression algorithm on top of our data set. So this time from sklearn.model selection, we are importing train test split. So this would help us to divide our data into training and testing set. Now, once we do that, we will be building the linear regression algorithm on top of the Maharashtra dataset, which I have just created earlier. And on this Maharashtra dataset, we have this date column, which you see. So I'd have to convert this date column into ordinal. Ordinal is basically numbers, because if I have to build a linear regression algorithm, then the linear regression algorithm can't be used on top of date columns. It would require a numerical entity. So that is why I would have to convert this date column to ordinal column. So what I'm going to do is maha date, which is this particular column, and I'm going to convert all of the values in this column to ordinal. And I will store it in this, I'll store it back to the same column over here, and then I'll have a glance at the first 5 records. Now, if you look at this, you see that the dates over here, so this is 9th of March till 13th of March, those dates have been converted to ordinal numbers. So that date has been changed to this particular number over here, which is 737493. Similarly, the next date has been changed to the ordinal number 737494, and this goes on. Now, after doing this, we will have to create a dependent variable and independent variable. And since we want to predict the number of confirmed cases, the confirmed column would be our dependent variable and the date column would be our independent variable. So the date column will store in this X object, the confirmed column will store in the Y object. I'll click on this. Now, once this is done, I'd have to split the data set into training and testing set. So I'll just use this particular method over here, train test split, which I just imported from Scikit-Learn. And in this, I'll pass X and Y, which are my dependent and independent values. And I'll set the test size to be equal to 0.3, which would mean that 30% of the records would go into the test set and 70% of the records would go into the training set. And this would give us 4 objects: X train, X test, Y train, and Y test. X train is the training set of the independent values. X test is the testing set of the independent values. Y train is the training set of the dependent values. Y test is the testing set of the dependent values. Now again, I'll click on run. Then finally, we would have to implement the linear regression algorithm. So I'll be importing linear regression from sklearn.linear model, and then we will go ahead and create an object out of this. So linear regression, I'll create an object, I'll store it in this object called as LR. Now, what happens is this X train and Y train which you see, those are actually present in the form of they're actually in the form of series object. Let me just print out X train over here and show it how it looks like. So this, what you see, is actually a series object or maybe even a Pandas Dataframe where you have index values. Similarly, I'll have a Y train over here. And as you see, along with the values over here, again, I have the index values. But I don't want these index values when I'm fitting this linear regression model. So I'd have to use np.array method and convert these into single dimension. So that is why I'll use np.array, I'll pass X train and I'll reshape it to -1 and 1, which means instead of having 2 dimensions where I have index along with the values, I want only the values. And similarly, I'll do the same thing for Y train as well. So I have successfully fit the model. Now let me look at the the tail of this, which is basically so here 737623. So let me go back 737623. So that would be maybe let's just go back over here. So maybe that would be 17th of July over here. Now let's just go ahead and so 623 would be 17th of July if we add 7 more to it. So 17th of July plus 7 would be 24th of July. So let's say if we want to know the number of cases on 24th of July, I would have to use lr.predict. Now you would have to note that we have converted the date column into ordinal values. So here, when I'm passing 737630, so this 737630 would actually indicate the date of 24th July over here. So 23 is 17th of July. When I give in 30th, this would mean this is 14th of July. And when I click on run, this will give me the number of confirmed cases as of 24th of July, and it tells us that there will be 188,409 cases. But we already know this is incorrect because on 17 July itself, we had 284,000 cases. But this model is telling us that on 24th of July, we'll have 188,000 cases. So as you guys see, we would need to build a much better model, which would give us the correct guess or maybe even the correct estimate of the number of cases which we will have maybe in the next few weeks or next few months. So this what I built is a very basic prototype of linear regression which has given us a random number. Now all of the folks who are new to machine learning or new to data science need to know that when we build these algorithms, it's not necessary that whatever result you get is actually correct. And to be honest, whatever result you get, 90% of the times or more than 90% of the times, the result which you get is incorrect. So that is why data is very important, and reiterating or rebuilding of these models is also very important. So this is something which you'd have to work on as a machine learning engineer or as a data scientist.
So, let's start with quickly understanding the evolution of computers. When the computers were created, they were created as calculating machines for mathematicians and bookkeepers. Then it evolved to understanding programming languages so that it can understand instructions, human instructions. But now it has evolved to incorporating human-like intelligence as well as creativity. Mimicking human-like intelligence is nothing but artificial intelligence. And artificial intelligence combined with creativity is nothing but generative AI. So, let me make you understand with a very simple example what is generative AI. Transport yourself back to your childhood. You had a lot of toys to play with. You would keep that toys in one box. Now, also imagine that if you wanted some toy which is different, you would not get in the market. But what if I tell you that this box is a magical box? And if you input your understanding of what you want in your new toy with instructions, it can create a new toy for you, which is not available in the market. Now, this toy can be a bear with unicorn features and wings. What if it generates for you? This magical box generates a toy which is very unique for you. This magical box is nothing but generative AI. Generative AI actually is not a magic, it's a fast and rapidly evolving artificial intelligence system which creates, generates, transforms content that can be text, video, audio, image, etc. based on your input. So, if we want to understand it technically, generative AI or Gen AI functions by employing a neural network to analyze data patterns and generates new content based on those patterns. Neural networks are nothing but a mimicry or a replication of your biological neuron based on how it gets from brain, the activity from brain, and you do your work. It's nothing but a mimicry of that. Based on that mimicry, it analyzes data patterns and generates new content for you. Let's now quickly see what is the difference between discriminative and generative AI. Suppose you have a data set of different images of dogs, cats. You provide this as an input to your discriminative AI, which acts like a judge, and it classifies all this into set of images between cats and dogs. This is discriminative AI. It classifies. Now let's understand what is generative AI. You have the similar set of cats and dogs, but now your generative AI is acting like an artist. It creates a new species of dogs for you. That's why generative AI is nothing but AI system that transforms, creates, generates your own content based on your instructions like an artist. Now that you have understood what is discriminative AI and what is generative AI and what is the difference between the two, let's understand why is generative AI or Gen AI trending. Gen AI has impacted various fields, be it text, audio, video, any input, and those inputs in various domains like data, management, tech, healthcare, and entertainment. It has creative applications such as DALL-E, ChatGPT, where you can input what you want and get output from it. For example, if you want to create an image, what you think or perceive as a concept and you want it, you give a prompt for your generative AI model and it will create that image for you. So your input is a text, but your output is an image. That's why it's trending. It does not depend how traditional AI is dependent on what form of input you give. The same form would be your output. However, Gen AI works on your inputs, on your instructions. That's why it's trending. It is impacting a lot of fields, be it creative field, be it research field, be it business. Professionals are using tools like ChatGPT to create or generate code so that they can create something new. The researchers are actually developing new and new large language models based on which we can create new generative models and can do new and new tasks each and every day. That's why generative AI is evolving rapidly, and that's why is close to magic for everyone. Now that you have understood why it is trending, now let's understand how it works. We give an input to generative models. Gen AI works on generative models. We give an input, it can be text, audio, video, any format. Those generative models are then pre-trained on the data and they are fine-tuned to do the task that you want. It can be text summarization, it can be sentiment analysis, it can be image generation, it can be audio generation for your YouTube channel, or analyzing your customer feedback if you are a brand or a marketing firm. It can create codes, whatever you want. You give a prompt what you want, explaining it that what you want, and it fine-tunes and gives you that task for you. So this is how, in nutshell, generative AI model works. So now let's see what are the different types of generative AI. First one is Generative Adversarial Network, GANs. It's a type of AI where two models, one generating the content and one judging it, work together to produce realistic new data. Second is Variational Autoencoders. This AI learns to recreate and generate new similar data. Third is Transformers. Transformers is an AI which learns to produce sequences using context. Fourth is Diffusion Model, which generates data by refining noisy starting until it looks realistic. Now that you have understood what are the different types of generative AI, let's quickly walk through different applications of generative AI. First one is content generation. It creates, it generates whatever textual or any code that you want. Customer support and engagement. If you are a brand firm, it helps you with that. Data analysis and data science. It helps with visualization. It helps with analyzing any data. Be it any data you want. You are a brand firm or you are a technology firm. It will help you analyze your data and create new automated tasks for you. Or it would create new perceptions for you to take over. Then it is code generation and software development. We have research and information retrieval as well, where it helps different researchers, it helps different professionals to grow and retrieve extract information required from different or various data sources. Then we have machine translation. If you are a person who do not understand a language and you're watching something or reading something which is in different language, you can use generative models to translate text or audio or anything into the language that you require. Then we have sentiment analysis, which actually takes feedbacks or any text that you have to give you. Is it a positive, negative, or neutral sentiment? And so that you can analyze and take decisive decisions. Other domains here include healthcare, transport, everywhere it helps. Generative models, generative AI is helping each and every domain in their perspective, how they are applying this technology change in their domain. So let's now quickly conclude what we have learned in this video. We learned AI is a superset. We have a subset called machine learning, which trains your machines to do what you want. But the machines need your input. Deep learning is a subset of machine learning which incorporates neural networks which mimics your neurons so that it can imitate human intelligence. Then comes generative AI, which involves creativity, introduces creativity in artificial intelligence system. Then comes large language models. Large language models are basic bits that you will learn in our upcoming videos, so stay tuned. Just before we conclude, let me tell you different generative AI tools which are in the market and which you can explore. Some of it are ChatGPT by OpenAI, Claude by Anthropic AI, Copilot by GitHub, Gemini by Google. You can go and explore the world. However, stay tuned to our channel so that you can learn more about generative AI, large language models, prompt engineering, and several different buzzwords that are there in the system.
Hello learners, today we're going to understand about data analysis, but not through a normal usual process. We're going to understand how to use ChatGPT to analyze the data. So let's get started. First, our agenda would be introduction to data analysis, then difference between ChatGPT 3.5 and GPT-4, applying Python codes to analyze a data set, and then applying Excel commands to analyze a data set on which we're going to analyze the whole data. Now we'll start understanding the introduction to data analysis. What is data analysis is? So data analysis is a method of inspecting, cleaning, transforming, and modeling data to discover useful information, conclusion, and support decision making. There are various steps that comes under data analysis process, such as first is data collection, second is data cleaning and pre-processing, third one would be exploratory data analysis, then data transformation, and then model building, after that evaluation, and then at last interpretation. So next we're going to understand difference between GPT 3.5 and GPT-4. Now why I'm discussing about difference between both version, because we're going to apply the data analysis process. We're going to understand data analysis process using GPT-4, which is the latest version of ChatGPT. And before we start working on that, we should understand why we are not working on 3.5. That is an older version of ChatGPT. So there are few differences between 3.5, ChatGPT 3.5 and 4. First difference is that ChatGPT 4 is multi-model and has more processing power compared to ChatGPT 3.5. Now what it is? So the major limitation of ChatGPT 3.5 was that it was unimodal. Now what is unimodal is? In the sense of chatbot, only understand and interpret text input. In ChatGPT 4, you will be able to apply more advanced features, such as you can upload the images, you can upload the whole data set, and you can basically upload images there. So not even text, but you can apply more advanced features using ChatGPT 4, so which we cannot do in 3.5. Second one is ChatGPT is more accurate than ChatGPT 3.5. So in terms of accuracy also, that ChatGPT 4 version working more correctly than 3.5. ChatGPT 4 can solve various problems and equations in subject as varied as calculus, geometry and algebra. ChatGPT 3.5 on the other hand can only give us the direction, like how to solve the problem, and rather than providing the actual solution there. So that's why we follow nowadays ChatGPT 4, which work better than ChatGPT 3.5. So here you can see two options, GPT 3.5 and GPT 4. So basically GPT 3.5, here if you want to upload a data set, it's not possible because we do not have the upload file option. You can ask ChatGPT if you have any question, if you want to analyze the data, you can ask like by using text only. But in GPT-4, you are getting an option to upload file. So here first we're going to upload the data set on which we're going to perform data, and then based on that we'll ask ChatGPT-4 using some prompts. So let's get it started. So after uploading the data set, we're going to understand how to load the data, what is the process of data analysis. As we discussed earlier, that there are various steps that should cover under data analysis. We'll understand those steps step by step first, and then we'll move to the final analysis of the data set. Basically, that is Car-MPG over here. So for that, first we'll ask ChatGPT that what are the steps that should be covered in data analysis by using a prompt. So when I enter the prompt over here, that is what are the various steps to analyze the data, you can see that the ChatGPT-4 will show you all the steps that should be covered during the analysis process. So first is understanding the problem statement. Then after data loading, then after exploratory data analysis, that is data exploration and understanding, that has subtopics as well, which we'll discuss. And then after data cleaning, feature engineering, and data visualization. So these all are the steps that should come under data analysis process. Let's understand the first step, understanding the problem statement. So understanding the problem statement is what? Basically, you have to understand what you will achieve from the analysis. So first you have to understand the data, like how many columns do you have in the data, how many rows do you have in your data is all about what. Second is data loading. So load the data into suitable structure to begin the analysis. Then after data exploration and understanding, that covers summary, that cover missing values, that cover duplicacy as well, like if duplicate values are there, that we have to remove. Then univariate analysis, bivariate analysis. Now what all are these basically? First is data summary, that in this we'll get a summary of the data to understand its structure, type and basic statistic. So basically it's about to understand the whole structure of data set on which we're going to analyze. So it covers basically how many rows do you have in the data set, how many columns do you have in the data set, and the mean of the columns and the median of the column, the standard deviation, because these all are very important factors that should be covered during analysis. Second step is missing values. So basically this missing value, basically what is about to check if there are any missing values are present in the data. If missing values are there, you will not get the clarity at the end of prediction, at the end of modeling the data. After modeling the data, you will not get the exact output. You will not get the exact prediction. So missing values should not be there. If missing values are there, for that we will follow another process that we'll discuss later. After that comes univariate analysis. But before that, I want to add one more point over here, which we are not getting in this, but that should be what? Duplicacy. So if suppose in a column, we have duplicate data, same data, but there should not be duplicate. Okay, that should be different. So in that case, we have to impute that duplicate rows as well. So that also we will check. And then after we come to univariate analysis, analyzing single variable, basically analyzing each column, each variable that comes under univariate. For that, we have a lot of charts through which we can analyze. And then after bivariate analysis, using different plots, we can analyze the bivariate analysis, which is basically what? Analyzing the relationship between two variables. So if you are analyzing a single variable, for an example, a single column, okay, like name. If you want to analyze the name of the cars, okay, different cars we have, suppose in the Car-MPG dataset. If you want to analyze how many cars we have, and suppose if you want to understand that miles per gallon, like that particular column, what we will going to see after this. So single variable, if you want to analyze, that will come under univariate. If you want to compare between two variables, if you want to check the relationship between two variables, in that case, we'll follow the bivariate analysis. For that also, we have various plots through which we can perform this analysis. Next step is data cleaning. So basically, data cleaning is what? Data cleaning, same. If you have some missing value, if you have some duplicate values, so we have to clean the data, because once you will clean the data, then only you will be able to get the correct prediction. Then only you will be able to model the data, and you can model the data, but the thing is you will not be able to get the correct prediction based on that modeling of data. So here, before the data modeling, we have to clean the data properly. So here, first step comes handling missing values, imputing or removing missing value. Either you can remove or you can impute with average value, mode, or median. So basically here it depends on the data. The values, if they are very important, if we cannot remove those values, then there we have to impute with some other values. And if it is okay to remove those missing values, then we can remove. And it depends on the dataset what we are using there, and the values are very important. So we will keep that and we'll impute those missing values with some other statistical value basically. Next is outlier treatment. Identifying and treating outliers if necessary. So basically what is outlier over here? The value which is completely different if we compare with other rest of values. So here if some outliers are there, so that also we have to treat. So the next point in data cleaning is data transformation. So data transformation is what? Converting data into required format. Now what is this basically? Here data transformation, when we require this, for an example, if you have a column with the name, the name should be in the form of string data type, correct? But if the data type of that particular column is an integer, so basically the data type of that column is integer, then obviously we should change that to string. So if the data is not into the required format, so there we have to transform that data. So these three steps actually comes under data cleaning process. After that, we'll do feature engineering, creating new features that might help in analysis of modeling, that will understand properly when we perform these steps. Then after comes data visualization. So in that, we'll visualize the data using various charts. As I said earlier, univariate analysis, bivariate analysis. So that actually these analysis we generally perform through visualization by visualizing different various plot, and here visualization distribution using histogram bar chart we can do, and visualization relationship that we can do using scatterplot correlation matrices. So here univariate analysis we can perform through histogram bar chart, and if you want to understand the relationship between two variables, basically that we call bivariate analysis, so that you can do, that you can perform using the scatter plot, using heat map, also using correlation matrices. Now the next step comes statistical analysis, performing a statistical test to understand relationship, significance, etc. Model building is the next step. There we will build predictive model using machine learning or statistical methods. So basically it depends on the data, like which type of data you are using. So based on that, we'll use relevant model. So next is interpretation. After modeling the data, we'll get the predictions, we'll get the final output. And based on that, we're going to interpret basically the conclusion. What is the end result of the whole process what we have performed. Then after, report and communicate findings, basically presenting the finding in a clear and understandable manner to stakeholder, basically is like to whom you will going to report that whole analysis. So to them, it should be very clear, because you know the data analysis might be possible that person to whom you will going to show that complete picture, they might not understand the process what you have followed. So you have to present in a very clear and in a very precise manner, basically the outcome. So these all are the process which comes under data analysis, and we will follow this process and step by step we'll understand how to perform this. So now the next step is, as we have already discussed about the process, like how to perform data analysis, all the steps we have understood. We'll perform those steps one by one. And the first under that process is how to load the data set, and we'll understand about the whole data what we will going to analyze. Before we do that, first we'll click on upload file, and then we'll upload the data set. So here our data set is Car-MPG. We don't know as of now what is basically this Car-MPG and what is all about. After uploading the data set, we're going to understand by using the prompt. We're going to ask ChatGPT a few prompts. Based on that, we'll get an output. So first prompt we're going to enter over here is, so as you can see here, we have uploaded the data set. Now we'll understand about this data first. So before that, we're going to enter a prompt. Here we are giving a prompt. The prompt is basically what we want to know through ChatGPT, what we want to understand through ChatGPT. Here we are asking that load the Car-MPG data set which we have uploaded and display the first 10 rows. What information is contained in this data set? So let's enter this and let's see what output we'll get over here. So you can see that we are getting the Python code also here, and you can see here that using this head function, we are getting the output. And parallelly, we are getting the information of all the variables which we have in the required data set, that is Car-MPG. So first is what we have asked. We have asked to load the data set. So ChatGPT will load the data set, and we were asking over here that display the first 10 rows. So by using this head function, the output will be here, will show you the 10 starting rows of the data. So we are getting the starting 10 rows. Simultaneously, we'll apply this code in Jupyter also, that whether we'll get the correct output in Jupyter Notebook or not. So that also we will check. But as of now, first we'll discuss what we are getting as an output over here. So now, as we can see, we are getting starting 10 rows. Now we're going to understand the whole data set. So this complete Car-MPG data set is having 10 columns, 10 variables basically. First is MPG, miles per gallon, that is fuel efficiency. Then after cylinder, that is CYL, number of cylinders in the engine. Then after this, that is engine displacement, which is in cubic inches. Then HP, that is horsepower. Then WT, that is weight of the car, which is in pounds. After that, ACC, that is acceleration, second required to reach 60 mph. Next is YR, that is model year, as a 2-digit number, example 72, 1970. Basically 1970 over here, it would be 70. So next is origin, that is origin code. It might represent different region or countries. Then after car type, that is type of car for which we are doing this analysis. So type of car, example 0 might represent one category and 1 might represent another. Car name, the last variable, that is name of the car, which basically include make and model. Now, this data set could be used for various analysis, such as understanding the relationship between fuel efficiency and other attributes, or classify car based on their characteristics. Here, what we will going to understand, we're going to understand the relationship between fuel efficiency and other attributes. Okay, so let's try this code in Jupyter as well. Let's see that whether we are getting the output there or not. So when we copy this code, you can copy directly from here as well. When you click over here, it will get copied, and then you can paste this code in Jupyter Notebook. So you can see I have already pasted the code. I have uploaded the data set over here. I have given the data set name, which should be in CSV format over here, because we are using the command read_CSV. So if you are uploading the data set, which is with the extension of CSV, then there you have to use this command, that is pd.read_CSV. And then you can see that we are getting all these column names over here. Now, the next is over here, you can see that we want to check the starting first rows. So what code for that? So basically here we have this code, that Car-MPG underscore data dot head. So when I paste over here that code, let's see what outcome we'll get over here. So here we are getting what? First is this one, that whatever the code we have at last, computer will display that only. So here the last code is .head function we are giving, and based on that we are getting starting 10 rows, because head function is basically give starting 10 rows. If you want to see more rows, just enter the value inside the bracket. So if I want to check let's say 20 rows, so if I enter this, here I am getting 0 to 90, that means 20 rows data. So head function is basically what? To display the number of rows based on the value what you are giving inside the parenthesis. Now, next is what? So next is to display the data type of all the variables from the above data set, because we want to know the type of the data which we are using in the data set. So for that, we'll ask ChatGPT by using this prompt. You can give any prompt as per your ease. So as of now, I am giving over here that display the data type of all the variables from the above data set. So when we enter this prompt, we'll get some output. So let's see what we are getting over here as an output. I'm getting the code also, which is in Python, car_mpg_data, which is the data frame name, and .dtype. Dtypes is the function basically used to understand or used to get the output based on data type. So you can see here we are getting the result that first variable is of float, another is of integer, another one is again float, one is of object, that is HP, that is horsepower, then after weight is of integer data type, and so on. So here you are getting a complete explanation also, and the data type of the variable in the Car-MPG data set are as follows. So here we are getting all these complete explanation. What next ChatGPT is showing here is, it's worth nothing that HP column is of type object, which might indicate some irregularities in the data, such as missing value or non-numeric entries. If we need to perform numerical analysis on this column, we have to clean and convert it to the numeric data type. Now, why we are getting this? Because if you want to perform analysis, and if the analysis is numeric based, so in that case, we have to convert that. And if you are converting a variable into some other data type, before that you have to check whether we have missing values or not. So for that, we will going to apply some other code there, and let's see what output we'll get at that stage. As of now, we are skipping this part because any which ways we're going to check whether we have missing values or not. And during that process, we'll check this column as well to understand whether how to impute the missing values or not. So yeah, here we are checking all the columns, and simultaneously we are checking the type of the data. So this is the final output. If I apply this code in Jupyter Notebook, let's see whether we are getting a correct output or not. So already we have over here this code. I'll paste it over here. When I will run this code, so after applying this code, we can see that we are getting the output. And here what we are getting as an output, we are getting all the type of the datas based on the code which we have given here. So MPG is float data type, cylinder is of integer data type, same HP is of object data type, and so on. So yeah, this is correct. And as of now, whatever we are getting code through ChatGPT showing the correct output. Now let's understand the next step. So now the next step is, if you want to check is there any duplicate rows. So that is also a very important step during analysis. Duplicacy should not be there, missing value should not be there. So as a prompt I am giving here, display the duplicate rows from the above dataset using Python. Why we are specifically mentioned over here Python? Because we want Python code as of now. So that's why we are specifically mentioned here using Python. When I enter this code, I am getting some output. Let's see what output we are getting. Okay, so as a code, what we are getting over here, that finding basically here, first we have to create a variable, obviously. So the name of the variable in which the output will get stored is duplicate underscore rows. And we are getting the code over here that from the data, Car-MPG data, get the duplicate values. So for that, we are using here duplicated function. You can see one parenthesis over here. So if a parenthesis is there, that means that is a function. So with duplicated, we have a parenthesis. That means duplicated is a function which we are applying on the data, and that basically take out all the duplicate values. We'll show you complete duplicate values, whatever we have, whatever duplicate values are present in the data set. So when it will get stored to duplicate underscore rows, then we will call that variable and we'll get the output. As an output here, what we are getting, that empty data frame. Columns are these many columns, whatever we have already in the data set. And as an interpretation, as a final result, what ChatGPT is showing here, that the Car-MPG dataset doesn't contain any duplicate rows. All the entries in the dataset are unique. There is no duplicacy. So we can go ahead with this dataset as of now. If you have any specific questions, so you can ask. So now I really want to check whether we are getting the same output when I apply the same code in the Jupyter. So when I copy this code, I'll paste over here. Let's see what output we'll get. So there is nothing. Basically, we do not have any duplicate rows. Okay. Let's go ahead with other step, and we'll apply one more prompt here. Now the next prompt I'll give over here is display the categorical and continuous variable in the dataset using Python. Why? Because I want to know that how many categorical variables do we have here, how many continuous variables do we have here. When I enter this prompt, let's see what output we are getting. Okay, so as we have asked over here that display the categorical and continuous variable in the dataset using Python, we are not asking what is categorical and continuous, but still we are getting output based on the explanation that ChatGPT is giving over here is that categorical variable are those that can take on one of limited set of values representing categories or labels, while continuous can take on an infinite set of values within a range. Based on the data type and the nature of the variable, we can identify categorical and continuous variable. So categorical variables are basically what? Variables that are typically integer or object type and represent discrete categories. And continuous is basically what? Which are typically float type and represent continuous measurement. So now here you can see the code based on the prompt what we have entered. So categorical variable ChatGPT has created in which we are storing the output, and output based on what? That select data type include object int. So we are asking if the values are of object and integer, store that column names in this variable, that is categorical variable. If the variables are of float data type, then store those column names in the form of list, because here you can see that we are giving a code that to list. So basically the columns will convert to list, and that will get stored where in continuous variable basically. Okay, so now here removing the column that are known to be continuous but are represented as integer, that is year. So the categorical variable dot remove year from the list. Now when we display, when we ask a categorical variable and continuous variable, what we'll get as an output? This is the output. So based on the data type and context, categorical variables are these many are the categorical variables, and these three are continuous variable. Because based on continuous and categorical, we'll perform the data analysis. Let's apply this code once and let's see what output we are getting in Jupyter Notebook. Okay, so first is categorical. So first list is based on categorical variable. The another one we are asking here continuous variable. So the another list is what? Of continuous variable. So we are getting a correct output over here. Let's understand the next part of data analysis. Whether do we have missing values in the data set or not? Or if we have, then how to impute that missing values? Because if we have missing values, that will impact the final outcome. So if you have missing values in your data set, so you have to impute those missing values with some other values. Like how, that we'll understand after this. Okay, so the next one is plot the distribution of the origin variable. How does the origin affect the other feature in the data set? Let's understand this also. When I enter this prompt, we are getting an output. The origin variable in the data set is likely a categorical variable representing different region or countries of origin for the cars. We can visualize its distribution using a bar plot to show the frequency of each category. Once we have an understanding of the distribution, we can further explore how the origin affects other features in the data set. Like why we are using this feature overall in the data set and how it is affecting. So this is the bar chart and showing the distribution of car origin. So 1, 2, 3, as we have three values in the origin variable, and first is 1, others 2 and 3, and the frequency here we are getting as on y-axis. So the bar plot above shows the distribution of the origin variable in the Car-MPG dataset, and it appears that the three values are there and with the name 1 followed by origin 3 and origin 2. So origin 1 has higher frequency, then origin 3, and then after origin 2. Let's explore how the origin affects other feature in the dataset by summarizing some key statistic for numerical variables, and how we'll understand that. There is complete explanation. We'll come back to this code also. So now here you can see we have applied mean function, and we actually want to know how this variable is impacting. Okay, what is the importance on other variables? So MPG origin 3 has highest value fuel per efficiency, so miles per gallon. So origin 3 has the highest mean value, followed by origin 2 and origin 1. So highest will be origin 3. This suggests that the cars which are from the origin 3 are generally more fuel efficient. If the cars are from origin 2, so they are comparatively with origin 3 less efficient, and the origin 1 has the least value. So the cars which are from the origin 1 comparatively with origin 3 and 2 have less fuel efficient cars. Okay, so next is cylinder, displacement and horsepower. So cars from origin 1 have high range value, and other one is car from origin 2 and 3 have a smaller engine with few cylinders and lower horsepower. That's how this origin is important for understanding the other features. Based on different origin, we have different values of each column, and that we are getting through this summary. So how we are getting this summary? By using this code. When we apply this code, group by origin.mean function. Mean function will give the mean value of origin, and column wise, the other column wise, here you can see MPG of origin 1 is 20, cylinder is 6.2. So the highest value of miles per gallon is for origin 3, then after 2, and then after 1. We have already discussed what does it mean. Let's copy this code from here and apply, and just check that whether we are getting the output. Yes, we are getting the correct output, what we were getting through ChatGPT, and that's how we can understand that the distribution of the origin variable and how this variable affect the other features in the dataset and the importance of this variable. So thank you. So now we're going to understand whether do we have missing values in the dataset or not. So for that, first we'll ask ChatGPT by using this prompt that identify and handle any missing values in the Car-MPG data, and how did you choose to handle them and why. Let's see what output we'll get over here. So we are getting an output. I want to know what code ChatGPT will display over here for that if we have missing values. Okay. So now let's understand this part first. To handle missing values, we first need to identify whether they are in the dataset or not. Once we have found them, we can decide on an appropriate method to handle them based on the context of the data. If we can remove those missing values and if it will not impact the whole data set, like because of removing the values from the data, if it is not impacting the main data set, then we can remove. But if we remove the missing values related rows and if it impact the data set, then there we have to use some process that is called imputing the missing values, and that can be done by using some relevant code. But here first is what common strategies we have for this type of issues is removing rows that I already discussed, that deleting rows with missing values if they are few in number and if they are not impacting, like if we remove the values and they are not impacting the main data set, then we can remove. Filling with mean and median. So filling missing values with the mean or median value of the column suitable for continuous variable. Next is filling with mode. Filling missing values with the mode most frequent value of the column suitable for categorical variable. Using interpolation, interpolating values based on surrounding data suitable for time series or order data. So basically here what we do if missing values are there and if we do not want to remove those rows which contain the missing values, so we'll impute those missing values with mean, median or mode value and then we can proceed further. Here let's understand whether do we have the missing values in our data set or not. So for that we have a code over here, missing values summary equal to Car-MPG data.isNull. IsNull is the main function to check whether do we have any missing values or not. Suppose if we have 5 missing values in one column, so that will get sum up by using sum function, and the final total number of values for a particular column will get displayed as an output. That will store in this variable which we have created over here, and when we call this variable we'll get the final output. So this is the main code. Based on that, what ChatGPT is showing over here as a result is 0. Means we do not have any missing values in the columns. It appears that there are no missing values in the Car-MPG dataset as indicated by the summary above. However, we previously noticed that horsepower, that is HP column, has an object data type which might indicate some irregularities in the data such as non-numeric entries. So let's investigate this column to see if there are any unusual values that need to be handled. So we have already discussed about this column, that column is of object data type. This column also we have to check that whether this column has a missing value or not. If this column has a missing value, so we have to work on it. So the code related with this is this one, same. And if in the object data type any missing values is there, so we'll impute those values. So here as an output, we are getting a question mark is there in the column. That means that particular row doesn't have any value. Those rows have only question mark instead of any appropriate value. It seems that HP column contains some question mark, that character which likely represent missing or unknown values. These values are not recognized as null or NaN. So we need to handle them. Given that here what we are getting is in output that HP is a numerical variable representing horsepower. Obviously, horsepower basically should be a numerical value, but a common approach is to replace them unknown values with the median value of the column. So let's proceed with replacing the character with HP column with the median value of the known horsepower values. So how to convert? See, first is this column is of object data type, but in general, we know that horsepower should be of numerical because the values are in numbers. And if we have any column which showing numeric values, but the data type is different, so there we have to convert that column with the correct data type. So we have already done over here with apply function. Okay. Next is, this is the complete code. What we are doing over here is, we are imputing the missing values with the median value. So when we do that, then after in HP also we are getting 0 because now we have filled those unknown rows or missing rows with median values of HP, and because of that we are now having no missing values present in the data set. The missing values in the HP column have been successfully handled. And how it got handled? With the median value of the known horsepower values. That median, mean, mode, how we get these values, that we'll understand after this. So now there are no missing values or unknown values in the Car-MPG dataset. Now I chose to handle the missing values in this way because here ChatGPT is giving the reason also, that why ChatGPT chose to handle missing values in this way, because replacing with the median preserve the central tendency of the HP distribution. The median is less sensitive to outliers. Basically, outliers are which is very different from the main values what we have in the column. Let's say HP only. So if we suppose have A, B, C, D, E values in one column, all of a sudden if we are giving their Z, right? So that is very far from the continuous series what we have in the column, right? So that Z will consider as an outlier. So here the median is less sensitive to outliers. So it provides a more robust estimate for filling in missing values. Since horsepower is a continuous variable, using the median is a suitable method for imputing missing values. So that's how we can impute, but again, we're going to check whether based on this code we are getting the correct output in Jupyter Notebook also. So let's copy this code first. I'll copy and I'll paste it here. So now, here we are getting the output based on this code that we have missing values, and that missing value basically what in rows we have some values with this type of character, which is not a value, which is not anything. It is completely unknown value. And now we have to impute this. So based on this type of character, we'll not get a correct prediction. So the next code for that is to impute this value. So when I paste here, we'll run this code. We are checking that missing values after handling. This variable contain all the column names from the data set, and will show you whether we have any missing values left or not. So here we are getting all the names of the column, and parallelly we are getting over here the number of values if missing values are there. So no, there is no missing value because we are getting as an output 0. This is the output what we were getting in the ChatGPT also. So That's how we can impute the missing values if we have any values which is unknown in the data set, and how to impute that we have already discussed. We'll now move ahead with another step. So let's understand the new step for data analysis. So now we have covered till now univariate analysis, bivariate analysis. We have seen that summary statistics, and we have checked that what data set is all about. Everything we have discussed till now. Now we're going to apply a model on the data set to predict the fuel efficiency. So here I'm using a prompt using the Car-MPG data, build a regression model to predict fuel efficiency. What feature did you include and how well does the model perform? When I enter this prompt, as I'm going to building a model on my data set to predict the fuel efficiency. So building a regression model to predict fuel efficiency involves selecting features. So before we discuss the regression model over here, we'll ask ChatGPT that why we are using here regression model. Okay, when I enter this, I'll get some output. Let's discuss that also. Regression model are used to understand and quantify the relationship between dependent and one or more independent variables. So one would be target variable on which we're going to do the prediction. So here, which one is the target variable, which one is the independent variable, that also we'll discuss. Now we are using here regression model because of some reasons. First is nature of the dependent variable, that is MPG. MPG is the target variable. We're going to predict the fuel efficiency over here. So that is the target variable. The target variable MPG is a continuous numerical variable. Regression model are designed to predict continuous outcome, making them a suitable choice of this problem. Now, exploration of relationship. That regression model allow us to explore the relationship between target and features, quantify how changes in features like weight, horsepower, cylinder affect fuel efficiency. So this is the best model to predict the final outcome based on the target variable. So these all are the reasons. In summary, basically why we are using regression is for the Car-MPG data set, that with the nature of the problem, the characteristic of the data and the goal of the analysis or prediction, it provides a statistical framework for understanding how various features of car influences the fuel efficiency, offering both exploratory insight and predictive capability. So in short, we can say that as the variable is continuous variable, so in this case we should use the regression model. That is the best model through which we will get the correct prediction based on our data set. Now we're going back and understand the output which we are getting through this prompt using the Car-MPG data, build a regression model. Building a regression model, here you can see that how many features we have selected. We'll consider the following feature, and these all are the independent variables, and one would be the target, that is MPG over here. This feature include various aspects, okay, and which influence actually the fuel efficiency, that means the target variable. These all are the independent variables, and they actually somewhere or somehow they are influencing the main target variable. That's why they all are comes under independent, and the target variable would be then MPG. Data pre-processing, after that we're going to split the data into features and target. Means one would be X and the other target would be Y. We're going to split that target variable from the independent variables and then further divide it into training and testing set. Then we're going to build the model. So we'll use a linear regression model, a common choice for predicting a continuous outcome variable. As we have already discussed this, let's start. How we're going to do that? There is a code for that. There are required libraries which you have to import first. Then only you will be able to split the data into training and testing, and you will be able to modeling the data set. So this is the complete code for that, and based on that we are getting this result. Now the thing is, we'll discuss this code step by step. we have imported all the required libraries as we are using linear regression model. So we have to import linear regression model from this sklearn.linear model library. Then after train and test split, why we are importing this? Because we're going to split the data into target and the independent variable. Then after from sklearn.matrix, we're going to import mean squared error and R2 square, because we'll check the accuracy of the model. So here we have splitted the data set into X and Y. X will contain all the independent variable and Y will contain the target variable. And then we'll split these data, and after that we're going to create and training the linear regression model. So we will apply this linear regression function. We'll store that in the model variable, and on this model variable we're going to fit the X train and Y train. Y train has the target variable value and X train will have the independent variable values. Here the Y-pred variable consists the testing set on which we're going to predict. So this is all about how to apply the code, what to do to get the final prediction, and at last we're going to calculate the performance metrics, that how this model performed, and that we can understand by using MSE and R square values, and we are getting the final output. Let's discuss one by one the final result. Mean squared error is 7.25 and R square is 0.8652. So what is the interpretation based on this model? The mean squared error is what? Represent the average square difference between the actual and the predicted variable. The trend data set X train and Y train has actual values and predicted values what? Based on test. So a lower MSE indicate a better result, better fit of the data, and MSE of 7.25 means that on average the model predictions are off by the square root of this value and approximately 2.69 mpg. R squared over here is what? Is a measure of how well the model's prediction match the actual data. Means what actual data we have, if it is getting matched with the prediction, how well it is getting matched. So it's based on while we check the R squared value. Here the value is 0.8652, that is 86.5%. So that approximately is what? The variation in MPG explained by the selected feature. So this is the R squared, this is MSE, we have already discussed. Conclusion is what? The model shows a relatively good fit to the data. If you are getting higher value of R squared by 86%, that means your model performed well. And feature includes what? Cylinder, displacement, and these all are the features. Based on that we were predicting the target. We already know, that is MPG. The model could be further improved and validated through techniques such as cross validation and all, if you want to improve your model more. As of now, by seeing these values, R squared, the performance matrix, we can come to the conclusion that the model shows a relatively good fit to the data, explaining a significant portion of the variation in fuel efficiency. So this is all about the modeling of data, and we have discussed this part, but through ChatGPT we were discussing. Let's apply this code in Jupyter Notebook, and let's see that the output what we are getting here is same in Jupyter Notebook also. So when I enter this, I'm getting the same output, and this is the final output. Here also you can compare, right? So this is all about the data analysis of the Car-MPG data set. One more prompt I'm going to enter here. You can see, analyze the feature importance in the regression model. What features have the most influence on fuel efficiency and why? So based on the interpretation, if you want to know that which feature is having the importance and which actually somewhere influencing the fuel efficiency, which one has the highest value based on that influence. So we're going to check this by using this prompt, that analyze the importance of features. And how we're going to do that? Feature importance, basically we generally check just to understand the prediction what we are getting there, which particular feature or which features having more impact on the target variable. So here, if you can see the code, feature importance, pd.dataframe, we are giving feature and coefficient values. One column would be of feature and another would be of coefficient. This coefficient, by seeing this value, we can understand, okay, this feature has the highest impact and this feature is actually influencing our target variable more. So out of all these, we can see that the table above shows the coefficient of each feature in linear regression model reflecting their influence on fuel efficiency, that is MPG column. So car type is the most influential feature over here with a positive coefficient 5.82, which indicate that the car with the higher value are associated with high fuel efficiency. So this value is somewhere influencing this MPG variable more. Then after comes 1.49 coefficient, that is of cylinder, and then origin, and the least is weight, a small negative influence indicating that heavy car tends to have slightly low fuel efficiency. So this has the negative influence. So why we want to check the importance of features? Because we should understand that which feature has high impact on the target variable. And the conclusion over here is the feature car type, cylinder, origin and year seem to have the most significant influence on the fuel efficiency, and based on that we can work. And the interpretation of this coefficient should be done with caution, as the nature of the variable, potential multicollinearity and other factor can affect the coefficient. So this is the final analysis, that features in our data set, how they are impacting the main target variable. And this is the way we can analyze the data. And the last step we're going to perform now, we're going to apply this code also in Jupyter to check whether we are getting the correct output or not. When I enter this, the output what we are getting here in ChatGPT, we are getting here also. So that's how you can analyze your data, whatever you want to analyze. You can easily do that by using ChatGPT. It's so easy to understand because you are getting the code also, and you can see that I was parallelly applying the same code in Jupyter and I was getting the correct output there also. So it's very easy to understand, and with that it's very easy to get the complete explanation also here. If suppose somewhere if you stuck that what is the meaning of particular function or a particular code, that also you can easily understand using ChatGPT. So it actually make your data analysis process easy and very understandable. So that's how we can analyze the data using ChatGPT. Parallelly, you can apply this code what you are getting through ChatGPT in other notebook like Colab or Jupyter, just to check whether you are getting the correct output or not. And one thing I can add over here is we should play around with ChatGPT. Like we can explore more also here. These all are the steps of data analysis using Python. And if you want to know more concept based on the output what we are getting, that also you can explore by asking or by applying or by adding prompts in the ChatGPT. That makes your data analysis journey more easy. So yeah, this is all about how to analyze the data using Python code through ChatGPT. Thank you. So now, as we were continuously discussing about missing values, how to impute missing values, with median we have to impute, or we should impute with mode or mean. What is all about like mean, median, mode, what is these values are. So we'll understand this by using this prompt, we'll get to know. So the prompt which I'm going to enter over here is display the Python code for summary statistic for the numerical variables in the Car-MPG dataset in a tabular format. What insight can you gain from this statistic? So let's see what is summary statistic is. Here, as we are getting the output, so we can use describe method in Pandas to obtain summary statistic for the numerical variable in the Car-MPG dataset. This method will provide us with the count, mean, standard deviation, minimum 25th quartile, median 75th quartile, that is Q3, and maximum for each numerical variable. I know it's a bit confusing for you, but we'll understand these all terms step by step. Here we are getting the code to get the summary statistic. but we do not know what is basically summary statistic is. So that we'll ask first to the ChatGPT, and then we'll come back to this part. We are getting the complete output based on the prompt which we entered over there. But let's understand first what is summary statistic is. So we'll ask ChatGPT that explain summary statistic. So now, first we'll understand all the terms what I was saying here, that mean, median, mode, standard deviation and all. Summary statistic, we'll understand this part and then we'll go back to that code. So here, summary statistic provide a concise description of the main aspect of the data set, particularly for numerical variables. Obviously, because if you want to check the mean of the column, it should be a numeric value. Then only you will get the mean, median or mode. So this help in understanding the distribution, central tendency and dispersion of the data. Such a heavy term. So we'll understand this first. What is central tendency? What is dispersion of the data? What next we are getting over? Let's see that also first. So the commonly used summary statistics are count, which will count what? The total number of non-null observation in the data set. It helps in understanding the size of the data set and identifying any missing values. Mean, the arithmetic average. Median is the middle value that is specify the higher half from the lower half of the data set. Now the next is standard deviation, a measure of the dispersion or spread of the values. A high standard deviation indicate greater variability, while a low standard deviation indicates that the value are closer to the mean. Minimum, the smallest value in the data set. Maximum, the largest value of the data set. Data set basically will show you like for each column. Now the percentile. This percentile will divide into three parts: 25th, 50 and 75. 50 is basically what? This one. The 25th percentile, that is Q1, is the value below which 25% of the observations fall. And 75th percentile, that is Q2, in which the value below which 75% of the observation fall. And in between, we check the median value, that is 50%. So now the range is the next one, the difference between the maximum and the minimum value. That is called an idea of the spread of the data, like how the data is spread. Next is interquartile range, that is IQR. It is also a difference. So what is this? Basically the difference between 75th and 25th percentile value, representing the range within which the middle, that is 50% of the value, falls. It is a robust measure of spread that is non-affected by outliers. Next is mode, the value that appears most frequently in the data set. This mode median we have already studied in mathematics. Same meaning is over here also. Next is variance. Variance is the average of the square difference from the mean. It's another measure of dispersion. With the higher value indicate greater variability. Variance means what? That also you can ask if you're still confused. So you can simply just ask, explain in detail. So we'll give over here as a prompt that explain variance in detail. When I enter this, here I'll get what? Variance is a statistical measure that describes the spread of a set of data points within the data set. It quantifies how far individual number in the data set are from the average and thus provide insight into the overall variability of the data. So how we calculate, that is another thing, but here basically we'll get all these values in the summary statistic. So now let's go back to the code, and here we are getting the output. We are getting the output for each column. We are getting count, we are getting mean. Count is basically the sum, okay? Count means total value basically. Here count is what? Let's understand this. What ChatGPT is showing the total number, okay, of non-null observation in the data set. So now here we have count, mean, standard deviation, min 25%, 50%, 75, that is Q1, and 75 is Q3, max value, minimum value, and so on, right? So let's understand this particular code, that whether it's giving correct output in Jupyter Notebook or not. When I will enter this here, I'm getting the complete summary. This is the complete summary, that is the complete statistic of our data set, which is showing the minimum value, minimum or maximum value, min, that is average, standard deviation, like how the data is deviated. So these all are the statistic. Next is why we always check this. As you know that we have one column over here, that is HP. So when we were checking the missing values, we found that this column has some missing values, and we cannot remove those rows because will impact the data set if we remove. So what we did there, we imputed with median, right? So by seeing this statistic, we can come to the conclusion that like with which value we can impute those missing values. So there we imputed the missing values with median. We can impute with average value, that is mean also, or median as well. Now, as of now, we have discussed the statistical summary of the data set. Now let's understand the next step, which comes under data analysis. So this is the summary statistic. Now we'll check what output we are getting here in terms of explanation. So first column is MPG, ranges from 9 to 46.6 MPG. The average fuel efficiency is around this, that is mean value. Standard deviation is 7.8, indicating the variability in the data set. Same, there might be some high fuel efficient cars, and the maximum value of this particular column is 46.6. Same, we are getting the interpretations based on the other columns, that is cylinder, displacement, horsepower, weight, acceleration, year. So now here is origin also we have, which is a very important column, and we have horsepower is also an important column. So we can see that we are getting fair enough outcome based on the prompt which we have given over here for ChatGPT, and we are getting the correct output as well because we have already checked in Jupyter Notebook. So let's understand the next step that comes under data analysis. Thank you. So now we'll understand how all the variables are correlated with each other by using correlation matrix. So when I give this prompt that create a correlation matrix for the Car-MPG data, will show you the relationship between all the variables, because that also we have to understand when we increase one variable, that what is the impact on other variables, how they all are correlated with each other. When I enter this prompt, let's see what output we are getting here. So here first is correlation matrix, provide a numerical summary of the linear relationship between pair of variables. It contains correlation coefficient that range from -1 to 1, -1 indicating a negative linear relationship, 1 indicating a perfect positive. Basically, when we are getting the graph in upward direction, basically that means that is positive linear relationship. Negative means that because of 1, the other values is getting decreased. 0 indicating that there is no relationship between the variables. So when I check the code over here to get the correlation matrix, there is a function which we have to apply on the data set. The function name is over here is CORR, that is core function, which will give you the complete summary, of what? Of how all the variables are related with each other. And you can see that we are getting over here the result, and the result is that first MPG and this year, these are related with 0.57, negative basically if like yearly this value is getting decreased. So let's understand this complete statistic, whatever summary we are getting here through ChatGPT, MPG and engine characteristic. So here you can see this is the complete relationship, and let's understand step by step. MPG and cylinder, strong negative correlation, which means that MPG and the cylinder variables are negatively correlated. More cylinders associated with low fuel efficiency. MPG and displacement, strong again negative correlation, which means large value of displacement leads to lower fuel efficiency. MPG and horsepower, again the strong negative correlation, which means high value of HP column associated with the low value of MPG, that is fuel efficiency. Same when we compare MPG and weight, strong negative correlation. Heavier car tends to have low fuel efficiency. Means the weight of a car, if it is high, if it is more, so that will tend to low fuel efficiency. So the value of MPG will get decrease. So that is why here the correlation is strongly negative. Next is cylinder displacement, horsepower and weight. These variables are strongly positive correlated with each other. Because of one variable, the other variable is getting increase. So more cylinders typically means large displacement, will give high horsepower and greater weight. Acceleration and other variables, negative correlation. Acceleration and MPG has positive correlation. Cars with faster acceleration tends to be more fuel efficient. Then after air and MPG, moderate positive correlation, because here you can see the value is 0.58. So these all are text based analysis, right? What if we want to see this through a chart, like how to visualize this correlation matrix through chart? So let's ask the ChatGPT itself, like how to visualize this correlation matrix, and how we're going to ask this. So now if we want to visualize this summary statistic, which is coming in the form of numbers, if I want to visualize using a chart, I don't know which chart I should use over here to visualize the whole data. So I'll ask ChatGPT itself that visualize the above output of correlation matrix using an appropriate chart. Let's see what outcome we'll get over here. So for visualizing the correlation matrix, heat map is the best chart, and it's the best way to visualize. So here you can see that heat map is an excellent way to visualize correlation matrix, as it allows us to quickly identify the strength and the direction of the relationship, whether it is negative or positive correlation, and whether correlation is there or not, so that we can easily understand. And stronger correlation will have more intense color, with positive correlation typically shown in one color, example over here is blue, and negative correlation in another. So let's see what output we'll get over here. So this is the code to generate the heat map, and this is the output based on that code. So you can see that this is the final correlation matrix using heat map. The heat map above visualizing the correlation matrix for the Car-MPG dataset, providing basic understanding of the relationship between all the variables. And you can see that if I compare this cylinder and car type, negative correlation. If I compare cylinder variable, or let's say MPG, so if I compare MPG variable with cylinder, again it is a negative correlation. And let's see which one is the positive one. So the positive one is this one, origin and car type. It is positively correlated. And if the color code is dark, that means they are highly correlated, either negative or positive. If the color code is light, so they are correlated but not strongly correlated. So here you can see that HP and this disp. So here it is related, how it is correlated, 0.9 with 0.9. So there is a high correlation. So that's how we can understand the correlation matrix. We can visualize the correlation matrix using heat map. So this is one way to visualize correlation matrix. Let's apply this code. Let's understand this code when we paste this in Jupyter Notebook, and we'll see whether we'll get a correct output or not. So when I copied this code over here, I'll enter and let's see whether we are getting the output. Okay, we are getting an error. Correlation matrix. Okay, so here it's showing an error. Why? Because we are calling here directly the variable correlation matrix. We are giving as a variable over here based on which variable you want to display the heat map, and I'm giving here correlation matrix. Correlation matrix computer here, the notebook is not getting any variable with the name correlation matrix. So first we have to check the previous code. Here you can see that we have stored all that correlation summary, that is statistic, in this variable which we were not defining in the notebook. So obviously we will not get an output. So first I will copy this code. When I'll copy and paste over here, then we'll sure get an output. Let's see. So here first, by using this correlation function, that is CORR, we'll store the complete statistic correlation matrix in this variable, and when we call this variable in heat map, so we'll get the complete chart based on the correlation matrix of our data set. So this is the complete output what we are getting over here. That means the code what ChatGPT is generating is giving a correct output.